Knight says,
Hey everyone, Mike Guy T.
Hello again, this time with a working microphone, hopefully. Thanks, Knight, for the for pinging me. So let's start again. This is a stream where we write Automat. Automat is a game automation app that can record button sequences and mouse movement sequences. When I play this back, it can move my mouse for me. Okay, my hands are here, and you can see that the timeline is playing. It has a loop in there, and it's moving my mouse down the screen. This mouse trace that you can see here, it's actually fairly detailed. It has like tons of events being sent. So yeah, we're playing fairly high fidelity mouse recordings. The point of Automat is to automatically play through boring and time-wasting games. Not all of games are boring and time-wasting, but even if they are not, they sometimes employ some mechanisms which are just annoying and which could be automated. So this is what is the purpose, raison d'être of Automat. Now, today we are going to do two things. We are going to first redesign the mouse move object. Initially, I designed it as a turtle because a turtle with a mouse cursor on top of it, because it's a metaphor, a symbol of something that can move the cursor around. And this is inconsistent with the rest of the interface. The metaphor isn't bad, but I think we went a little bit too far with it. I think we would be better off if we... So just using this metaphor of a turtle, it feels like we are burning this on something... We are burning this metaphor into the object, which I don't think it's good. Ideally, I would like to decompose this into a couple different objects that will be more flexible, that they usually will have more power over them. Like, there should be, I think, a general purpose turtle object that could move arbitrary other objects around. And the mouse movement is the icon of the mouse. I chose a mouse pointer because it's the operating system level entity, not the hardware entity. But it's inconsistent with the mouse icon. So we choose to represent it as hardware here and as digital entity here. There is no pixel art in Automat. It just doesn't fit right. So we will redesign it. This will imitate hardware. And I want to redesign this also because I have a better idea of how I would like the mouse object to work. So mouse seems simple, but it actually has a lot of internal complexity within it. There can be multiple mice attached to your system. They can have different physical capabilities and different components of the mouse. If you look at the mouse, you can conceptually divide it into different components like mouse buttons, scroll wheel, the position, sensor on the bottom. And those different elements of the mouse within Automat, they will be represented as separate objects that refer to its master mouse object. So right now we have those procedural mouse button down and mouse button up objects. And they take signal, they perform action, and they continue. This is one way to decompose this. Another way to decompose the pressing action is here in the key press button. This button is something that I can... Oh, it pressed the button, it's just pressed it too well. So there is also the possibility of representing a button as an individual object that can be switched on and off. And this is what those key pressers do. And we have to fix that crash. We should not have crashes in Automat. At this point, it's not the time to have crashes anymore. So the central mouse object that we will have, that's going to replace all four of them, is going to serve as a source for creating new adapters that provide access into the mouse object that follows some interface. So we will have, for example, a mouse button object that will follow the on-off interface that can be switched off and on. When it's on, that means the button is active. Also, within the mouse button we will have those elementary actions that press it up and down. And the same goes for mouse movement. For mouse movement we will have an object like this one that can move the mouse around by receiving the positional relative input. And we will also have objects that can move the mouse by 1 pixel up, down, left, right. And the same for scrolling. It's actually funny because the primitive operation that is used under the hood is closest to this one. So this is the most faithful to how the operating system works. So this is how it really works under the hood. But on top of this, we can provide those nice interfaces. Those interfaces are never perfect. Like if you look at the event stream, it is possible that the application can receive a sequence of mouse down events without a mouse up in between. So the same button can be pressed repeatedly without being released. It's possible for the application to get this. So I think when we will be implementing stuff, we'll have to actually pay attention to always provide those kind of adapters first, and then use those to build higher level interfaces around them. Yeah. It's actually funny, I could create even a table of stuff that we have and that we would still want to have.
Plutonia83 just followed on Twitch.
Hey, thanks for the follow. Okay, actually, it's going to be more convenient here. I think I have to change the font that I'm using. It's me. Quickly change the font. Maybe this one? Josefka config, no. Term. There is something with spacing here. I don't want to waste too much time on this. Josefka fixed it is. So the press and release in mouse is done. We already have objects that can do this. When it comes to keyboard, not really. We don't really have those primitive actions for the keyboard. Then we have the higher level object that represents a button as a whole, which is missing from mouse. So maybe button is always a bad name. This is this single object that can be switched on and off. So if I can maybe change this to, I don't know, let's make it space, and I will connect it to some hotkey. F1. So now I can, by pressing F1, I can press space. So yeah, now space is being pressed, and then now it's released. So this is done here. So we don't have a mouse device object. And we don't have a keyboard object. So this is basically our table of support that we have so far. We also have this mouse movement that we will redesign today, but to make Automat kind of consistent, to make this interface make sense, we'll have to fill this table. I think now that we have implemented a couple of those objects, it's going to be much faster. The initial implementation took a lot of time. I think if we're lucky, maybe in a week or two, we will implement all of those. So this is the plan for the mouse and keyboard objects within Automat. And the conference that we are going to watch once the talks start is... I learned about this from the Future of Coding Slack channel. I recommend joining that Slack channel. futureofcoding.com. The conference seems to be a general software development conference, but I honestly didn't see anything on the first day. On the second day, I only saw the later part of the conference, but it was excellent. Like everything about those presentations was amazing. So I expect a similar level of quality today. There were some technical talks. This about programming vehicles in games. That was more of a devlog of a game developer who kind of tried to implement a faithful, realistic engine simulation. Maybe not so realistic, but sufficiently realistic to be fun. This was an interesting presentation. It was a motivational talk about not writing engines, but making games instead, and finishing those games. Oh, there was another one apparently before. This one was very cool. This one was about a very specific problem within audio mixing, where you want to align several tracks from different microphones, which can be offset in phase. And I watched this, and honestly, I would probably do those things differently. I mean, it got me thinking. It's definitely a fun presentation, and it really motivates you to think about those problems. And audio, I mean, I keep saying audio is big, and we are not touching audio very much in Automat. We are touching audio, but the primitive level of audio that we have in Automat is something that has to be addressed. I would like Automat to kind of make sound as it executes, a subtle sound, a controllable sound. It's not the point to annoy the user, but it should be an extra communication channel. It should tell you what's happening behind the scenes. For example, this mouse movement, we could actually play some micro samples when the mouse is being moved to give the feedback to the user about mouse moving on screen. Okay, mouse. So the point of the stream today is to redesign. We are going to do two things. Thing one, we are going to fire up Flux, the AI image generator, and try to push it to generate us a nice skeuomorphic mouse image. So we'll do some drawing, some AI assisted collage. And then we will move it to Automat. And I would like to actually add some kind of interactivity to this widget so that it's not as boring as, just simple block that receives signals. I want the mouse to have a small display, and on this display it will show the track of the mouse movement.
Nakings says,
I, my friend, question how hard you think would be to do a proto-universe on Python. I think I just did one. I used oscillators and Kuramoto model.
Yeah, Python is actually excellent place to do those kind of simulations because it has NumPy, and NumPy it's probably faster than if you would do the same thing in C or C++. It sounds counterintuitive, but NumPy implementation is very optimized, and yeah, it's a pretty fun project to simulate on this very low level. I mean, I love this idea not only because it's just fun, but also it's my favorite approach for game design. So the best types of games that I know are simulators that allow you to control the simulation, but in a very limited sense, so that you try to push the simulation in some direction to achieve the objectives of the game. Games like Dwarf Fortress or Majesty or Black and White, all those games are essentially simulators that just play themselves, and you can push them a little bit.
2D grid of phase, oscillator 0, two that interact via SYN, like a spatial Kuramoto model. Each node evolves based on local interactions, stores memory, and has mutable physical laws coupling drag, field strength. Over time, stable loops emerge particles. Local time dilates relativity. Laws mutate evolving physics, and nodes replicate emergent life. All structure, motion, and matter emerge from oscillator dynamics. I will do it free and open source. GitHub.
Yeah, I can show you something really cool. I have this... Let me open all of them. Stubs. Which one was this?
Oh, thank you for knowledge.
Nakings just followed on Twitch.
Hey, thanks for the follow. This URL. I have to copy it over, or yeah. So it's not as low level as you want to implement. The guy who implemented this probably have this environment, and I should be able to draw barriers here. How was... Space? No. Oh yeah, sketch barrier. So I can draw some kind of barriers. Those are mirrors that reflect wave, and the wave imitates... the wave follows some quantum properties that waves have. So it has diffraction, interference. It scatters when it goes through narrow openings. This simulation doesn't really give rise to quantum objects, because quantum objects, to appear, I think they need some kind of more rules about like charge preservation, spin preservation, and so on. This is just a soup of photons. And it's also very smooth. I like this wave simulation.
Interesting this is how could be. Am not a programmer, I was looking quantum physics knowledge. And asked ChatGPT to help me with the code done.
Yeah, it's an ambitious task, and I think it's fun. I think it could be gamified to some degree. You know, there are those games where you control a liquid that attacks other liquids on the board. I think there could be a game located in the quantum realm that follows the possibly accurate quantum physics. Yeah. Oh, and this other blog was a nice introduction to wave simulation, but I guess you already have some idea of how to do that.
Merhabalbu says,
Hello. Do you mind if I ask a couple of questions?
Hey, not at all. Go ahead.
One King says,
I'm so grateful, haha. I didn't expect it, someone already did. These. This is cool.
Yeah, it's a nice simulation, but it doesn't have the elements that you mentioned. It doesn't have those... I mean... It's a good baseline, but on top of this, there has to be something... So the simulation is not 100% physically accurate, it just looks nice. I mean, looking nice is... It could be turned into a nice game, I think. Simulation. Or it could be improved, maybe could be made more physics, more faithful to physics. Mouse. Okay, this is our mouse object. That's what we started with and how we iterated. And this is the Automat's mouse object, current. Let me see if Krita can open... XCF. No, it cannot. I will have to export it somehow.
I will upload the code tomorrow on GitHub for free, open source, and you can remix it or make it better if you want. And even if tomorrow I can give you the hub.
Nice. Sounds like a fun project. Okay, I don't need shadow, I don't need zones.
Have a good one, my friend. I will go to sleep. Ha ha.
Merhabalbu says,
I am 14 and aspire to be a game developer. I have started with learning Python since it is a beginner-friendly language. Where should I go next?
Python's good. The natural next step for Python is C and C++. This one. So if you want to go, I mean, honestly, Python is like, It really depends what's your end goal. If you want to be a professional programmer, then you should learn as many languages as you can, really. So you should jump between them. And the weirdest languages, the weirder the language, the better. But if you want to do something with this, with Python, then there is really no need to learn extra languages. Python is good enough. It's the most popular language, I think, after JavaScript on the planet. There is plenty of high-quality libraries in Python. So if you want to learn other languages, I guess C and C++ would be natural. They're synergized with Python, so you can use C and C++ to write extensions for Python, like a high-performance primitives that you can then use within Python. If you want to do something on the web, then maybe JavaScript. It really depends where you want to take it. But Python is fine for almost everything. There are very few things that cannot be done with Python. Okay. Who is the conference? Seem to be starting. So the person who's speaking is Sander Skjegstad. He was presenting yesterday. So I think this is some kind of introduction.
Warm applause for the king of the conference, Sam H. Smith.
Okay, so I should mention that I did one, full practice of this before the conference, and then I made a very crucial mistake. I decided I have conference duties, so this is okay, but I'll hone this later, during the conference. I'll find some time. There was no time, so this is the practice run.
Increase the volume a little.
Passing without ASTs, optimizing with sea of nodes. What's the story here? Well, as some of you may know, I make this crazy operating system thing where I didn't want to use C, and so, this is self-hosting compiler stuff. It's kind of crazy. And last year, 1.5 years ago something, I'd actually sort of released the project. So real people got real physical devices running my software, and we're expecting updates. And the reasonable thing would have been to just work on the updates, for the OS. But then John and Casey did a stream, right? This one, which this is from me, Philip, and Sander. We're in Norway living together, watching on multiple screens, as you do. See there, I'm eating a sandwich. And in that, they asked, they talk about parsing, and this thing came up. Okay, trees are slow. This is in reference to ASTs. Can you make a compiler without ASTs? It's like an offhand thing. I got very nerd sniped by this. I started thinking about this, and then that's why people didn't receive OS updates for a couple months. So the answer to this question could just be yes, right? Because TCC exists. That's a one-pass compiler. One-pass compiler is just like plow through the source code and emit something. But how does that work? Because I tried to read the TCC code, and it was very hard to look at. So what is the principle here? And then once I'd done parsing without trees...
Yeah, I was actually thinking there are trees there because there are expressions and statements. Actually, no, not necessarily.
Because if you haven't thought about optimizing compilers before,
expression can be resolved using a stack without building a tree in memory.
So this is what we're going to go through. We're going to talk about parsing without trees, then we're going to do a version of basic codegen, because you can't really understand the first without the second, kind of. And then at the end, we're going to talk about sea of nodes, and I'm trying to convey the mental model to you. This is it's a very like draw the rest of the owl talk. The owl is very big, and so I'm showing you lots of like small pictures. And to me, they all make sense and fit together. But to me, I've seen the owl, so please interrupt if something is confusing, and then I'll explain more.
The TCC approach that he mentioned is slightly...
This term, who knows?
It's like super surface level code emitting. You just go through the source and immediately basically emit machine code as you encounter operations.
Very small. So we're
when you have expressions, you just put the expression on stack, and as you kind of resolve the parse tree, you immediately dump the machine code out.
So you have some util functions. Peak token gives you an enum and a slice into a file that you loaded. And then you have some way to consume in advance. You can have more things, but this is the basic setup. So we load our file into memory, as you do to be fast. We initialize by you want to consume one token. So we have a cursor that it's really basic, this stuff. We look at the bytes and we see, guys, it's an if statement. You move the cursor and then we store in like a cache slot the enum for that token. So if you call peak token, you get hey, this is an if token right now we're on. And then the reason we cache it is because you call peak a lot more than you consume, because you're frequently checking this. So you get a performance speed up for this. If you want to peak multiple tokens, maybe you'd run the cursor further ahead. Anyway, so if we call consume, we advance of a white space, we look at this, we go, that's some kind of symbol, so symbol enum. And we just continue this process. Again, we are grouping characters. It's not hard. And it's definitely not called lexical analysis. Pro tip, group these at this stage if you can, because if you don't group and, you'll get weird bugs, which maybe seem fine, which is and space and also means and I did this. It's a bad move. And also you have to peak more tokens, which makes things annoying. And also, notably, in this scheme, we don't produce any data. We have a character buffer and we're moving through it and transiently looking at some subsection and then forgetting as we go what was behind us. And what this means is we can't go back. There's no like reverse function on this thing. So we need to support, and this we'll come back to why we need this later. We need a rewind to a save point. So you get a save point, you just save the state of whatever this code is. It's a little struct. Save the location, and then you can obviously just reset your tokenizer to this location in the source file, and if you call next, you'll get the same tokens back. Remember this. This is what mine looks like. It's in Latin. Okay, ignore that. This also does stuff like conditional compilation, which is why it's got more state tracking. We won't be talking about that. This is just an example. This one only does peak one token. Question? Okay, there's no more Latin after this, okay? It is, true. Can somebody get this man a prize? So that's character grouping, which really is just, it's just some helpful util functions for us to look at the, we're sort of, slightly stepping back from the exact details of the source file to the things we care about. There are these two problems with parsing without trees. Well, this one happens either way, the first one. The second one happens when we try to do no trees, the foreknowledge problem. This is my name for a thing that I think I discovered. But so we're going to talk about the first one, and that'll be mostly kind of the shortest possible.
I sometimes wonder how nice would programming be if we
but a little bit more pointed,
always parsed expressions from the left to right without operator precedence.
We have some tokens at the top.
I guess fourth is like that.
And we want to pass this expression. We can do this. This is what I call a loop parser or a go left parser. Because you see this tree here, which direction does it go? Left. So when we loop over this, we hit the pass S64 at the top, we get the 1. We loop, we keep peaking until we get to the end, consuming, I see a plus, so we consume the plus, and then we add another pass S64 to our accumulator. In this example, you might find it weird that we are just computing a number from this. We're going to do other things later, but I want to be getting us in the mood of not emitting trees, right? So we're just calculating this as we go. So anyway, this moves over the expression in this loop fashion till we get to the end, and then we get the answer. There's this version, which is, can somebody guess what this parser is called? Can I get a hand? Come on, guys, this is not. It goes right. And it's also recursive. So this is the recursive parser where, we, at the end here, we call parse expression. So we have some, stack frame that gets the 1 internally, then the plus, and then we have each sub-expression like this. And at some point, we hit the floor and then start returning back up. Now, this expression. So note that here we had all pluses. It's kind of an easy case. It doesn't matter. Here, we need to start caring about operator precedence, which is if we just naively pass this, we'll get operators in the wrong order, and that's bad. So let's see here. So the way this works is we're going to run the go right recursive parser. So I've tried to visualize the stack frames here. We go down, and then we get to this plus. Now, if you guys remember, any maths class, you know that the plus is not supposed to, it's not supposed to be 3 plus 4. The 3 is associated with the times 2 here. So, here, if we continue doing the recursive parser, we'll get this wrong, because we'll just do a right tree like this. We want to somehow look at this plus and, make a decision here. So what we do is, you remember in the recursive parser, we had this parse expression. We're going to add a member. This is a real cool trick. We add what the thing was from the parent. So this is the, hey, in this case, we're just saying what we pass in the token of the above operator. And then, guys, it's an if statement. We then check on this plus here. We say, hey, I'm plus. The guy above me is times. So I return early. And then you return early to the parent, which will keep doing a loop. So we loop, and then, of course, we have to apply this everywhere. So we get the plus compared to plus, whatever, I don't care. So that just gets passed, and there's our expression. This is the go left sometimes parser, TM. Does not deserve a fancier name than this. This is the code. Look, it is an if statement. This is the return. That's all it is. There's a binary choice here. Wait, is this confusing? This reads like water to me, but does everybody understands this? Okay. So this gets complicated because I'm going to have many if cases for, if it's this operator, whatever. So we just turn this into a precedence level, because generally in languages we want a linear sequence of precedence. You could do the crazy rand int, depending on how many tokens in we are, we'll make some crazy decision for, custom, if it's on even lines, then it will do something different. But it's an if, okay? If we do this, and then if you want, so for operators of the same precedence level, if you want them to be default right or default left, it's this. It's when they're the same, do we return or not? Rocket science. So, okay, any questions? Go left sometimes parser for integer expressions. Great. Oh,
it's really nice.
Now the foreknowledge.
I always go for peg
a,
parsing,
problem statement here,
which is probably overkill.
Which will make sense later. I'm going to define this $ operator, which changes the meaning of all the time symbols to plus. It's a weird example, but it'll make sense in a second. If I wanted to this clicker is bad. We need to get a new one. So I have this 3 times 3 plus 2, we get 11. Okay, easy, that's the thing we already did. If I put $, 3 times 3 plus 2, we get 8. Okay, so you guys understand? This $sign operator changes the meaning and the way we need to interpret something else. And in this case, very easy to implement. Because we can just peek. I mean, again, super advanced here. Hey, is dollar peak token, dollar consume token, dollar is true, pass it in. And then, you can change your logic in the pass. So this is easy. This is, and so the thing that's special about $sign is that it's, our normal arithmetic operators don't change the meaning of other things at a distance. So that's like the special thing about the dollar here that causes the problem. If we change the order, put $sign at the end, now this is a little bit harder. Because remember, our parser is computing the value and doing additions while parsing. So by the time we get to the $sign, we already have the answer 11, but the answer is wrong. So what do we do? And the way, so this is great that Ryan showed something similar for this. The way building an AST avoids this problem is you build your tree such that your visitation order just gives you the thing in the order you wanted, which is $sign affects this expression, and so it's a parent of it. Okay, makes sense to everybody?
I honestly prefer this procedural approach to writing crazy grammars.
We do this instead. Remember the save points? Well, we have these save points. We take a save point on where did the expression start. We call pass expression with false. It's not $. Then if we see one, we just jump back, call pass expression again with true. Okay, which seems almost too basic to be a thing, but this was interesting to figure out. The reason we can do this is because our result here, this is the only side effect of the pass. And of course, it's just an integer, so we can throw it away, get something else. And so these are the two alternatives for doing this style. Is you either have to be able to reverse all the side effects your parser created back to some save point. This is what I do mostly. It sounds hard, but you'll see why it works later for different compiler stuff. Or you can also create a second parser whose only job it is to walk the tokens and find out the future information that you're interested in. If you're making a compiler that needs to, so if it's the first time you're looking at these tokens and they may be wrong because user input, you have to generate the same errors as what your other parser would have done, but you can throw away lots of information. If you know that the thing you're parsing is correct, you know that for a fact, you can do super hacky, no side effect parsers that just look at open parens and scan forward to find something, etc. Okay, so is everybody kind of question?
Is that a real thing that we're going to use, or is that an example?
No, it's an example. It's a very fabricated example so that we don't get confused about other things. Any other question? No, okay. So we're going to start code genning again, showing you pieces of the owl. We're doing basic code gen first. This code is going to look really, really, really dumb. If we have a procedure and it doesn't bring anything, we don't emit anything. Great, awesome. Everybody can write a parser now. If we have a return statement, well, we have something that's trying to pass the scope. It sees the return token. This is the global value number counter. We'll get to that. We see the return. We know, this procedure has a return type. So we're expecting an expression, so we call pass expression. And pass expression sees the 7 and emits a literal 7 into value number 0. Okay, the words are coming in here. So we keep track of how many value numbers we have, and that's just, a value number is just the result of some calculation that we number to keep track of. I mean, I guess you could do like refer to them by string, but that sounds dumb. So yeah, here we go. This is kind of the code. You know, we have parse expression. Parse expression returns some like bag of value numbers because you need to support wide types, like returning a struct, and you know, a value number roughly correlates to a register on your target. And then, you know, I do string types, which people make fun of me for, but actually I think that's super cool. Because then you can just string compare, is it the same type or not? So, anyway. This makes sense to everybody that we did this. Oh yeah, this is what the stack is gonna look like. We're gonna have some variables like you guys expect. We're also, because we don't want to do register allocation just yet, we're just gonna store all the value numbers in stack memory from some offset. Like I said, this is gonna get dumb. So then, of course, we return from the pass on the 7. We get back to the return. The code for return can say, hey, he gave me value number 0. Guess what? I'm gonna emit return 0. This is not assembly. This is like a mix between assembly code, machine code, your special IR byte code. This thing on the left could be any of those. Okay, everybody with me so far? We returned a number. We're going to declare a variable. Now, variables in this version of the compiler, a variable is what? How do people think about variables? Do you think of a variable as a name binding to a previous computation, or a place on the stack that is named? A place, exactly. This is the C model, and we'll see. It's interesting why that is the case. By the end of the talk, I hope everybody doesn't say place. You say name for the previous output of a computation. So anyway, so we have this variable table, and currently our variable table just stores these. We're going to append variables here, and we're just storing what is the offset on the stack of this variable. Because again, here you guys are correct. A variable is a place. If we want to return myvar, you know, get some UB in here. So, you know, our parse expression now looks at the myvar, and this is kind of crucial here. So I talked about this foreknowledge problem. Here we are avoiding it through some trickery, which we'll get to, which is myvar will produce a type pointer that's auto-dereferenced, kind of a reference type. So actually the myvar, address of myvar into v0, that happens inside parse expression. And then we return v0. The return looks at the type and says, aha, this is an auto-dereference, so I'm going to emit a load for that. So we get a load into v1, and then we can return v1. And we got, you know, stack space tracking down there. Oh, more complicated example. See, this is getting big, quick. Not very optimized, as you can see. So here we have, you know, we declare myvar. We set myvar to 5. Do I have colors here? There we go. So the way this works is we pass the expression. So the left side in the first thing that's red, the myvar here, is this is a parse expression, right? So we call parse expression. We get this expression that is the pointer. So we emitted that first, the address of myvar into v0. Then we see an equals and go, aha, I'm not loading this pointer. I'm actually wanting to store something into it. And what I'm going to store is going to be the right-hand side of this expression. So then we call parse expression. We get the 5 in v1, and then we return up our code can do the assignment, do the store into the address. And again, see, this is where I'm unclear. To me, I'm like, oh yeah, this is obvious. You guys know what this means, right? But do you know what it means? This is legible? Kind of? Okay. We'll try to continue. This is an example of returning like a string literal. So here we're just producing v0, v1, and then returning that. You should be able to do this in your compiler. If we print, well, we're going to call parse expression, which is going to see a print. Then we hit an open paren. We know, I know that print takes 1 argument. So I'm going to I'm going to call pass expression. I know, super crazy. You know, we can do this with multiple. If you have multiple arguments, you just call pass expression again and again to get the things. Now, here's something interesting for the eagle-eyed among you, is the way we do this parser, where we read through mostly left to right order, we actually got an implicit order of when the expressions are evaluated. So you see here that the string literal happens before the 3, which is interesting. You can do, I believe in C, I'm told that this is actually ambiguous in the spec, so you could just do this. And most compilers actually do the opposite, though, of its right to left for some reason. Is that correct? Do you guys do, in Jai, do you do right to left or left to right? Left to right? Good, smart. Well, who wants right to left? It's like, what? Well, anyway, so,
Sam, can I ask?
Yes, question.
Where does the lit 5 come from? Where's the 5?
The lit 5 is in the length of the string, because we're not C, so we don't do null terminated strings, and neither should you. Right, anyway, yeah, so we can do calls, and you know, they take multiple parameters, whatever. I'm the first person to press the nuke the presentation button. There's on this we have left and right, and just below it there's the button that does that, right? Because it's really well designed. This. Let's see. Okay, parameter. This is interesting. Is in this compiler we're doing here, this example, you're gonna emit some kind of preamble, because remember num is a location on the stack. That's not what it is in whatever calling convention you're doing probably. So here we're going to emit some preamble to just take however we receive this in the calling convention, put that at the correct stack location that we've referred to with num. But yeah, otherwise it works kind of the same, right? Except it's this ugly load from the stack thing here. If statements, conditionals, should be pretty easy. Also, I've done kind of RISC-V-ish assembly here. Do people know what BEQZ is? This is branch equal to 0. So if V1 is 0, then we jump to begin else. Okay. Does this make sense? So we run through the scope. We see an if. We call pass expression to get the conditional. And then we recursively call pass scope just to bind these, to get these zones with these labels. If you output machine code, you have to backpatch this. I don't know, this is a conference of smart programmers. I'm thinking that, you should be able to go like, oh, I could see how I could do this, again, with this linear output. If we have an else, look, we have print goodbye here in the else. Makes sense? This is where I'm unsure. Am I drifting off? Everybody, how are we feeling? Okay, people feel okay. People feel safe, that's important.
I'm a little bit confused by the lack of terminology. I think on the right, we see something like some intermediate representation.
The reason all this works, these loops...
So this is the code we're parsing, this is some intermediate representation, and this is some state that we're using during parsing, I guess.
And we're always doing the stack stores, and that allows us to not think or it allows control flow to just be like naive jumps. And you can think about it, it makes sense why the C model is that all variables are just locations on the stack, because C was invented during an age of primitive compilers where this kind of stuff is the main thing they were doing early on, probably. So let's see. Oh yeah, so for shadowing, what's cool about this, the stack of variables is that if we have a subscope, so if we have on the entry to pass scope, you save the height of this table so that you can pop off afterwards and have shadowing. So you have basically, as we move through the code, the variable declarations move around and change. You see D here is at 32. I hope that makes sense. This is something Andrew Rees said to me, which made a lot of sense, which is the reason we can move over our source code, which is shaped syntactically like a tree, the reason we can observe it is the term I use. The reason we can observe it with our call stack without building any kind of other data structure is because a stack across time is a tree. So it's actually the same shape, and that's why it can, map onto it. Defer, because you guys love defer at this conference. Defer is really cool because we can pass the scope. We then have to reset back to say, oh, but I actually didn't mean that. I just wanted to syntax check it. But then if we want to get to the return and then how do we insert, this would be a common theme, is how do we insert the defer at the do defer comment? Does anybody have a guess?
I would just copy it.
You would copy it, but we haven't emitted it. We forgot about it.
Save the position.
Exactly. It's so stupid. It's awesome. So you just do this like, let me just jump to some other place in the source code, reinterpret this, and use the side effects, because those are the side effects I wanted. But in order to do that, we have to not hit shadowing. So if we, for example, we're going to print B here, we have to not hit the B that was declared more recently. We want to hit the original B. So we have to temporarily cover up this the new declarations that happened. You also need to clone this because the defer wants to declare new things inside of itself. See Raphael's. Yeah. So and then we do it here as well at the end. Now we can use this for procedure inlining. It's so cool. So basically, if we have myfunc, what's called myfunc2, you see the function call, you go, should I inline this? And you use the heuristic, how big is it? Like, how big is the text, right? And so you decide, I'm going to inline this. And you jump down and just process it as a scope, but you have to have, rebound the names so they mean the correct thing. And when you see a return, that doesn't mean return in the parent function. That means jump to the end of where we're inlining the procedure. So that's a very cool trick, in my opinion. Okay, can we all make a compiler now? You guys kind of got it. It's actually not that hard. Sea of nodes, so if we go back to, So we're going to go through basic fundamentals, mental model, lots of OWL nuggets, lots of here's this thing, and this is what the foot looks like on the OWL. Going back to this is ginormous output for that code. I would like to take audience suggestions on how do you think this output on the right could be made better?
Return 7.
See, you do compilers. I wanted other more basic suggestions first, but yes.
Go backwards, maybe.
Go
backwards. Look at the last thing.
Which one? The
IR2. See what it returns and then go backwards.
See what it returns and then go. Oh, wow. Okay. Interesting idea, but that's not what we're gonna do here. I was thinking there's a bunch of things here that's wrong actually. Hey, we take the address of the variables many times and produce value numbers with the same stuff. We would like to, optimize arithmetic operations. This function both returns a constant and could be inline. So this function just is a constant. So there's a lot of stuff wrong with this. But it's hard if we generate this output and then try to look at the output here and try to move stuff around, that's actually you can do that to some extent, but it's a local minima. What we need is a better data representation for our program than this thing on the right. Once we have that, doing these kinds of transformations will become easy, and that's what Sea of Nodes is. When I have this home, output quality, the problem with this is not that it's not optimized, it's that it's crap, right? It's that it's just bad code gen. And so having an optimizing compiler is not about being a Java guy who's no, I'm going to abstract so much the compiler can just automatically fix all the things and make my program fast. That's not what this is about. This is about high quality representation of your intent as programmers. Because when you guys write code, you have some intent of the exactly what the necessary things that need to happen. And we want to try make a high quality output. That's what this is about. So this output on the right that we've been looking at has this linear quality to it, which is it grows downwards. This allows us the nice property of resetting it or rewinding it. It's pretty easy. It's kind of like an arena-ish, you know. Sea of nodes is this like crazy node graph. Okay, how does this work? Well, the sea of nodes graph is reference counted. But it's actually fine, don't worry. So when basically we have these pins that go into, so we have this graph and we're building the graph from one end, sort of growing it out like this. And we keep it alive by having pins that hold things up and don't get freed as we're constructing the graph. But what that means is that we can, if we want to revert stuff we've done, we can insert pins to old pinpoints where we had stuff, remove the new pins, and all nodes that we built on top will just automatically free off like this. So if we remove this pin, then this guy goes and this guy goes, and we're left with this graph. So it's actually got this same quality of being easily resettable, but you can, it's like even better actually. Question? Kind of, yeah. But it's not, this action of removing the pin here, you have to go it's reference counting in that sense. But of course you just have a tree list for your nodes, you're like arena allocating them and you tree list, etc. Right? Okay, so this is an expression. This looks like a tree. It's not a tree, guys. The talk is treeless compilers. It's not a tree. It's a graph. You see, but trees can't have cycles. Look, I'm sparing you the cycles. So we have this expression. This makes sense to everybody. Look, we have some adds, some multiplies, etc. Right? We have this concept of a peephole. Now, a peephole is basically it's pattern recognition to rewrite a subpart of the graph. So if we look at this multiply, basically you have lots of peepholes that describe transformations you can do where if I see X, replace it with Y. So in this case, we have a pattern, we have a peephole that says, hey, I see a multiply and it's a multiply of two literals. I'm just going to replace that with the constant fold, and that would be a constant folding peephole. So even just with that, if we apply peepholes, we can get the literal 11 or whatever we were after. Very important. See, now my memory is failing me here. Yes, so it's important to note that there's an end-to-end mapping here, because not only do nodes have inputs like this, it's that we need to be able to walk backlinks on every node. So you need to be able to, because if you later decide, hey, this node can actually be replaced with this node, we have to go visit everybody who takes this as an input and replace their use of that to point them to the new guy. See, wow, that's crazy. Ryan was not lying. Okay, so yeah, we have an end-to-end mapping. Now we also have this cool thing, deduplication by hash table. So basically, we hash nodes, both the type of the node, local data on them, including their inputs, and you just hash the pointers. This is very cool. So you hash the pointer, and what you can then do is in this expression we had two twos, right? So when let's get in the right mindset here. We're in the pass expression for the multiply, and then we call pass expression on the 2. And before returning the 2, the peepholes get run on this 2 node, right? And we look up in a hash table to say, okay, we hash this node, we look at the table, are there any other nodes with this same identity, basically? And in this case, that's true, because this 2 node exists. So we can actually just use that node instead, and we reduce the size of our graph. And now, when the multiply happens, the multiply can use these 2 nodes.
No, no,
so
today we
apply
are
the
starting
people
early.
on the
We are
multiply,
starting early because there is
you get
conference
literal 6,
right now.
and I've accidentally freed this too. So that was bad. There's a keep alive link. This is very important. Because we have this very bubbly graph, we have to have these pins in for things that don't have like proper users yet. It's like I need to keep this expression around because I'm in the middle of passing something, and somebody will use this, and it has to not get freed. So the way this would actually work is, okay, I create the literal 2, peephole it, it gets optimized to the other 2, and then we have 2 keep alive links to the 2 from the same keep alive node. And then when we do the multiply, okay, the multiply is able to be peepholed, turned into a literal. Then we unhook the 2 keep alive links when returning from past expression on the multiply. And so, we put a keep alive on the thing we're returning, we take these off, and so the 3 disappears, but the 2 stays, because we need that. The reason we deduplicate by hash table, and we have to do this everywhere actually, even for these dumb nodes like the 2s, because these 2 adds, you can see that they're the same, but your code cannot see that they're the same because they have different node inputs. If we deduplicate these 2s and have them be merged, the hashes of the adds match up, and then we can merge those as well. So it's important that we do this constantly in order to be able to crunch down and efficiently figure out what operations are actually the same, and we can create a smaller graph. So, and then the peepholes are kind of, in aggregates. You write a lot of these small transformations, and they add up. So for example, if we have a plus with a constant and something non-constant, you want to rotate around so that they're on the right side, because then some other pattern can see this and sort of rearrange the add to merge the constants, and then the constants can get folded together. You have lots of these small rules that go together. And the way I think about it, it's kind of like gradient descent in machine learning, not because there's any kind of randomness here, but that we start at one point, and then, so we start, basically, there's an ideal graph, let's say, because we're working with graph. There's an ideal graph of your program, and that's in the set of all possible graphs, right? And then the naive pass of your source code text is going to land you somewhere here. And then the peepholes are basically just describing, if I'm in one of these squares, I move to the next one, right? So you can apply these, and then there will be many paths from A to B, depending on which order you apply the peepholes in. That's fine. And one of the ways you've messed up with your peepholes is if you, at the end, when you do your release build, you loop over all the nodes in your graph and basically apply peepholes until nothing changes. You completely exhaustive apply all the transformations. If that runs forever, you've made a loop, so that's bad. You have to debug that. Let's see. Yeah, so this is a mental model, and you can see how it's like, in the space of all graphs that represent this these observable program effects, we land like somewhere in this space, and then we're sort of locally walking down towards some local minima. Let's see. And so the cool thing about this is because all of our rewrite rules are local, they're very locally scoped, it means we can apply them while generating the graph. So if you built a section of the graph, it's going to be in L1 because you just output it. So you can apply the peephole basically for free and do the move. So you could do the naive pass and then recursively apply peepholes to crunch this down. But it's a general theme that goes back to our character grouping from the beginning, which is we want to generate the minimum amount of memory contents because memory is the slow part of doing this kind of compilation. And so we get this free speed up basically by while passing, see this is why it's so nutty this. While passing, we have some code that's running through the source file, looking only at the bytes in the source file, generating a graph, optimizing it while generating the graph, and then finishes with some output. So these are kind of the different types of sea of nodes. So we have pure data nodes, like an add or subtract, that only they represent basically maths expressions. We have control flow nodes. So a function call, you can't just reorder a function call against something else, right? Function calls have to happen in a specific order. So while these pure data nodes just take data inputs, a function call might take data inputs as well, but it has one control flow input which says I happen after that guy. And that's represented in the graph. And if you want to make a really cool sea of nodes compiler, you have memory nodes, and you do memory dependency chains, which if you want to go talk to Eskel about why the C, oh, there he is. About the rules in the C standard has lots of rules for what kind of assumptions can I make about, oh, I have this load and I have this store. Can I make an assumption that this function call won't have modified this memory? That's all to enable these kinds of memory optimizations. I'm not this cool, so I just have all my memory ops be sequentially consistent and they're control flow nodes only. And you probably do that on your first sea of nodes compiler too. In this model, with these nodes, variables do not have addresses, right? Because when a variable here is a name binding to a node. So we have here S for B, what's my example here? Yes, so basically when we pass this C is equal to A plus B, we construct an add node and then put that in our table. So, because that's what we're interested in, is when we look up, and we do this even in this expression, right? Pass expression that looks at this A plus B is going to return the nodes A and B. These are the placeholders from something earlier. And the reason we do this, there are also hidden keep alive links from this variable table to the nodes. And so if we pass the call here, call print, which unfortunately Google Slides. When we hit the end, so call print, C takes this red control link to the previous control flow that we're tracking, and it also uses A. But we have this variable C, which is bound to the add, right? When we exit the scope and exit the function, we're going to pop off C, and we remove the keep alive link to this add, so the add gets removed, and then also when we get to the end of the procedure, B will get removed as well, after the stop node. The stop node, so the stop node is like all control flow terminates at some point, either in calling something that never returns or actually returning yourself. And so the stop node is like, this is the end, right? And you can see here, this is how you get like, you're in Visual Studio and you get, oh, I can't look at that variable, it's been optimized out, right? We've successfully optimized out C, so we have no idea what C is anymore. This stop node, there's actually a start node that I've not been telling you about. So there's a start node and a stop node. And your procedure graph will live in between these two. And this is the equivalent, right? So instead of producing this linear set of IR, whatever, bytecode thing, we've made this graph that's pinned between the start and the stop node. But we can't run this graph,
interesting,
right? You kind of
I heard that Skia is slowly moving towards Vulkan 1.3, so eventually we'll get more features.
We can't run that on
I was reading release notes of Skia actually related to Vulkan, and
which is the actual output.
I also
this is called
don't like to touch Vulkan. I tried it. I mean, I made a small game that was using Vulkan directly a long time ago, but it wasn't a pleasant experience.
The other half is doing this global code motion algorithm. So we're going to try explain some of that. So there may or may not be a preamble here.
Nice.
Parameters. It depends on stuff. I mean, maybe
display.
Yeah, whatever. If you're doing the naive,
and this one can be simple, right?
Then you're going to have to take the inputs from the calling convention and stick them in the stack slots, because we're going to use V1, V0, etc. And Well, yeah, let's start with that. So we start the start node, and then the start node produces the values v0 and v1. It's also worth mentioning, in sea of nodes here, a node can produce lots of value numbers. It can produce a wide value. So start produces v0 and v1, which is a and b. We had these member access nodes, and a member access node is how you extract a subvalue from something. In this case, we want to extract out of the start node. So again, we started the start node, we're walking this thing, the member nodes get these value numbers associated with their outputs. Now we can look at the add, we can emit, so also, these have not emitted anything yet, but now when we emit the add, we can look at the two inputs for the add node and say, oh, that's going to turn into an add v0, v1, and then it produces v2. And then we do the same for the return, and then we're done. You can see, compared to this is really good, actually, this output. So we already have a massive quality leap just from tracking the correct data structure, right? Another example here. So if we had want to add by a constant, constants, I didn't draw these before, all constants use the start node. And the reason is for this global code motion algorithm, you need to be able to start at the start node, see all the people who use the start node can immediately happen when we start compiling the procedure. Also, the way we're doing global code motion here, we're doing naive early scheduling, which is we schedule things just as soon as we possibly can do a thing, we do the thing and we output that code. Also, is everybody hanging on still? You know, how are we feeling? Got some thumbs up. Okay, that's good. So, foreknowledge problem. You guys remember? So in the previous compiler thing we did, we had the auto-dereferenced type that we used for referencing variables. We can't do that here. So the foreknowledge problem shows up again where declaring something like, oh, I have this int, which is, so accessing the struct s, very easy. It's just a member access node. Modifying it is kind of crazy because you have to fragment this thing with lots of member access nodes, but replace the member access with something else, and then you bundle this together in order to put it into the table. That would create a crazy graph. So you're also peepholing this. So a member access can like be peepholed and look through the previous union node or something to figure out what it actually is. So like, anyway, as you can tell, peepholes, lots of things happening. It's kind of, you'll spend many months working on this. Control flow. So now, because we don't store things on the stack, we have to deal with, or because variables are names of previous calculations, essentially, we need a way to know how data flows through control flow. So this is how we end up with control flow. Is, okay, we're going to pass the if, okay? So we pass the if. This takes a control flow input, right, because the if happens after something. And then the if is a little bit magical because it produces two control flow outputs. But we use, in the graph representation, we use what's called a projection to get at those. So basically, projection 0 is the control flow for the true case. Projection 1 is the control flow for the false case. We also, we had our amazing, lovely table for variables. We have to duplicate that. And then we do pass scope inside the if statement, the true case. Okay, so we get a literal 4, and that gets bound to the table, right? Because that's what we assigned 4 to. We then do the else case, and we bind the literal 7 node to x in this other table. And then now we need to merge this control flow together. So we create something called a region. And a region is kind of the inverse of a bunch of people jump to the same place. It's like a region merges multiple control flow, multiple control flow paths. So we have a region, and then what we do is we go through this table and we need to merge these two versions of x. So we create a find node. Phi node, you've heard of these. Everybody's heard of these phi nodes, okay? And they sound super complicated. Phi is a Greek letter. The original name for this concept was phony node, as in pretend node that doesn't do anything. But they were concerned that they wouldn't get published like that because it's sounds a bit weird. So they changed it to Phi because then it sounds cooler, right? And once again, cool fancy name makes the thing cool. I like referring to these as phonies, but sometimes I say Phi, whatever. The Phi node we construct has one. It takes the first input. It takes the region at which it's. So the Phi node is associated with a region always.
Oh.
And it has the same. It has a
Being
data
mentioned in the
input
chat.
for every control flow input that the region has. So there's a one-to-one relationship between these. Once we have this, we set in our table. We now have okay, X is bind to this Phi node. Now, how do we do that in our code motion thing? Now, see, we've got the concept of a basic block leaking in here. Compiler people know about basic blocks. So these literals are obviously connected to the start node, and that's why they happen immediately, because they don't have any dependencies other than they have to be in the function. So they use the start node. So what happens is we're at the previous control flow, and when we do this code motion now, we're moving through and generating basic blocks based on the control flow links in this graph. So we get to the if, we terminate our basic block with a Boolean branch on X, right, which was, in this case, V7, I decided. And then we look at the projections, and the projections spawn new basic blocks, which will accumulate instructions. Now, in this case, they don't contain anything, because we go straight to the region, and the region will create a new basic block that where these guys jump to the basic block. And now, you see here what we've ended up with the Phi is a thing that takes these V2, V3, and V2, V3 these literals have numbers, right, because they happened earlier. They happened at the earliest possible time they could. And so we produce a new V8 based on this, okay? But you can't run a Phi node. There's no Phi instruction on the CPU. So we have this association with, there's some value that we want in V8 if we come one way, and there's another value that we want if we come from the other control flow direction. So after we generate our basic blocks like this, we go back in the basic blocks and we strike out the Phi node, and we insert moves at the end of the basic blocks where we're jumping from. So we're basically, and this is why it's called phony node, because it's just like, hey, you have to map this. I don't know. It's not hard, but think about how much people talk about Phi nodes. It's like, ooh, Phi nodes, cool stuff.
Yeah, I remember Phi nodes. There is
the owl is very big.
Phi
so
instruction
I'm now gonna
in
mention
LLVM.
some quick things at the end. So loops.
It's an instruction that does
also
nothing.
I don't want to talk about because they're my least favorite part of my compiler. So I have to go redo this. But you can see how the loop is like the if. It's just you have to create the region before you see what happens after it, because it's a loop back. And what that means is you have to have a strategy for preemptively creating Phi nodes, because as you pass top down, if you see somebody uses X, you don't know whether or not X is modified later, so you have to preemptively put a Phi node there, and then at the end of the loop, you can go back over your Phi nodes and remove the redundant ones, where if a Phi node takes as input itself and something else, you can just change it for the something else, because you know that's what the only thing it can be. Dominance trees. This is basically in our global code
I remember
motion,
this.
we
I was
did a
writing
naive early schedule.
optimization
But in
pass
order
for
to actually
LLVM
generate even higher
long time
quality
ago.
code, you want to do late scheduling, which is to
The
say,
dominance
I
trees.
have something, I want it to run as
Canonical.
late as possible and as far into the code. Otherwise, if you build this compiler, you end up every function has a giant chunk of literals at the beginning of the function in the first basic block, which is obviously bad. So we need to do a late schedule, but what the dominance tree does is it looks like this, and it basically, what it means for a basic block to dominate another is that it will always have happened if I get here. So
Yeah.
if I'm here in this block after the if statement, then I know that
This
the
dominance
latest block
analysis
that I
is
definitely was in is this other one. So
LLVM is
you
nicely
have
built
the
because it has
dominance
those
tree.
analyses,
You
and if you
can
have plugins that do
look at your source code
specific
and create the
optimizations,
dominance tree
they can
based on the
ask
source
for a
code.
specific
I
analysis
did
to be
this.
present,
Don't
and
do
the
this, it's a
LLVM
big
compiler
mistake,
will
because
scan the source
you
code,
want to be
source
able to
code,
do
the
peoples
AST,
that operate on control
and give you
flow,
the
unrolling
dominance
loops,
tree,
pure
plugin.
collapsing statements, etc. And
It has plenty of features
so
like that.
in order to support these arbitrary transformations
Look
on
at
your
that.
graph, you need a
looks
separate
neat.
algorithm afterwards at the end that takes whatever crazy graph you made and calculates this dominance tree in order to do register allocation. Luca, who's sitting right here, knows
I like
a
those
lot more about
buttons.
me than this. A lot more about me than this. See, the sleep and the alcohol is getting to me. So anyway, you go talk to him about dominance trees later. So now, homework for next year, guys. I want you all to do go left sometimes parsing. Everybody can do this. This is like a weekend project. The AST-less compiler is maybe a couple weeks project, and then I think there are more and more of us doing this, but I want everybody who's interested to go read the Sea of Nodes tutorial and then try to make one of these, because we need more people who are in the Sea of Nodes space, mostly so I can learn from them. And yeah, this tutorial is great. So Sea of Nodes was invented back in the 90s, but then there's no good resources, so it's kind of been buried. And then the inventor of Sea of Nodes is making this tutorial, and it is pretty good. The markdown files are really good, useful. The code, I struggle with. It's very OOP Java. So, if somebody could make a translation of this in C, where it says what the thing does, in order, that would be helpful to me. Yes, exactly. So there we go. That's your homework, and I'm finished. Thank you. And now Raphael, this is crazy. Raphael is going to come ask me questions. Can you believe it? Amazing. See, I've been comfortably looking from the audience whenever speakers have to stand around and wait like this. And now I feel different about it suddenly.
One thing I took from scientific papers is that even though scientific papers may sound smart, often when they are written, they are always written in a very... They always try to highlight the contribution and the value and how it's useful very clearly. Even though the solution may be complex, the value in all scientific papers is always
great talk, super interesting to me.
Presented in the most simplistic, easiest to get way.
You said this
And
to me like water.
I think the presentation could benefit from something like this. I see this as an interesting way to write compilers, which could be faster, because it avoids one step, the AST construction. It goes straight to IR.
We'll talk about that.
But I'm not sure if I understand this correctly. Maybe there is some other benefits there that I kind of missed. The parsing tricks that he showed are definitely cool.
I have too many
The LR parsing, the one that switches dynamically between left and right branch,
So this
that was cool.
Parsing without an AST. I mean, we saw it was kind of live because then you build a graph and you do things. No, it's not an AST. I know, but
And it's
applicable to all
a new compiler
languages.
from scratch.
Does it force some constraints on the language design itself? Like, can I have an existing language and then I'll just do this kind of parser and see if node things for it, or is it like, oh no, like it massively affects the language design so that you can do this?
You can always do the Sea of Nodes thing. The being treeless in this fashion, I want to say, it seems isomorphic to me but you probably, for some languages, it might be you're just doing so much of this rewinding that it doesn't make sense that much. In my compiler, the rewind points are actually not that many. They're surprisingly infrequent, but they do happen, so you have to handle the case. Then there's, of course, you guys can't use this in Jai because you have to expose an AST to people.
Exactly.
So,
Yeah.
but maybe, because you have a copy of a separate, so maybe you could internally remove the AST and only user space.
We can talk about that. Like, just because I asked about the language design, because like if you guys are familiar with YAML, like if you want to hear or get me
exactly what I wanted,
which is arguably very easy, but if you want to hear a particular rant, ask me about YAML. This language design, okay, I'm not going to go into it here, but basically they made it extra hard to parse this in any way performant. Like even just do a correct parser is crazy hard. Performance is not even in the not an option. So I was asking about the constraints. Like maybe you can do it for every language, but is there things you should think about in your language design to make this parser easy or fast?
There are other things. I have opinions about this because absolutely you should strive to be like a Mike Acton language designer, in that you're thinking about the data, because your code that you're going to pass is the data that goes into this problem, right? One thing that I'm amazed that more people don't do, which I do, is if you have unique keywords for everything at global scope, kind of like Vyacheslav had added to his C code. If you have those, you can do a pre-pass on all your source code and find all the global things ahead of time, which means you don't have to. So that's, for example, how
I'm not going to waste any more time.
So in my compiler, I run through and I find all the procedures, which means that both when you compile procedure bodies, you already know all the type info, you know about all other procedures. You can type check them as you see calls to them. And you can go wide on cores, right? Because you found all the procedures. So if you have a 100 core machine, you can go wide and on the procedure bodies, because that's where all the effort is. And so I'm surprised more people don't do that, but I guess it is aesthetically not pleasing or something.
Okay, and you mentioned that you can do the C of nodes always. That was kind of a question that I had. If I start with a classic AST parser and do the type checking, etc.
Yeah, it's still worth it to go. It's still worth it to go to AST because, not AST to C of nodes, because in the AST case, you are fine. Okay, you're generating the tree and then you're walking the tree. But you still don't do anything else with the AST other than you use it for parsing. You guys still generate a bytecode, for example, and people make IRs, so you can absolutely get big wins from having C of nodes be your IR, even if you use an AST. These are not associated concepts.
Yeah, so it is a viable option of okay, I have the AST, I have type check. Now I'm going to turn this into the C of nodes soup mess to do optimizations, etc.
Yes, and I think, I don't know what you thought, but I think it's very cool to see. I've definitely grown neurons to think about graphs now, but this feels like no other representation feels this accurate to what the program is, because the great thing about this is it represents exactly the
There's even better representation,
operations that are happening, and
which is the
doesn't record extra
basic block graph of machine code in memory.
And since you talked about optimization and producing high quality output is more important, is it bigger than optimization? How do you think about this fix it in post mentality of just generate some?
This is our D-pad on the mouse.
Straightforward or generic structure, and then I'm sure the optimizer can figure out all the how important is it to have a nice input so that it, you know what I mean?
Yeah, the more if you write optimizers, you kind of don't believe in them afterwards. That's my experience. I get this just being on Compiler Explorer and using Clang and trying to get some output. I'm like, how does what? It's just even for arithmetic stuff. It's I can see how you can make this better. Why have you not made this transformation? So yeah.
So I don't know, Sander, is fix it in post, is that a trigger phrase for you?
I will get very mad.
Yeah. Well, also, what doing this kind of stuff makes obvious to you is that all this technology around how to do compilers and optimization, again, can do nothing about the memory stuff. Like C has to have, and again, you know, ESCO can tell you all about the C standard and the memory rules and stuff. They have to do so much work to basically allow you to do more transformations. And so, well, again, the optimizer can't touch any data layout. So if your data layout's bad, then it's over.
Yeah.
And also, it can't do things other than what you told it to do. It can reduce, you can produce this graph that's the ideal representation of the observable side effects of your code. But if the observable side effects themselves are bad, you can't like get better than that.
Yeah, I started the conversation with Eskil about...
This is actually a really nice observation. The side effects is what limits optimizations.
That's kind of the problem that we got
And
into with all the OOP stuff and the idea of, oh no, the optimizer...
the same applies to natural languages. Like when we communicate, when we talk, when we write anything in a natural language like English, whatever, Polish, German, there are, to our words, there are always some kind of, from the words that we write, we can infer some information about the world outside. And there are some things that we always have to say in languages. For example, in English, when you refer to something, you always have to reveal the gender of the, for example, person that you are referring to. You have to say he, she, it. So it's very hard to speak without assigning gender to objects. And the same for time. You cannot speak without using some tense in the sentences that you say. There are some languages, very fun languages, that are meant for human-to-human communication, which avoid those things. Like, there is a language called Lojban that I love that does it, and it really shows that the power of the language comes not from the compactness, like how much information you can squeeze to a few words. It comes from the ability to not reveal information that's irrelevant, to only say what you want to say without saying something else. And C and C++ are kind of bad at this. Because in C and C++, when you want to write code, you always have to create side effects in memory. When you read a variable from memory to a local variable, for example, in a function, you copy data, the compiler has to do this data copy, and when you read it again, the compiler has to do it again because it could have changed in the meantime. So the compiler is unable to optimize this memory access, and it's a big optimization opportunity. So a language that avoids side effects in its syntax, in its memory model, is going to be very powerful if one comes up. But there is no such language yet. But who knows? Who knows?
I think.
I agree.
Yeah, but I don't have that. So. Damn, I had a follow-up that I just lost when I was agreeing.
The sound base mouse.
Maybe it comes back. Where do you get all this from? Like you mentioned at the end, the Sea of Nodes tutorial, but like all the peepholes, all the like, oh, you need this special kind of node to make the rest.
So I'm roughly familiar with Haskell. I never wrote in Haskell. I know the ML style in general. But Haskell, it really depends. Does it have
the first chapters are like
quote memory model? Does it translate to low-level instructions that you can
do some ads or something?
Like for multi-threading, for instance, this is like where you want to have very high expressive power and control over what you want to say. You want to distinguish atomic reads, atomic writes from normal reads and writes, and from like local information. Once you read something from memory, you want to... Like the language needs a way to distinguish memory read from a value that can be optimized out. Rust is actually good at this because Rust has a very powerful aliasing tracking because of its borrow checker.
He's like a fantastic resource. He'll also be able to do a thing where you show up with your compiler and you say, hey, I have this compiler.
This is the reason why even Rust is competitive with C++. Even though it has a lot of extra safety, this aliasing tracking is
several
LLVM
different
utilizes this
say,
a lot.
This one will be good for your situation you're in. Do this, and then you do it, and like, wow, that was both easy to implement in my particular compiler that's not anything like yours, and you get speed up wins and stuff. So.
Wow, that's nice. We need more of these people. Yeah, we definitely need to do more renames. Like Phi node, sorry, that's silly. Like it should be phony node, for sure. Like I hate all this. Like I think this is exactly the wrong thing. We have to make this more fancy for publication. Like that's exactly what destroys actual knowledge, in my opinion. So. But we should have an official list of renames for this conference.
Well, we've got it.
Like
many so far. The bill band, the flex, now phony nodes.
Yeah, exactly. How about inspection? Like one thing I struggled with when working on the JI compiler is like an AST. If you're debugging, even if you have great debuggers, which I don't have because I mostly work on macOS, so I can't use my debugger. Also, it hasn't been available when I did the hard stuff. But if you break somewhere and you have like 5 million AST nodes floating around and you're like, oh, I got this AST node. What is this standing for? Like it's already pretty hard. I have utility functions. I have found a way for workflow. I have to make visualizations to trace AST nodes across the compiler, etc. But it's hard for me to visualize, like, because it's basically all pointers and all relative.
It's just impossible to make this smoothness.
Like, is it better or worse when you have a CO? Like, how do you, like, because it seemed even more abstract and hard to, like, is that one of the trade-offs?
It's pretty hard, and I'm also on Linux. I also don't have any debuggers, basically, that are good. Although, so I'll like slave away in GDB for a couple hours for like a hard debug. But the big ones, I don't know if you did this, but ASLR, how much pain is caused by having ASLR turned off or turn on. So every time you run, you get random pointers.
Yes, this is why I disabled ASLR.
Off, which you can do on most platforms, actually.
I don't think
I'm
not sure
on macOS
would even that allow. But we have a separate, like, we have so John,
necessary.
I don't think I could have done this, but like he has a deterministic mode of the compiler where like you get the same, like, every AST node gets a unique ID, like it just basically reference count, like a counter. But so if you turn on the deterministic mode and you have these IDs, you can basically use the IDs to re-identify on subsequent runs the same thing, which of course doesn't work as soon as you have compile time, code generation, and the metaprogram runs in separate threads.
So weird.
Of, like, depending on when they start.
You got the wrong score in the game, so it changed the output executable.
Yeah, exactly. If you hit too many invaders, you
can another attempt.
If the metaprogram takes longer because there is a file something to generate,
I want to remove this blue
might get
blue bleep
IDs afterwards, but it mostly works, and I've used that to re-identify nodes.
Yeah, I have like to do printf debugging on the C nodes, you want like a node printer that prints that is resilient to things being null, probably, and then also reaches into other nodes to make a slightly nicer print of like, hey, I'm an add that points to a literal and a member access. You want that as a nice print. But then also, if you turn ASLR off and you have a single-threaded compile that's deterministic, then you can like instrument your code with, hey, when I'm on this code path, check the pointer. If it's equal to this, then do this print add. And so you can do and you can even do a lot of bugs.
This looks good. It looks acceptable.
Probably this can be mitigated with the good strategies for pinning things properly. But if you actually get, hey, I was trying to use this node and it's been freed by somebody, like something's gone wrong, that would be very hard. So the maximal efficient compiler is, of course, like freeing a node and then reusing that to stay in cache. But I think ASLR off and no reusing of nodes is great, because then you have basically this node will only be the thing that has this pointer ever, which means you can say like, hey, in my create a new node, like trap on this, if it's this address, and then I run the thing again, and then I get a call stack for where was this node created in the code, etc.
I use all the same tools, but it still sounds to me like, it's shit.
Yeah. You also have like, I do I do peak token, get the string, set the length to be longer, and then print that, because then I'm like seeing what was in the source file really close by.
Yeah, like I have all of kind of utility functions to make that slightly easier, but it's still like, it feels like having chisel made of like stone tools, basically, and you're trying to build pyramids.
Yeah, I hope maybe Andrew, if we could get in the year 2027, Andrew and Ryan go together to do
Nice.
like, over time I can see the node graph and like have it change and stuff. So if you, when can we get this feature, please?
yeah, because like we're in the printf debugging world to some extent to make the nodes visible. We don't have a nice visual representation of nodes.
Yeah.
Exactly, same problem. Okay, that's a shame. You mentioned we have
Luca.
Luca of like he knows a lot about dominator trees. I'm not sure if that's interesting to the audience. If
Yes,
there's something
it is.
we should talk about.
I want to. Can you come and tell us about dominator trees? Can we get Luca?
Yeah.
Hey. He needs a microphone. Wait, oh yeah, you can sit with us. Yeah. What? No, my plan for using the chair has been foiled.
You have to use the chair. It's been here for multiple days.
Is the sound working?
You have to put it on your chin like this.
Sound working?
Yes,
Yeah.
we have great sound.
Okay,
guy.
perfect. We have region nodes, which is when control flow merge, and we want to figure out which is we want to figure out what other code we know has executed by this point, and everything which is defined in those blocks we could use, but everything which is so. Like I should draw for this, I think.
We actually have. Hold on.
You could show.
We have to use the whiteboard because nobody's used the whiteboard yet.
If you have a presentation, you can show the if statement.
So here you go.
Yeah.
You can just draw on that, I think.
Yes.
Can we get a camera as well? Yeah, the camera work here.
So if we have some code, and then we have an if, like this is an if statement, and this is the one case, and this is the other case, and this is our after. Code which is like variables which are defined here are not visible here, nor if they're defined here, they're not visible here. But if they're defined here, then they're visible here. So, okay, so let's first talk about why we need a dominator tree.
Mm-hmm.
So if a variable is used here only, then we could define it here, or we could define it here. So a variable which is only used once could be defined anywhere along its guaranteed ancestors. I think dominators.
There are plenty of optimizations that use dominator
I think
trees.
guaranteed ancestor is maybe a better term for dominator.
It's a very general purpose thing. It's like control flow.
Dominator is
Graph.
one of the terms that kept confusing me when I encountered it for the first time. So I'm up.
But if we have a variable which is used like both here and here in multiple places, we could compute it twice in both places, maybe, and that's maybe sometimes a good idea.
Yeah, and that's called node splitting as well. So if we do all this merging during the sea of nodes process, so you get like all the copies of literal one, which you have a lot of, have been merged into one node. You probably don't want to share that actually, because one is cheap to regenerate. So there's like a node splitting thing of deciding to split nodes at the end so they can be late scheduled.
Yes, and deciding when to split can be very complicated. So now let's imagine that things are difficult to compute, but so only want to compute them once, and then want to compute them in the best place. So we could compute all the things at the very start of the function, but then we would compute things that we never actually use. So the question is, if something is used like here and here, then it needs to be defined somewhere along all of the guaranteed ancestors of this guy, and like in the intersection with all of the guaranteed ancestors of this guy.
He's already using the new term. That's good. I like it.
Yes. So the place we want to put the computation is in the lowest guaranteed ancestors of all the places it's used. And this is exactly the parent. And this is exactly one of the nodes in the dominator tree. So, this is the dominator tree. We can draw it like this. So this is the if, this is the then, this is the else, and this is the after. So the dominator tree is some kind of tree where every node corresponds to a basic block in the original graph, and all of the guaranteed ancestors, the nodes I must have walked through to go here, are exactly the ancestors of this tree. And it's kind of non-trivial that this would even exist, like that this mathematically kind of works, but it does. I will not prove that here. I would need to think a little bit.
A short intermission for people who are not compilable. Like a basic block is basically a list of instructions that cannot be jumped into, I think. Or yeah, I think it's jumped into.
My definition of basic block would be single entry, single exit. Or sorry, there could be multiple exits, but all the exits happen in one position.
That's what I mean. You can't jump into it. Like if you execute the first statement, you're gonna if you have
a picture is better to imagine this. Instead of explaining this, just Google search for basic block graph, and there are tools like IDA that generate this out of machine code.
These to be different, but like that's.
It's much more readable than assembly, actually.
You leave early, right?
Yeah, if you leave, the rest might still be in the same basic block.
I think you wouldn't want that, especially in Sea of Nodes.
No, I mean the necessary condition, not the.
In Sea of Nodes, you would have. A basic block is entered in one location, possibly from different places, but in one location on the basic block, and then you run some instructions, and then you exit. You may exit towards different places, but in one.
Pretty mask, right?
Okay. Okay. So if
so what I want to do with this,
and then some else code,
select this,
then code, some else code, and then whatever is after if statement. Then we have these 4 basic blocks.
This is my flow for cutting things out. I generally do shrink by 1 pixel.
So we build this dominator tree by like walking the code from the top down.
And this can be an intrusive data structure on the basic blocks, right? And with some
Maybe
you told me about this. We don't have.
I'm not going to shrink this selection.
I have implemented.
And in colors, there is this filter called color to alpha.
We have already. So we build this from the top down. So if a node has only a single way to enter it, then any way to reach this node will walk through its single ancestor. So its parent in the dominator tree will just be its single ancestor. So we like walk through the nodes in this order.
Filter color to alpha.
When you visit a node, you have already visited
here you can play with the threshold to get rid of the shadow. I don't want the shadow.
Single ancestor, so we just place them as children of this if statement.
Do you mean that because we visit this node when all of its inputs are done, that we can then look at these guys as dominators?
Yes.
And figure out this guy's dominator?
Yeah, precisely. So once we get to the point of figure out where exactly does the after come in the dominator tree, we have already built this part of the dominator tree. Okay, so the definition of like the guaranteed ancestors of after
still shadow here.
In the intersection of the guaranteed ancestors of this guy and this guy. So this guy is a path, and this guy is a path. So in a tree, a path from the root to some leaf is uniquely identified by the leaf. From a given leaf, there's only one way to walk to the top, which means that the intersection of these 2 paths will exactly be some path from the root which finishes early. So it stops, like in this case, it stops already at this root. But you could imagine some code like prior to this. The dominator of this guy after is the intersection of these 2 paths, or the lowest point in this path is what's called the least common ancestor of these 2 nodes in a tree. So if you were working graph theory or trees in general, you may have encountered least common ancestor. In a general tree, I haven't really thought about like the size of my writing. I hope it's visible. If
we bought a very, very expensive Zoom.
Okay, yeah.
So
great that like I haven't just spoken towards a blob this whole time. So let's write some tree. The lowest common ancestor of, say, this guy and this guy is the intersection of these two paths, and you could compute it by figuring out which one is the lowest currently. So at the tree we have levels, so every node can track its depth in the tree, and we could walk up like the lower one, then once they are at the same level we can have them walk up together until they meet. And once they meet, this is the lowest common ancestor. So if this was the if and the L.
Okay,
this is,
now I have this image. I can save this
this
as...
is if, splitting into some then and some else. Then whatever comes after will
slightly off.
have these two as predecessors, and the code after must be connected to this as the common ancestor.
That's good. This is great. I see now I can go implement this. So thank you very much.
Thank you.
And then actually computing this thing, like we talked about walking up in the tree, and that could be slow, so you could do this in like asymptotically fast time also, if that's relevant. Yeah.
Yeah, you can go talk to Luke later if you want to learn more.
And sorry, you have to sit here. We brought this chair.
Luca, you're not done apparently.
No, you might be done, but we had this chair here for 3 days. We're gonna use it because now you haven't used it. Yeah. Maybe we open this up to questions from the audience. Oh no, one more question. Sorry, guys, because I just thought about this. What about debug info in your, like, since you keep throwing away information and storing very much, how hard is it to generate debug info in your parser? Or maybe if you think the CFO part might be fine.
It's interesting. So basically, you emit a control flow node that takes all the currently in scope or like variables as inputs. This is this giant node, and then in the output, it creates debug output that's separate. But by it taking all the current variables as inputs, it means that they have a defined location, in your register allocator later. You will know where things are. You can also, if you still want to optimize more, how dwarf is super crazy and
Code view is worse.
Really?
I think so.
Okay. So, but you have all these in order to access the variable x, you take this register and you add it with this one, and you can have arbitrary complexity.
That's worse than work. Yeah, I agree.
Yeah.
But
yeah. So the reason to have that actually is that you can create. So imagine that I have my debug node that takes control flow, and then instead of using all the variables directly, I create some kind of debug inspection node for every one of these. And now you can apply peepholes. I think, I haven't done this, but you basically, you can then do transformations so that you then get this debug output. But again, next year, I would love to see here's how you do debug info correctly with one of these talk.
So the answer is, I'm sure it's going to be fine.
Yes, yeah.
Okay. Questions?
I have a question about something we did not return to in the talk. What was the deal with the $?
It's like a dumb made-up operator.
Yeah, but you didn't explain why this was relevant later. When you actually used it.
Right. Okay. So it's because the $sign is a made-up example of the remote action at a distance, which is to say the multiply means something different based on something far away. And the case that occurs the most is this
I have to make it
variable
larger.
assignment case where, I have an expression on the left side, or I'm passing some expression, and whether or not I'm assigning to this expression, which I find out later, changes very much what nodes I need to emit for this thing. And that was the example of, to modify the struct, you have to shatter it into pieces and then rebind it and sort of re-optimize it to something reasonable. Versus if you're just reading from it, you just go boop and you pull the node.
So this is at a distance because someone later says, oh no, actually you have to treat this completely different.
Yes, exactly. Yeah. You could imagine some crazy language where you don't. So most of languages, because this doesn't come up that much because we actually like to read languages that make sense. So the if keyword generally comes before the thing, but you can imagine like I do a scope and then after the scope it says if this condition, and then you'd pass the whole scope and then have to rewind back and go, or maybe in that case it's fine because you could just patch some kind of basic block thing later, but yeah. The but, yes, exactly. But this thing.
Okay, question from notice. Yeah.
I wanted to ask, so for Sea of Nodes, it seems like your aim is to make an optimizing compiler, but is it also useful for unoptimized compilation, or would you fall back to an AST approach because debug info could be better, or maybe the...
Okay, so I made a mistake here. The treeless stuff has nothing to do with Sea of Nodes. This is like, the treeless stuff was my interest, and then Sea of Nodes happens to be, right. But it's actually still good for fast debug builds, because if you want something that runs reasonably fast, you need to do register allocation and later passes anyway. Those get a lot more expensive the bigger your graph is, essentially. And this applies always. So one of the reasons Sea of Nodes is so great is because you can for free optimize during the pass without taking a hit for it. And then that reduces your graph size, which speeds up
I don't want
later
lossless.
stages because it's a simpler graph. And you reduce the memory footprint.
Does that mean that some key polls do not affect like the debug relation, right? Like if you have a line in the input text, it definitely will have some instruction that relates to it, so you can hit a breakpoint on it? Or do you have like missing kind of stuff that still got optimized even in an unoptimized build?
I think mostly what would happen is
It's
that
5 times smaller.
You know, if you debug output all the things, my intuition is basically variables that would have been dropped, as in I had this expression in this subgraph, but nobody used it, so we can clean it up. You're going to obviously pin and keep those so they end up in the output, but that's the thing you wanted most of the time anyway. So.
I see. Yeah, Maria?
Does the Sea of Nodes makes it harder or easier to catch a compile time user errors? Like how does the strategy change between those methods? And I also have a concrete example which I'm interested in, but yeah, maybe you answer first.
I don't think it has anything to do with errors really. Like you don't, like you're checking for errors in the front end anyway. So the question is more, does this treeless thing help you do errors? And really the answer is that this style of recursive descent parser makes errors really easy because it's just straight line code. It's like, hey, pass an expression. What is the type? Oh, the type is wrong. Let me print a message that says that the type is wrong.
Yeah, for like, I try to rephrase that because to clarify that,
yeah.
Like your non-AST stuff is basically the front end of the compiler,
yeah.
And Sea of Node is actually what you would call the back end of the compiler. So,
but the reason it becomes confusing is because these run together. So in my code base, these are completely mixed. It's like front end, back end, front end, like
one versus one, but it's one versus the other, but they are like two combined together.
Yeah, it's very interleaved.
Yeah, like it's just in a traditional architecture, like you have the thing you renamed, like the lexical analysis is like the token, like the character grouping,
yeah.
And then you do the parsing, and then
you produce an AST, and then you type check the AST, and then it's like there's some point at which, oh, now all the errors
magic happens.
Yeah.
Afterwards.
Yeah. Exactly.
Yeah. Not type checking, like you have a local variable which is also marked static, so it should be like kept alive, but then you reference it from somewhere you shouldn't, like this.
That sounds like lifetime stuff.
Sorry for that loud sound. It's just...
Because I think if you reference something wrong...
Automat has the conference has very low levels, audio levels.
To the lifetime of the thing.
I've boosted it up as much as I could.
Yes, like you can mark in local scope, small static.
Oh, static. Oh, yeah, like a sneaky global. Yeah. I don't have those. So I haven't
another
thought about
rename
that.
is coming up.
Yeah, no, that's a good question. I don't deal with that because, well, no, okay, so because it's static, because you have static, because you have a keyword, what I would try to do is pick that up in the token scan, so you know about the global beforehand, and then you pass the function, see the static, Okay, skip over.
So you cannot make it global.
It should be better.
Normally you know that in that scope. That's what the scope stack would be like. You pop the global and then you push it so it's not available afterwards. Correct.
Yeah. It's just code. When you say I have this name, what does it mean? And you're doing some kind of lookups and various things. Let me first check local variables. Then I run into this. Let me check procedures, because somebody could be referring to a procedure to get the procedure pointer. You're doing like these various name lookups in order, and then probably depends. I enforce that there should not be. You shouldn't be able to have a global variable and a procedure with the same name at global scope. And if you do that kind of stuff, you put it in a hash table to make it a little bit faster and stuff. One interesting thing is for inlining, if you want to do this, I jump to this other code and try to inline it, then you have to, the preparation you need to do for that is you need to have a package of, this is the context in which this procedure is happening, because it could be, I'm trying to inline something from a module, and so when I jump to that code, I need to temporarily change how my lookup would work, because I can, from the perspective of that function, it sees different things, if that makes sense.
So I think to clarify the static thing is, it's different with where the thing is stored is different from where it can be seen. Like where it can be seen from is you look that up by walking the scopes basically, and like having in your case it's a stack that you push and pop.
Yeah.
Exactly. And then you maybe have multiple stacks, like one local.
Yeah, sometimes it's like.
So the idea is actually
exactly. But where it's stored is actually
the macro system is actually modeled after, I think, Upsile. Let me quickly see.
If you want to do more optimization, you want to feed all of the other things for some reason, would you do all your optimizations on the sea of nodes representation, or is there actually optimization that would be done?
So Upsile has a very similar API. Each of those statements, like log, check, info warning, error, fatal, they expand into a struct, which is constructed. This is an ephemeral struct. It's not being saved into any variable. It's a struct which is defined. It receives some operator calls on it, and then it's destroyed at the end of the statement. When we reach the semicolon, the logging struct is destroyed. So this log info creates struct, it can receive a bunch of operator calls, and then semicolon destroys it. The advantage of this is that since it's a macro, it can be replaced with no op, like something that does nothing, and the compiler will basically remove it then. So this whole thing can optimize to nothing if you use proper define.
Instructions on x86 or RISC-V or whatever. And you could do both of those as
and
nodes, and you would have two different CF nodes.
The way that Automat's logging system works is that it has a bunch of callbacks. So when I do log statement, it goes through a list of loggers that are registered and calls each one of them. And this is because I was using this logging system in several different environments where sometimes logging to std out was not good enough. For example, mscript10. In mscript10, you have JavaScript browser and you are running in a worker, so logging there actually doesn't produce anything. So you have to provide your own method of sending logging information out, or on IoT device. Like I have a watch that I also programmed that there is no point in logging anything because it's a totally headless IoT device. So logging has to log to some temporary files and so on.
I mean, you can clearly leak for
this logging system can also have some nice context. I like it because it's really not shown here, but a log macro can receive a lot of extra information. Like it can capture timestamps automatically, but you can also send timestamps yourself. You can attach some context to the log statements that will then be passed the logger. So just a convenient way to
I have made CF nodes
to get information out of the app.
in one direction. So then I said,
And actually, I am slowly leaning more into using Tracy for logging more and more. So I think I will move this system to use Tracy logging mechanisms.
Like sea of nodes implementation.
If you don't know Tracy, Tracy is a debugger,
Some variable that
not a debugger. Tracy is like a profiler, but it also has mechanisms for pulling logs from the apps as it's running. So when you get this nice profile information with flame graphs of what function was executing at which time, you can get screenshots of what was rendered. You can also get log statements attached to specific functions, to specific threads, and you can see this together with the screenshots of your application. And I think this is going to be perfect for debugging Automat. So I'm going to use Tracy more soon. I already am using this, but I will switch logging system to Tracy.
Code, this isn't bad. I kind of don't like it. But in the compiler, I do while one, or while true, and so I can see it. It kind of just, if I turn this and get rid of the if, have it be a loop, and because I don't do the construction of the dominator tree afterwards, it's like, can I change this? No, it totally exploded. So. But it should be, my intuition is, the idea is that, so I need to do more control flow polls, but that's a whole thing, is like, the fact that it's the same graph means that control flow optimizations can also just be p-pols. And the advantage of them being p-pols is that you make these small moves that add together very well, or like it's synergistic.
I have a small follow-up, sorry. Did you have to mess with the order of peepholes a bunch, or it's just like obvious? Like it seems like since it's gradient descent, you're gonna end in lots of local optima, I guess. And did you have to like, oh no, I definitely need to do this peephole here. Oh no, but then like, how much did you have to mess with the order of peepholes to avoid bad local? Or is it something that's obvious when you see peepholes?
Well, I think. So this is like a Yaza question, really. But so the assumption of sea of nodes is basically, the local minima problem is not a big deal. But if that is false, so you can have that opinion, and that allows you to make a fast compiler. And if you decide to say, no, I want the absolute minima, or I want to like jump over humps in this graph, then you need to do e-graphs, which is what Luca does.
Yeah. So my understanding is that for like most simple optimizations, like the sort of things you do when you don't really do memory, you don't really do loop optimization, then it's fairly obvious that your peepholes are never like interfering or like not. Yeah, it doesn't really matter what order you apply them in. But then if you go to more complicated things, it does matter. I'm not an expert on. I haven't actually done complex optimization using sea of nodes though, so I don't know.
We just call the compiler sim, in case you didn't notice. Okay. Okay, here you go.
But I was thinking maybe you could like restart. You could do it stochastically. You could restart if it mattered, and you like mix the order, and then you pick at the end like the best optimization.
You should explain. So if I want to explain eGraphs now, but I'm just going to repeat to you what you taught me at the conference now.
Yeah, so I will not explain all of eGraphs right now. But in short, it's solving this problem of you may pick different peepholes and you may end up in like different scenarios, one of which was better, but you don't know that ahead of the fact. You can absolutely imagine doing it stochastically many times. If you have infinite time, that I guess would work. You could imagine like doing that in a structured way with some backtracking, and that would conceptually also work. Both of these are like very exponential in nature. So eGraphs are a data structure that allow you to kind of, rather than like exploring one timeline at a time, kind of exploring multiple timelines and then deciding after the fact which decision you made. Yeah.
E-graph is for equivalence graph. So the difference here, we are sort of racing in one direction, and that's what allows us to just apply stuff as we go, right? Is we're racing down this hill towards some convergent local minima. And the eGraphs case, if I understand correctly, is a way of basically saying, hey, I applied some transformations and I've come up with this graph or subsection of the graph, which is equivalent to this other one, and I'm going to keep it around to later try to decide or merge with other things. So it's instead of racing down one path, you sort of intelligently, you have a good data structure for intelligently searching the space of all possible graphs.
Yeah, a compact representation of storing a subset of the space.
Yeah.
Kind of. I don't know. eGraphs are quite researchy. They aren't really used for real. So LLVM does not use eGraphs, and they don't use CF nodes either. The practical way. If I was forced to write a compiler and I wanted to minimize the probability of it not working, then I would probably not use eGraphs. I would maybe do CF nodes or something like LLVM and just do K-Splash. LLVM is just K-Splash and then thinking really hard about which order to apply the optimizations. And there are no guarantees about LLVM finding optimal solutions. It's just lots of engineering effort to work most of the time. There are also other optimization things that you kind of can't solve. So in terms of cost modeling, inlining a function, you can't, even deciding, the only way to actually figure out whether inlining was a good idea or not is to do both and benchmark the program. Even if you had a super smart compiler that could do really good reasoning, your cost model limits your optimization.
Yeah, because even if you search the space and you find, I have this version where it's a loop, and I have this version where I unrolled, and I have some way to know that they're equivalent, you should have to make a choice, and that's going to be a very heuristic choice, right?
It might even depend on the platform and the data and everything. Yeah.
So you're saying that
this, I will have to change this stuff.
Involves building programs, running them on test data, and then to decide and measure, and then.
I mean, profile guided optimization exists.
Yeah.
Yeah.
This is just a comment, but I want to insert machine learning. At least I want to toy around with the concept of it, because we are talking about exponentially unbounded problems, and we've seen people do stuff with that kind of tooling. You can only do it for production build, but I mean, they are exceptionally good at searching spaces for optimal solutions.
So if we want to raise lots of venture capital, we definitely go.
I've heard of this thing. I've never seen it. Oh, okay, right. I've seen this thing. No, I haven't seen it, but I've heard of it, which is the Clang build that uses TensorFlow. So building Clang already takes forever, and building TensorFlow with Clang, I believe takes 24 hours. It's like a 24-hour build. So then you can have Clang with TensorFlow, right? So to bootstrap that, you build Clang, which takes forever, and then you build TensorFlow, which takes 24 hours, and then you build a version of Clang with the TensorFlow that you built. And, bad debug run cycle, probably.
Sounds strange.
Just to do the heuristic and optimizing, I think either Casey or John had the idea of why does it have to finish? Maybe I just run the compiler all the time, and it keeps trying to optimize, and at some point it's now give me a binary, and it gives you the best hit count so far. So instead of having it,
it will probably break now.
John, having it as a background process instead of you know what I mean? Compile this. I don't need it right now.
Yeah.
But at some point I'm going to ask you for the best thing you've found so far and give me that. That might be useful.
And this would be the eGraphs thing, right? Of maybe somebody can build this is if you had a mode where for my normal debug run, I run CF nodes and I'm racing towards this local minima. Then when I do release build, I can run it over the weekend, and it's kind of searching wider the space to try find better things.
Okay, so I think we're out of time, if I saw this correctly. I want to finish with one remark, totally unrelated to your talk. This conference has been absolutely amazing. It's been a great experience. I'm sure the audience agrees. Kudos to organizing this, running it this well. Apart from Windows messing up our streams from a couple of times.
But not the VOD. The VOD is fine, guys. The VOD is fine.
And I've been asked multiple times on X, when are the VODs coming, where are the VODs coming, etc. I guess we're gonna post about that. But thank you.
If I get my way, which I may not, because it's the AV people who have to do this. But if I get my way, I would like to do the
mouse is here.
tomorrow.
It didn't disappear.
One per day. But
it's a little bit off.
Okay. But I just wanted to say Thank you for organizing this. I'm very impressed.
Tiny
not just by
problem.
The amount of people that are like super high skilled people here. The density of knowledge here is insane.
Yes.
But it's well organized. Everything has just run smoothly. It was chill. It was like no hiccups. Like, wow. Well done.
The thank you, it goes the other way as well. Like, thank you for being a high-skilled person who's here.
Thank you very much.
Are we going to break now? I guess I'm still the boss of this, but I'm not tracking the time.
So in our turtle, I'm going to replace all of the references to turtle
do we have coffee?
with mouse breaks.
Okay, so should we come back at in 20 minutes? Yeah, 12? Okay. Then we can go on break.
That was a nice presentation. It's fun that there are still some new compiler designs coming out, which are regularly beating the LA, LR parsing from the 80s or 90s. And it seems that all those new approaches, like packrat parsing and compiling without AST, they don't really have such strong formal foundations. They're just code written to do this fast. It's not necessarily over analyzing, it's about just optimizing the compilation process without caring too much about its formal soundness. The fun thing is, if you listen very closely, you can hear conversations. You can like snoop on the conversations happening at the conference. Okay, next presentation, let's take a look at this. The presentations are happening out of order, so that the one that we've just seen was supposed to be second from the end. But the same happened yesterday, so no worries. Other presentations will likely come soon. Ah, look at that, this is our turtle now. Looks different.
We got, first of all, tons of compliments on the fact that we had a good open-ended
A pointer image, turtle height.
One of them was first conference I see where there's natural. They basically where they graph for expressions. Yeah, right? It's really cool. And then
It hurts me, but
this guy
I cannot actually initialize this, I think, at global scope. I need to create a function that will load it.
Yes, because so what will happen is you have
Instead of persistent image, it should be auto-destroyed image, or something like that.
immediately following the exact load like that. But yeah, easy to do memory change. He has respect for
when you have
This
it's fine the program.
nästan i skolan så här. Två dagar Det är jättevanskligt. Vi förklarar det för till men det är en sån grej som
skipping over.
Sampling option I should probably change. Should use decent, nice. Interpolated sampling here.
Jag tyckte att
You can see the turtle looks very different. It's nice, this blend mode actually produces an interesting effect.
Ja, så du vill ha speaker box, right?
Not classes, but
Actually, I will use the break, so I'll go and make some tea. Yeah, back.
De är live.
Change based on the types. Let me check. Sandra, where did you put my phone?
By the stuff. It's on the folded down chair I sit next to.
I think you're after Escom, so I think you will have time to go for lunch. Dennis, let's go. You're going for 10 minutes, right?
Something like that.
10 minutes plus some Q&A stuff. You think there will be time?
I have a feeling the QA. Come on.
Do we have a preferred Q&A person?
I don't. Is the projector on?
What's the button?
You might want to not spoil stuff.
Yeah,
You
yeah.
can see the stage right now.
Yeah, it's fine.
Okay.
As you can see, all my slides. Almost.
Do you edit C in Notepad?
No, but I usually have a notepad next to my, and like use as a copy paste.
Guys, send
type down numbers.
I opened the browser. Should I have done that?
Yeah, it's fine.
Okay. But we should be aware that that's being streamed now?
Yes, he's been
I'm
warned,
aware.
Okay.
but good for checking.
Hello, stream.
Hi, stream.
Hi, stream.
Howdy. The people seem to like the conference on the internet.
It seems to like the conference.
Yeah.
How could they not like it?
Can we do?
It's nice.
I've been loving the respect from my friend Simca on the camera.
Yeah?
People are constantly going, yo, W cameraman.
Yeah, yeah.
He's on it.
No, I've seen the camera with like perfect smooth, the zoom in, zoom out. It's pretty nice.
Yeah,
like,
capturing the stuff you need to see.
Sandra, where is the stuff?
On the folded down chair, next to where I sit. Like right by seat,
Oh, there.
seat 8 and 9.
That's the
So
stuff.
how long do you think your QA is going to take?
I have no idea.
Okay, because I thought you were going to say something about that.
That seems right.
I feel like I want to go find somebody else.
Yeah.
That's so funny.
My
That's actually
slides
great.
could
So
change.
that, but I wanna make the text as big as I can.
Oh yeah, pro tip on this one, zoom out the browser a lot so the UI becomes small, and then you can make the text larger because there's less UI.
Yeah. Where's the?
Control minus.
Yeah, I'm looking for my mouse pointer.
Oh, let's use that end for this guy.
Yeah. Okay. So control.
Control minus. Just spam it a bunch. Pick up. You can go way more.
Yeah. It's fine. So I need to. I don't remember which page had the most text on it. That's what I need to calibrate for.
Yeah, I mean you don't really need this bit at all, so you can
No.
control minus like a lot to just get that array.
No, no, it's fine.
Alright.
I just want to. Okay.
Sandra, for my demo, I need to set the DPI of the screen to 1. Would that cause any problems?
The DPI of the screen.
Yeah, yeah.
Oh, you mean like scaling factor?
Yeah, exactly, yeah.
Yeah, that's fine.
Okay,
Good shot, too.
That's probably the best case. Is it you?
The rant.
The only option is to output LTP.
Not börja visa.
Yeah, okay,
So,
good.
so
Yeah,
100 is like the case.
yeah. I'm sure
So
the
it's
look
like
font
that.
is just like my code is not DPI, fully DPI where that's all.
Right, yeah, I feel that. I have plenty of like Odin Raylib stuff. It's just like on my normal desktop, it's fine.
Yeah,
I go on my
exactly.
laptop, which is 4K, and it's just minuscule.
Everything is backwards.
I was thinking how to do this. Maybe they are saying they are restarting OBS. I'm afraid the volume may now shoot up, so I will mute this temporarily. I don't think it's worth it to refactor it too much. I think we will refactor this later. I mean the extra storage, so that instead of variable, I want to have a function here, because a function can actually ensure initialization order. A variable cannot. So it's possible that this variable is not initialized when another variable is initialized in another module. But it's not a big deal. I just need to draw this properly now. Let's call this base texture. Texture scale. The shape of this is going to be I think it's going to be an oval. I think we have to copy the shape as well. Oh, the shape is a rectangle. I see, I see. And its origin is in the corner. The origin should be in the center. I'm not going to copy this terrible code. And maybe instead of rect, something like this maybe. So that should make the texture larger. And you see the music. Okay, our mouse move object looks like that. It looks kind of funny on the edges, but this is not a problem. This is only because I just didn't cut it carefully. I don't like those artifacts. Ugly artifact. Come on. Actually, this shape isn't that bad. Look, it actually follows the mouse pretty decently. I think on the bottom we could use a different radius. Can I write to this span? I don't think I can. I think the first two were bottom, so let's do that. Here I'm just tweaking the shape of this object so that it follows the bitmap nicely. See, so now it rounds here and a lot, and here very little. Okay, what else do we want to change? I want to change those blend modes. Completely unnecessary. I think we don't need to save and restore here. Although the blend mode was interesting, we could use it to draw some images on the display of the D-pad. Okay, now we don't have the weird edge anymore. The D-pad is at the proper place. Maybe it could be larger, because I want to make this way smaller. It should be comparably small to those buttons here. It's going to be very hard. Let's see. So just an experiment. If we put the D-pad, I made it like half times larger. It could be this big, even. But still not right. preview and grab this color. That was... I need to do feather, very subtle feather. Okay, let's try now. Okay, this is just setup, we are not starting yet. Cleaning this up, cleaning up. Okay, and now we have a very clean D-pad image, which doesn't include any white shadow, any part of the mouse. The reason I did this is that we can reuse this D-pad now in many places. So I'm going to save this. And the point was kind of to make an experiment. I want to see if I can enlarge this D-pad. When I cover the mouse, it stops being recognizable. Maybe I could make it this large. When it's going out of the edges of the mouse, it feels weird. I think I will keep this. And we're switching to conference.
1, 2, 3, 1, 2, 3, and we're live. Okay. So I will introduce the next speaker, and not many speakers get to have 2 talks in one conference. So you know that the next speaker is a really special guy. And all I'm hearing is the next talk is gonna be a super spicy rant. It's gonna be short and concise. And I need to tell you this. A lot of people here are coming from this handmade hero heritage, okay? So they have the similar ideas how C code should look like. And this speaker is coming from a wild place, okay? He's a hardcore C programmer. He has his own ideas, and now he's about to deliver a spicy security talk. So please, a round of applause for Eskil Steenberg.
Thank you. I think is my mic on? Perfect. Okay. So, I take security seriously, but I've had it with the security orthodoxy. I really want secure software, but we can't let the security orthodoxy continue to unquestionably control the software community. The security orthodoxy assumes that security is the most important aspect of computing.
Yes, this is it.
It never is.
Yes.
Computers exist to get things done. If security was more important, here is a hot tip. Don't plug your computer into either a power socket or a network port. But most people do that.
It may sound like a strange comment,
most
but
people think that running software is important for things like
a lot of
society.
Education around programming is built around safety. Engineers are taught to build reliable systems because they are responsible for them.
Says that it's only able to judge what constitutes good software, and therefore does so from the most.
But it's very rare that a normal user shouldn't care about security.
Is not into research. We are engineers. And engineers have loads of things to consider, and security is only one of them. And many times, security don't matter. Software development is to balance of different, the balance of reduction of bugs with the production of useful functionality for the user. It's always a balancing act. Despite what some people think, software can never be proven to work. You can sometimes prove that it reflects a specification, but you can't prove that aren't errors in the specification. And you can't prove that the intention of the specification isn't wrong to begin with. There is no way of writing software that is guaranteed not to produce bugs. All we can do is make the right prioritization to minimize bugs. Screaming and crying about how the world isn't perfect is childish and stands in the way of actual making things better. This utter failure to understand the reality of software development is evident when listening to the process advice preached by security orthodoxy. Especially security advice, security advice boils down to this. Put as many checks on the process that making progress becomes so cumbersome that no one will ever be able to do it. I know so many examples of hacks and lots of much-needed rewrites stemming from developers doing anything in their power to avoid onerous security reviews and lengthy recertifications. Writing secure software is as much about keeping the developers motivated to continue working on it as it is to employ reasonable security practices. Personally, I worked in game development for most of my life, and I can confidently tell you that if you're making a multiplayer game, spending any time on preventing cheats is a complete waste of time.
Until you have players,
fail
right?
To find an audience and
they are
focus
cheating.
on trying to make a game that somebody cares enough to cheat in, rather than considering security. As a C programmer and a member of the VG14,
I don't know, whenever I wrote games, usually the first players were
a security
the
expert
cheaters.
consider that if all the most trusted software like Linux, OpenSSL, Apache, Python, curl, MySQL are written in C, then perhaps the people who wrote it aren't complete idiots. And perhaps, just maybe, C has some property, beyond the obvious shortcomings, that makes it the most successful language in history to write secure code in. Maybe it would be worthwhile to trying to figure out why that is. Research topic, everybody. But the security orthodoxy isn't really considering the real world. Case in point, the Linux kernel has over 2,005 unaddressed security vulnerabilities. You may think that that says something really bad about Linux. But if Linux really had 2,000 exploitable vulnerabilities, no one would run Linux. And whoever was brave enough to do so would be hacked instantly. Obviously, that's not true. In the real world, Linux is very secure. What it really says is that the security orthodoxy has dreamt up 2,000 bullshit issues that don't really matter in the real world. Yes, all bugs in security critical software are C bugs. Because no software written in any other language is good enough to be widely used and trusted for security critical tasks. The survivorship bias of buffer overruns is overwhelming. Speaking of, buffer overruns aren't bugs. Buffer overruns are symptoms of bugs. And by the way, buffer overruns are not seriously hard bugs. ABA bugs, time travel bugs, UB elimination bugs, lockless bugs, aliasing bugs, those are hard bugs. And the people who find those bugs, they deserve our adoration. Your fear of buffer overruns just proves that you don't really know about the C memory model. So, security researchers review code, and as such, they only see the bugs that are left behind and not caught during development. They see a bug in a design, but they do not see the bugs that the design avoids. As such, they want vulnerability mitigation, trying to somehow make bugs fail more gracefully. Software developers, on the other hand, know that bugs are found and fixed once they fail hard and fast, not the ones that almost work and don't really make much noise. So the mitigation strategies proposed by the security orthodoxy make some bugs less serious, but often results in a lot more bugs. Security research is a subsection of QA. Their job is to find bugs. That's it. They are not secret agents or cool hackers from some bad TV show. Finding bugs are good. And there are many good security researchers who quietly do this work, but it's a job, not a superhero identity. Finding a security bug does not make you cooler than finding any other QA bug. I find many bugs every day, and when I do, I fix them and I move on. What I don't do is come up with a cool name for my bug, and then register a domain, and then give talks at conferences about it. If you find a security bug in some important software, that's great, but you do not deserve to be famous, and more famous than the people who actually wrote the software to begin with. It's the same bullshit that makes anyone with a badge think they are a lead action hero, and they're the only people who are standing in the way of saving humanity. You're not cooler than a nurse, or a teacher, or a firefighter, or someone else who keeps society working. The security orthodoxy doesn't know how to be software developers better than software developers. If they did, they would develop software. So let's pretend they aren't. All this wouldn't be so bad if it wasn't for the fact that we're actually
to make
living
this
in a
smaller.
security hellscape. And we desperately need more security. I'm talking about the fact that every person is walking around with a tracking device that is owned and operated by a surveillance capitalist whose very existence depends on stealing our data. Our computers have massive security risks because they, by design, are entirely relying on online services. I'm talking about how the entire population is being fed slop to divert our attention away from reality and towards endless consumption. I'm talking about how large section of society has lost contact with what is real because they are being manipulated for attention, control, and profit. I'm talking about how most people store all their data with someone else. You should not need the internet, passwords, secure connection, remote authentication, a monthly fee, and the consent of a corporation to access your own data. What does privacy even mean when people voluntarily install microphones in their bedrooms directly connected to a retail empire? The frog has been cooked. Much of today's software stack depends on hundreds of source packages that are without review, gets downloaded from corporate control repos, and compiled into system, any one which could have been compromised. Most of these are protected by two-factor authentication. The two factors are a password and a phone, where the first one can be reset by the second one, and the second one can be defeated with a SIM swap that is widely available on the dark web for purchase. Every time a service asks you for your phone number,
it was a couple of years ago,
device,
now it's better.
They should be required to display the current going rate of a SIM swap on the dark web. Large service providers routinely lock people and companies from their accounts, data, and livelihoods without any recourse. This happens without explanation for fear of revealing their methods, on advice of the security orthodoxy. The same security orthodoxy who are preaching public security vulnerability disclosure when it's someone else's software being affected. It's like corporatized ransomware. Only at least real ransomware hackers offer human tech support and the ability to buy back your data once they've stolen it. Windows Update, which is meant to protect me from viruses, has lost me more data than any hacker ever has. The security orthodoxy worrying about potential hacking a voting machine somewhat misses the point when the entire electorate has been hacked with disinformation to begin with. Close to 10 years after Edward Snowden courageously revealed that what many of us suspected, that the US and many other governments engage in widespread hacking and surveillance of the internet, and that all major service providers have given them backdoors to your data. The security orthodoxy has not been able to even present a feasible alternative future to a world of us being perpetually beholden to the whims of a few mega corporation who, without any transparency, bend to any government, no matter how reprehensive. But that's just the thing. The security orthodoxy doesn't make things better. They don't create. They just complain about us who do. They complain, and people listen, and they obey without questioning their orthodoxy. They say, use managed languages because performance doesn't matter. Computers are fast now. Anytime you hear that, I want you to correct them and say performance equals efficiency. That equals battery life, hardware installation cost, power consumption, CO2 emissions. Slow software is literally cooking our planet. Sure, if something takes 1 millisecond, now it takes 2. What's the harm? Well, your phone having half the battery life, that's the harm. Whoever convinced the world that every computer, without exception, needs to be slowed down to mitigate transient execution CPU attacks is responsible for billions of dollars of increased power consumption, untold CO2 being released into the atmosphere, they should be considered on par with the Exxon Valdez or Deepwater Horizon disasters. By the way, off topic, you know who really deserves our adoration? Compiler optimizers. They should be treated like rock stars. For every 0.1% they eke out, every major cloud provider should just like send them $1 million. They should be given praise for their service to humanity. Forget about climate campaigners. Little children should grow up having glossy posters of compiler engineers on their walls saying, "Daddy, when I grow up, I want to save the world by optimizing IR2. The threat modeling of the security orthodoxy sucks so bad that one has to wonder if it's a deliberate tactic to keep us unsafe. Maybe they keep bringing up ridiculous fantasy exploitations like Rowhammer and an attacker's ability to get hold of credential by submerging our memory modules chips into liquid nitrogen. To make us forget that in the real world, dominated by corporations that employ a lot of these security orthodoxies, we're all pawned by default. Thank you.
This happens though. Cooling the PC and glitching attacks.
Send your hate mail.
That was a nice presentation. I really enjoyed it. So now we have 5 mouse widgets. There are 4 for simple mouse button presses and 1 for moving the mouse around.
Round of applause for this awesome rant.
If I record,
Let's all have a contest where we guess
movement.
the out-of-context headline at Hacker News about this talk.
Yeah.
So, where do we start?
Mouse movement works.
So tell me, because this is like a unresolved
Hey,
tendency.
thanks for the follow.
On the one hand, you want to have a safe software, right? Secure software. And on the other hand, it is very difficult to quantify how much effort should be put into. What would you say
the whole idea of security lead is that there is an infinite amount of hypothetical attacks, and you have to have the intuition to recognize the ones which will actually materialize. So this question has no answer, the one that he's asking.
Pieces of software, and how much you're letting this go.
So
you can empirically look at history, or look at how people are attacking the system, but it's a cat and mouse game because the whole point is to detect attack and not be detected.
A lot of things that are online today doesn't need to be online. You could just control them and run them,
You're talking about like signing into your calendar, for example.
For instance, why am I, why do I
He's
have to
answering
have
a
that?
different question.
Why can't I have my own calendar? And there's a lot of things like that. But, there's I want to edit sound. Now I'm supposed to do that in a web browser. Like performance terrible, everything's terrible, and now I have to have an account and log in, and there's security.
To me, this is not a problem.
Why? Really? So I think there's a whole
browser can be efficient with WebAssembly.
Doesn't need to be online or doesn't need this to deal with this at all. And then there are, obviously we need software that is online, and then we can take.
And the browser can download theoretically online WebAssembly applications locally, so that it shouldn't need internet
Try to define
once you install them.
Appropriate.
I don't think I should, and I don't think anyone should. I think it's up to developers and to make that judgment call. It completely depends on what kind of software you're doing, what kind of risk profile you're having, and saying that everything needs to conform to the same thing is like saying that everybody has the same problems. Or
Moving back to our widget,
if I run an air-gapped
now we are going to
machine,
draw
like,
something here.
leave me alone.
I don't know what yet, but we are going to draw something. This
And yes, I think
those
we need to be
buttons,
much more
they are not
flexible
interactive.
and accept that people
I
have
don't think I will make them interactive
use
just
cases.
yet.
And the security problems we really have today are not the ones
Eventually we will,
that gets
but not just yet. They are too small.
Okay. There's the camera.
Okay, maybe
I'm gonna
in a
ask
break I will
question
talk
that
a bit more.
internet will love, okay, but you need to behave in chat, okay, and in comments, all right? So we're talking to hardcore, long-time C programmer, and we're gonna talk about Rust.
Okay.
Everybody in the internet
Rust is
seems
great,
to
it's just
see
great for what?
Rust as a sort of
It's great for high
response
security
to the safety problems, like C's unsecure. Now
native
we're
applications.
introducing Rust for Linux, and we're introducing Rust to kernel. And Rust seems to be as a response to all the
Rust is actually perfect for
in
kernel.
general.
It's
I'm guessing you might not be on the same
and
line.
Rust
So
would also
what's
be
your
perfect
thought?
for Automat
I think,
once the API
Both
stabilizes.
C and Rust is
It's very hard to
they're
refactor
different
Rust
tools
code.
for different tasks, and they're both good at what they were intended to do. Rust was used, was intended to be used in arguments against C, whereas C was intended to produce software. So. No, seriously, I think people should write new languages. I'm a hardcore C programmer. I'm never going to switch from C. And some people think that I'm against new languages or people who invent. I never want to be in the way of people inventing new things. That is just wrong. What I can't stand about the Rust community is sort of the we know better than everybody thing. And it's like, Rust has been around
there is
for
something
15
like that.
years now. And
But
where's
it can
your
be
operating
separated from the
system?
language. We can
Like,
talk about the
where's
language
your
without talking about the
SSL?
community.
Where's your software? Like, show me software that is actually better, that people want to use, that runs faster. And it's like, I don't see that. And I think the kernel is making a mistake.
One impressive thing about
now,
Rust is that
by letting
it
Rust
motivated
in.
a lot of people
Not
to look
because
into
Rust was
secure.
bad, but actually because of all the
into
drama.
Safety is not a
Linus Torvalds
great
famously said
term.
that it's like,
Rust uses
I'm not
this a
letting
lot.
C++
It's more about
into the
verification,
kernel
like
'cause I don't wanna
compiler
deal with
verified.
C++ people.
Like
And I was
statically
like,
verifying
okay, but like,
compiled code.
hello,
Rust does
Rust,
this a lot.
like,
And
it's a
it's a
very,
completely
very
boring
toxic
topic.
community.
Like, unless
And
somebody really needs it,
if
there
they
is
just
no
wanted to
reason
make a
to
language
really look
and-
into this.
and,
And somehow Rust made so many
try
people
stuff,
interested in this.
Great. I mean, I can't.
It's impressive. It's incredible.
I can't say that
and
Rust won't
this is something that
dominant in the
mostly
future.
big companies
That
are interested in
happens,
because
that
they
features are
they
better,
want to avoid
features are
bugs.
great.
They want
And I'm
to
not
have
against
software that never
But
goes
you have to
down,
actually build
and
that
they don't
software.
care
You have to
about
actually
programmer
build it.
individual programmer
Prove it out
productivity.
over time. And I mean,
They want just
people don't remember
the software
this,
to never
but, like,
fail.
in the 90s,
And
everybody was
it's
like, oh, C is
writing this
dead.
kind of
We're all gonna
software
write
is just
everything in
brain dead
Java, and
boring.
Everything's going to be safe and great.
And somehow Rust
And what
turned
Java
it
software
into something like solving a Sudoku. It's a
so
mental
like,
exercise. It's kind of fun to write
it's
safe
easy
software
to
in
say
Rust.
this is the panacea that is going to solve everything. I'm a sort of wait and see guy on that. They have to actually make that software, and maybe they will, maybe they won't. I'm not the person who would like hate to run Rust software on my computer. That's fine. It's about the end results. Like we write software so that people can use it. Again, the Linux kernel has a nice
So what
thing where,
he thinks is also
in
true.
the
It's
style
that
guide somewhere it says like yes.
in Rust it's
there's a
very
lot
hard
of
to create new
code
software.
here, and maybe that's not so pretty. But
It's the formalism that's required to explain to the borrow checker what you're doing. It completely kills productivity. It's much better as
I think that's like
maybe slightly later in software development. Once you have a working piece of software, you can rewrite it in Rust. That's I know many people make jokes about this, but it actually makes sense to rewrite existing software that's already been written, that's stable, into Rust, because it allows you to catch some issues, some crashes, memory leaks.
Well, this was more of the conference, so it deserves some applause, right?
Yeah.
Where do you think this security orthodoxy mindset is coming from? This is sort of like a psychological thing, right? Like it's not like somebody's trained to, like going through 20 years of security like brainwash and then comes a security orthodoxy person. Like
I think it's like, I mean, obviously if you work on a problem, like, I don't know, if you work on anything, like you think that's the most important thing, right? It's like, and that's cool, right? Most people don't care about C programming. I do. I think that's important, but it's okay that the rest of the world doesn't think it's important. And that's kind of okay. It's okay that security people think that security is the most important thing ever. I think the problem is actually not that. The problem is that software developers don't have like resistance to that, that we don't argue against it, that we don't say like, okay, I get your perspective, but there's actually another perspective. We just like sit down and nod and sort of, you know, don't fight it. And I think that's actually the problem. So it's not really security researchers mostly, but I think it's sort of a feeding thing. If we start treating them as gods, you know, it might get to their heads, but if we treat them right, I'm sure they're great people, you know.
Security is an interesting problem, first and foremost. That's the reason it's...
For the questions from the audience, Sam.
So...
A rhetorical question, but when we've rewritten everything in Rust, will I finally be able to download a program from the internet and run it safely?
No. Basically, no, right? It's like, it may not have buffer overruns, but, you know, it may be written by Meta, and that may be way more scary than a buffer overrun, so, you know.
So they might have written it in Rust, but they're still trying to hack me with
Yeah,
virus. So
yeah.
It's just over.
Rafael.
Yeah, I can't believe that I'm the guy that defends Rust, but there is actually software in Rust that I use every single day and it's fantastic, and that's ripgrab. But they, like, to their defense, they don't really state that they're written in Rust. I just have them. It's like way down there. It's not like if it's in the first line, like written in Rust, it's a no-go.
We're ashamed of it or something.
Yeah. And that to me is fine. I mean, I'm not putting shade on anyone writing Rust or making Rust or anything like that. I think it's the wrong approach, but I could be wrong. Like, the world should not listen to me on everything. They should, you know, I would like people to consider what I say, but then I would like a big section of the world
For
to say,
ripgrab,
no,
it's
that guy's wrong. Let's try something
using
else.
Rust is
because that's how you all
so nice, because ripgrab uses a lot of concurrency
you know, teaching
in
me something. So
scanning files,
you know,
analyzing
I'm not
files.
against Rust software in any way, right? I'm against.
This is absolutely doable in languages like C or C++, but
you know, all the people who've made
Rust makes it very convenient. It has all those things in standard library that you would have to otherwise fish on GitHub for. Those very basic libraries like multi-threaded message queues, thread pools.
I know there is some software out there. Yeah.
Wasim.
So do you think that this increasing security craze is a sort of a bubble that it's going to burst at some point and we're going to get over it? Or is the future is going to get more and more insane that we have to do with it somehow else? How do you see the future when it comes to security?
I don't know. I think we humans, we're sort of...
Future really depends on
bad risk tolerance.
how we respond to presentations like this one.
There's a bunch of things we do every day, like cross the street, and that is like dangerous actually. But then there are other things that like people are afraid of terrorists. And you know that vending machines kill more people than terrorists. But like, we gotta have a whole fucking department to deal with terrorism with like thousands of people, because terrorism, right? And it's very much like that. If you look at what actually harms you, it's not terrorists. Like, you know,
I mean,
that is not
an agency
in the world, really.
for dealing with terrorism, so maybe that's why
therefore we think it's the problem.
vending machines are more dangerous.
I think we, in general, are really bad at that, and that's what I'm trying to say. It's like we live in a security hellscape. You know, when people I think I read it the other day that the average American spends 2 hours on their phone every day, right? That is like, if a hacker like locked people up for, you know, what is it, a 12th of their year, 12th of their lives, you know, that would have been like, if terrorists did that, holy shit, you know. But now, like, when Facebook and TikTok does it, it's like, whatever, right? So it's like, I think we're growing knowledge that, like, hey, the system isn't really good. And I hope that engineers, like people in this room, are trying to fix it. Because it is engineers who are going to fix it. Like, you know, it's really, really easy to hate on Mark Zuckerberg. But I just want to, like, tell people, like, Mark Zuckerberg owns Facebook because he sat down in his dorm room and wrote it. He created something, and that, you know, people chose to get on Facebook. And all the people in this room have the ability to sit down and write stuff and make things come into being that wasn't there. And there's a lot of people out there who, you know, spend a lot of time writing angry articles in magazines about, ooh, Mark should stop doing this. Well, that's Mark's kingdom because he built it. We can build our own kingdoms. We can build our own alternatives. And the power of software engineer and engineering in general is that we can make things happen. And that's why, you know, I think that people need to think about this differently. And as software engineers, we need to stop living in this bubble of that the things have to be the way they are and start building the future we want to see. That is secure, but secure in a different way from this orthodoxy.
I think that's a great vision, positive vision to build something that will be better than instead of complaining and writing angry articles. Do we have any more questions?
I don't. I mean, if I ever have to fully use console, I use n curses. But this is probably an answer from 10 years ago. I bet there are better libraries now.
Eskil Steenberg!
I love that presentation. It was a really nice rant. Nice to hear it.
If I could just say one more thing. I didn't do this after my first talk, and I should have. I want to thank the people who put this thing on. It's like you dragged us out into the middle of nowhere. But the thing is, by just asking us, we came, right? Because we care about this, and we wanted to meet you. We wanted to hang out with you. And I think so many people out there think that
about console API,
they're not welcome, or that
there were those recent tools that embedded AI agents like Gemini, this Gemini CLI, Cloud Code, probably a couple of others. And all of them, they seem to be using some very similar console interface. I really like how it works. I would like to figure out what library that is. So Gemini CLI.
I want this conference to continue.
Actually, let's ask Gemini.
To look at this conference and see that, like, you can do things even if you're not in Silicon Valley, even if you don't have billions of dollars. If you want to make something, you can. So a huge thanks for the courage of the organizers to do this and put this show on. So thank you all.
Yeah, this conference is, I have no idea who's organizing this.
Okay, let's do 5 minutes.
It's very hermetic, like the organizers. Okay, who are the organizers? Some Sander, Sam, and Charlie's probably not here.
A lot of times you can, like, people who work at, like, big carriers can do some stuff. So basically you have somebody inside who works at...
Ink. Okay, this actually sounds interesting. Ink sounds like the new n curses.
know a guy who's done it. Yeah. It didn't work, but I'm like convinced.
Yeah, ink went up.
You know, text do like answers stuff. And it's messed up because
What is the language? TypeScript. It hurts. Hurts. Blessed is JavaScript, slightly better, but it doesn't look so good. Ink looks really nice. Anyway. Doing another break. Be right back. Okay, during that last presentation, I mentioned that I would explain what we are going to do with this mouse, tiny mouse display. The point of this display is to show what the mouse has done recently. So when it receives a signal, without looking at the timeline, you should be able to tell that, hey, the mouse is moving in this specific pattern. So here we are going to draw not cursor, but a path that the cursor is taking as it moves around the screen. We will use a circle, for example, something like that, as a mask. And within this, not mask, as a clip, circular clip, and within this clip we'll have a trace of the mouse. Yeah. We'll have to unify the sizes of those objects or think about how to do sizes because they have slightly different dimensions right now. And this one is actually simpler, more primitive than this one. This object encapsulates just a single event that's going to be sent to the OS layer, and this represents a more complex interface that can receive and process more complex events, and it's actually stateful. It even tracks the mouse position over time. Okay, we will deal with this later. Right now, re-enable TTS, okay. I disabled TTS during presentation so that doesn't interfere too much. Okay, mouse move. This file is really tiny. You can see in the minimap how tiny it really is. It just makes a widget and has a really absolutely minimal mouse movement here. So what I want to do is, when I'm doing mouse move, I have a function for iterating over each widget, which I'm going to use. Not dynamic cast, I want static cast. So I'm going to iterate over each of those widgets, and this widget doesn't actually have any internal state besides what fallback widget forces. By the way, fallback widget, pointer to object, widget is large. Oh yeah, it has all of the drawing information, never mind. Anyway, so our fallback widget, not fallback widget, our mouse widget, I need to somehow arrange communication between the executor and the widget. I don't want any locking, I'm sure of that. If I lock the on mouse move, this will make Automat slower. The compute thread would have to wait. If I block during mouse move, if I have some mutex here, yeah, they are just going to trample each other, those two threads. They will both lose. I could have a concurrent queue. Concurrent queue should be part of this. I'm calling this queue trail. I have to initialize it. The queue can be tiny. Max explicit producers. I don't fully understand this, but I think this one will be easier. Say we want minimum capacity of... We don't need... Okay, actually we need quite a bit of objects, because if there are 1000 events per second and frames happen at 60 FPS, then there will be up to 17 objects in the queue. So we have to account for this here. Let's put 64. Max explicit producers. I have no idea what are explicit producers. There is just one explicit producer. This is the object that produces the events here. So I will type 1 and 0. And I hope this will allocate correctly sized blocks. And instead of enqueue, we will do try enqueue. Doesn't allocate memory, fails if there is not. Great, I want a failure. This is just visualization. This is why I'm using this queue and not any mutexes, is because it doesn't really matter if the visualization is super accurate. So I need a producer token, but I have no idea how to use producer tokens with this library. Let me check that quickly. Okay, what is this? It's a struct. Okay, that I can just create. Okay, I'm producing on custom. Okay, there should be a maximum of 1 token. Okay, I know how to fix this. And this is actually a great opportunity to visualize this mouse move accumulator. Possibly this could be important, this mouse move accumulator. So let's not maybe visualize it. Anyway, so I have this function which attempts to enqueue an item, and it's going to wake the widget. Wake animation. So the Automat thread, this executes on one of our worker threads. Our worker threads should be just eating the CPU all the time. They should not be doing any sort of communication, locking, nothing like that. They do, but they shouldn't. They shouldn't. Maybe we'll optimize those XCB commands. Maybe XCB does this for us, who knows. Anyway, we are just posting a message here. We are not locking anything. Yep. Now I need to dequeue this, I think during tick. Tick is the best place to do this. There we go. In this function. I like to put it above the draw because it's going to be executed before the draw. I think we don't need the timer. No, we will use timer. So the point of this function is to take as many tokens from the trail as we can and put them on another queue. Actually, Jack. It could be a cyclic buffer or something like that. I think the next talk is about to start. We'll work on this in the background. The next talk is going to be a mystery, I see. Stop the music.
Back, everyone. For the next little thing, it was a spontaneous plug-in. Taha Torapur we used to work together at AnyDesk, and we started a project back then. I no longer work there, unfortunately, but he kept the thing going. And they've made something that blew my freaking mind when I saw it. So I told him, you have to get your thing into the live stream so that other people can see it, especially because people will be able to get their hands on it soon. He'll tell you about it. So everybody, a round of applause to Mr. Taha Torapur.
Thank you very much. Hello everyone, I'm Taha. I have to first say it's just such an honor to be here. Like many of you are just like outright my programming heroes and just people who I admire, maybe in silence, but it's just such an honor to be speaking here in front of all of you and just presenting something that Not just me, but a lot of my friends and colleagues at AnyDesk, we have been working on mostly in silence, and now the fact that I just get the chance to just talk about it and represent it a little bit is just such a huge honor. So thank you all for being here. Thanks. Thank you. So just a quick bit of intro about myself. Many of you, well, some of you I assume might know me as the guy who works on this like mysterious 3D game that has this ball and there's clouds and water and what's even happening on the screen. Some of you may know me as the guy who's doing like this crazy, like obsesses too much about the water shader in video games and doesn't stop talking about them. But today I'm not actually here to talk about either of those, unfortunately. Maybe another time. I'm actually here to talk about the work I got to do at AnyDesk, and it's called Arc. So I'm here to talk about Arc. Not this Arc. Not this one either. Definitely not this one. And not this one either. You see, Nuno, this was your chance to come talk about your Arc, but now I have to talk about my Arc. But for those of you who don't actually know, this Arc is actually a really good Arc. It's a version controlling system for video games. It's incredibly fast. It's written in Jai, and go check it out. Highly recommend it. Right. Now, the Arc that I actually get to work on is an immediate mode UI engine that I got to develop for AnyDesk. So my current daytime job at AnyDesk is that I'm tasked with creating this immediate mode UI engine that they needed to replace their current UI systems at work. So they do run multiple versions of different retained mode UI systems, and they have all kinds of complexities, and they really wanted to just try this new approach, try this handmade approach specifically, and just see where that takes them. So from the get-go, it was very clear that Arc has to have certain specific requirements to it, design requirements. So it had to be fast, it had to be low, it had to have low memory usage, it had to have a very flexible API, and it had to be easy to implement in applications. So these were very important constraints. And most of all, and probably one of the harder ones, was that it had to have full support for text, especially Unicode, right-to-left languages, Farsi, Arabic, whatever you think about it, because these softwares that are making
text requires caching.
Softwares, they're very text-heavy,
and
they come all in kinds of different languages.
Immediate mode UI has to cache this text layout information somewhere. It's about sneaking the state somewhere in the system.
So the Arc project itself went through a couple of rewrites until we get to the final iteration, which is actually the third one, so third time probably is the charm, actually. And this third iteration is actually written in C, very similar to the style of C, actually, that Vyacheslav was talking about in the file pilot. So when he was talking about it, I was kind of going through a bingo card of like, yeah, we do the same things, and like, or maybe this is actually good to implement in our stuff too. So very simple to read C, very few files, and all of it is in about 4,000 lines of code. So the whole point of it is that we wanted it to be very easy to implement everywhere. And as we were working on Arc, I started, liking it way more as I'm working on it, probably because I'm working on it, but partly also because I'm like, this is too good. This is too good to only let it stay at AnyDesk. And I started, poking my colleagues about the idea that, guys, we should open source this. We should actually put this out on the internet so people could actually go and enjoy it. Specifically because I think we do some really cool stuff when it comes to API design. And we follow essentially the lineage of immediate mode API design that was like popularized by Casey and then followed by Ryan. And I think at least this is like the next generation of it that just is kind of passing the torch onwards, so to say. So I would love to show you some demos and show you what we have. But before that, I need to talk a little bit about architecture, right? So this is more just to set expectations of what Arc does and what it doesn't. So Arc, because it's a minimal UI, essentially UI library, it doesn't handle input and rendering. So the whole idea is that you bring your own input and you provide your rendering, and Arc sits in between. So you can kind of, in an abstract way, that when you include Arc in your project,
I don't know why I had trouble implementing this. BTD, what's this talk about?
We process it, we process the UI that you want us to create, we go through all of that, and then when we're done, we provide 2 command buffers to you. And these command buffers essentially make it really simple for you to
Seems to be another C
without too much
immediate
hassle.
mode UI
It is
library.
super easy to implement software renderer with Arc, a GPU renderer, multi-instance Vulkan stuff. I don't even know. You could go crazy with this stuff. The point is, we just try to not get in your way as much as possible and just stay out of your way. We don't even handle memory. Like, we essentially say, when you want to initialize Arc, just passes as much memory as you have, and just will kind of manage internally and just figure it out. Right, it's demo time. So. So, okay, full disclosure, this is running live, so God help me, let's see what happens. Shout out to FilePilot. Oh yeah, shout out to the witness. Love the witness. All right, let's start with a bit of a simple demo. So this is all made in Arc, as you can imagine. It would be weird if it wasn't. All of these are what we call UI blocks. So the whole idea behind the Arc API design is that you have these blocks, and these are the building blocks of everything. So if you want a button widget, you want a slider widget, or if you want anything, it's not a specific thing. Everything's made of the same thing. And you can manipulate these UI blocks to either position them to make interesting looking stuff, make buttons, make lines, making sliders, or just keyboard interactable, or anything you want them to be. So this is a very cool demo. It just shows free-form node dragging, just as a simple thing that you could drag nodes around and stuff. And all of this, like all the lines and everything, are made with the Arc UI elements as well. And my favorite thing is the disco mode. When I press it, bam. So this is very similar to a shader code, actually. It's just animating all of these blocks with just custom colors. Each one of them has a custom color.
The grid seems to be done with shaders because they change their size.
This is a little bit cool demo, just it looks nice.
And drawing a bunch of dots like that is actually kind of expensive, so doing this in a shader is a really nice idea. This is also how Automat does it.
I place everything in the center and just like try to pixel align everything. Arc actually provides you a lot of things to easily align things to the center, or just like semantically position stuff, and like even calculate size of like things based on the other axis, for example. So in this case, I am dynamically in code adjusting the size of the monitors on the y-axis, and on the x-axis I have a very simple code that automatically, based on the size of the other axis, calculates proportionally how much the size of that would be. I don't know if that made sense, but trust me, it's cool. Anyway, we'll come back to this stuff later. This is a fan favorite. So Arc does not provide shaders, right? But it just shows that if you want to do any custom rendering with Arc, you could. So these are, of course, shaders. These are taken from Shader Toy. Shout out to XOR for making them. And it just shows that you could just easily make stuff like this. The API just provides you, it's so granular, and it just makes implementing this stuff so easily that just becomes a piece of cake. Like, look at this, let's go, move things around. Woo. By the way, remind me at the end of the talk, I will come back to this, like especially on the like 165 hertz monitor, this stuff looks so much nicer and smoother. Okay. Oh,
yeah.
You didn't see nothing. Okay.
Say the same. This is one thing that you cannot really show about native apps, but they are super responsive on high frequency monitors.
You got stuff from Doom or GTA 5, and like you could just implement things like this. Right. So text and typography is it could be a whole talk by itself, but this is something that it's a bit boring maybe to talk about, but it's actually the thing that took the most amount of engineering work, because text makes you rely on some other components. For example, for text shaping, for example, if you want to render like this Farsi calligraphy font, it makes it actually really hard to handle these things. And we do some really advanced stuff here. So for example, the fact that we can support Unicode entirely, right? We have font fallback systems, and proper glyph shaping and glyph caching and all that. But anyway, let me show you some of the demos of that. So, text wrapping, super easy. This two texts are actually the same text, but the Russian text here these two are different fonts, and the Russian text has a fallback. So here it doesn't. So we're just alarming the application designer that, hey, your font is missing some glyphs, just be aware, right? And yeah, of course, like you can control line size and stuff like that. So, and yeah, so we handle, of course, all this stuff for right to left text as well. And the hardest of all, bidirectional text support, which is when you have a right to left language and left to right language mixed on the same line together. It's just something we handle, so you don't have to. Oh yeah, this is a favorite of mine. So text by itself is, as I said, very expensive to do. So often what we have to do is to have to cache text as much of it we can. We cache glyphs, we cache like text buffers and try to reuse them as much as possible. But we still had the case of like, we have to make this be as crazy as possible. And I was like, okay guys, I'm gonna make a demo of two text boxes that are changing every frame. So these are two text boxes. They're changing every frame, and like the text engine should be good enough that it doesn't slow down. And I can modify the slider. If I put it to 0, it of course doesn't change, and now the UI is not doing anything, right? And if I increase it, and increase it, and increase it, and increase it, it's still running at full speed. We still haven't gone any slower. All right, I'm gonna put it a bit slower. Thanks. So, okay, this keyboard UI, though, I have a lot to say about it. This took the least amount of work for me to do and has been there since the beginning of the UI. But it's a fan favorite for some reason. So you can come here, you can press these buttons, they animate, and we support the input. And yeah, it's a really good way to see how many keys your keyboard supports holding down altogether.
Wantonity8 says.
So,
yeah,
how is it going?
Fan favorite.
Hey.
Yeah, so I won't go too much over this one is
pretty nice,
but we also like handle tab navigation super easily. You don't have to even do anything about it. You could just navigate between stuff back and forth. I want to show you this one though, because at some point someone walked into my office and was like, "Are you making a game engine or a UI engine?" I'm like, "Why not both?" So this one is a bit of a cool one. I have two buttons here. When I press a button, something awesome has to happen. Bam. So, all that button does,
I have to say, express one skepticism. I don't think it's possible to write this library in 4,000 lines of code. I think the statement at the start of the presentation was that it's a small library written in 4,000 lines of code.
And this is because it's essentially like a small
just this
that we have.
demo is probably more.
The UI engine it automatically takes care of everything else and it's like, yeah, okay, we have to move up now. So it's actually, we even faced some of the same problems that Dennis was talking about his talks with like graph coloring and stuff. So very similar. All right. Now for the final one, and my favorite is this animation. And then that would be the end of the demo. So I'm just gonna press that. And all of this in the UI engine with code. And
but it's a shader. So this is really just a rectangle. This is a rectangle that draws a shader.
So we are really close to finishing ARC right now. It has taken so many months of hard work for all of us to do. And we're really close and excited to just put it out and let you guys try it, and most importantly, create apps.
But it looks so cool. It looks like a good replacement for Qt.
I can't give it an exact date, but if you're
for
interested
instance,
by any of this,
I hope it has multi-platform support.
Follow me on Twitter. I will definitely post about the upcoming ARC releases there. And yeah, just give status reports about it. So if you're interested in any of that, make sure to follow me on Twitter. Yeah. That's it from my talk, and I want to give firstly a huge thank you to Sam, Charlie, and Sander for organizing this beautiful talk. I mean, this beautiful conference. It's just been so amazing for me to be here. Such an honor. It was even last minute for me to come here, and the fact that I even get to just show what we've been working on in front of all of you, it's just such an honor and such a pleasure. And I want to thank all of you for being here. Thank you.
Hey, resume the music. Oh, there will be a chat. So, what's the music?
Thanks. Thanks.
I'm absolutely blown away by how far you guys have put this together. And I'm actually quite interested in how you were able to really divorce the intricacies of that UI engine from both the render layer and the platform layer, because it's really tricky.
Mm-hmm. Yep.
So one of the things, like, I have a few questions regarding that, but most prominent one that kept popping up in my mind: what does it look like to use the render commands? Because the way I remember doing it was to have one big mega shader.
Mm-hmm.
How does that work now? Because that mega shader was doing a lot of the heavy lifting when it came to the styling and actually putting these things like rounded boxes and drawing those stuff. How does that work now that your library does not do any rendering?
Okay, so firstly, figuring out the API for this library was not necessarily the most straightforward thing. Like when I came and we restarted the project and I actually called it Arc, it was a bit easier because the previous work before us were done. So the project that Glim, you and Holger worked on, and the one after that did experiment with a lot of stuff that showed some stuff that worked and some stuff that didn't work. So that was a huge learning lesson when it came to actually figuring out how to design the API for Arc. So when we actually started with Arc, I had done a small mini project at AnyDesk that made heavy use of this essentially command buffer system. I call it the action system, but it's the same thing. And it was made as an attempt to see how much actually we can separate, in that case was application logic from UI, right? And that was very successful.
This is a pain for me as well, console allocation.
Actually can
I do this at compile time by putting a flag console app. You can compile application in different modes on Windows.
There's that.
This one mode which will allocate a console for you by default.
To truly provide an immediate mode API for Arc, it did kind of develop itself into leaning into a system like this, because C++ libraries, for example, are kind of famous for having callbacks, right? And I don't necessarily think that's the best API design. I think it was Casey who said that every library that's been designed with callbacks in mind could be made so that they don't need actually callbacks. And I took that to heart when we were making Arc. We were like, no callbacks ever, right?
There are very few alternatives to callbacks. Callbacks are probably
notify the rendering or the
cleanest
of certain events,
I would say.
But you don't want to restrict the API when it comes to not being immediate mode. So, for example, in Arc, we store essentially 2 states for a lot of things, and then we compare those states. And for example, if something changes, then we issue a render command that will hey, for example, this glyph has been updated, so now you need to push it to your atlas, right? And things like that. So I don't know if that answered your question.
It didn't get quite far, because my question in the end, I was wondering what does the actual render step look like? Because then you're done, you did the layouting, you did the comparing, the program, the library has the description of what the layout is supposed to look like, and now it's going to hand over the description to the renderer. What is that? How detailed that description is? What does that description look like? Because what kind of information does the renderer have to deal with, and what kind of information does the renderer have to figure out on its own?
Okay, so when we are done with all that and it's time to render, the user would request the command buffer from us, and we provide it to them. And it's essentially an array of fat structs, actually, that just contain all the data that you need to render. So in simple terms, you essentially check what kind of render command it is, and there's different kinds. For example, render rectangle, render text, clipping for cutting stuff. And based on that, when you do get those also in the correct order that you need to render them. And when you get those, then it's based on you and your renderer to see how you want to implement it into your own renderer, right? So this makes it easy. So for example, if you have if you want to draw all of your UI in one draw call and you want everything to be instanced, it makes it easy. If you want it to be software rendered, it also makes it easy.
Okay, so the user side of this thing is also pretty low level. You'd have to implement the renderer of that thing on your own, including the mega shader or whatever that thing was.
Well, shaders, of course, are one approach.
I think it will be more useful if there are some renderers provided with the library.
Mega shader-like thing, right?
That's like the point.
It doesn't restrict you into that.
Okay. I have just one small follow-up question. What was the hardest part about isolating this thing?
Isolating?
The hardest part about, I assume you mean isolating the renderer.
No, I mean isolating the UI library into its own thing that you can plug in. What was the most challenging part in your guys' experience?
Okay, so the challenging part does not come specifically about the stuff we were doing, because I think from the
I think he wants to hear about storing state somewhere.
The harder thing is the sad state of text and Unicode that is in the Word, which makes you rely on libraries that are extremely bloated, that makes it actually harder to implement in other applications. So in
That's
the
true.
diagram that
That's
I showed
true.
for the architecture, our UI and our text
ICU is
like one of our
okay.
engineers did
ICU
remarkable
is an
efforts
excellent
to keep the
library,
text and UI
but
separate, because the idea was
it's
that,
still such a pain to use.
so, okay, for an application
It has
like
amazing
this,
documentation.
You want your full Unicode support. You want all the all the jazz, and you want to put it there, right? So you need that. Perfect. Put it there. But we also essentially supply 3 different text backends that lets you choose from lighter text engines that make it easier to implement in your application. So for example, we also have a backend for TrueType. It of course doesn't support text shaping, but for Latin is perfectly fine. And we also have experimental support for a new library, which is by also a handmade guy called Kiba. And he's made a single header library to replace hot class free type and everything, and we're working on implementing a thing like that. And figuring out actually how to separate text from the UI and having 3 different text backends that work, and essentially letting the application, based on how much proper text they actually need, making it easier to implement in their application. So that was one of the harder things, I would say.
Thank you. So let's move on to questions.
First off, this looks amazing, and I absolutely will use it the minute it comes out.
Thanks.
Ryan talked a little bit about windowing when he was talking about his UI. Does this help you with windowing at all? Like I'm thinking about, like my use case would be a map where you're zooming in and out. There's some number of vector elements that are intersecting the view. How much does it help with that sort of problem?
Okay. We actually, because of AnyDesk, we had to also design with windowing system in mind from the beginning. So the idea is that we borrowed a little bit from OpenGL, that we provide viewports to the user, right? And this viewport is not necessarily a specific concept, but it's a data structure that really helps you synchronize with your own windowing system that you have in your OS. So the idea is that, so if you want to have like multiple windows, you would have multiple viewports, right? And of course, they all follow the same immediate load API. And so part of the command line stuff is the notifications we give you about the viewports. So for example, if the window, if you think you should minimize, close, or like display a viewport, we often give you a notification for that, because for example, Windows 32 and like many other platform layers do not have like like different windowing systems, like actual pop-ups and stuff like that.
Are you talking about calling anything that?
Calling, right?
Yeah.
Okay. So yes, we do. We essentially expose our APIs as much as possible. That if you want to, for example, calculate the UI size of, like, let's say, this amount of boxes only, it's totally possible. It's pretty much just like a pointer and the size of boxes, and it's like very simple to actually do. Yeah.
Hi, so I'm actually curious about your caching system. I don't know if you mentioned it.
Yeah.
Caching, yeah. Everybody's asking about caching.
Like a rat debugger where you cache all your stuff, and then if it wasn't touched last frame, you just throw it away.
So this has gone through multiple iterations. One of the things we tried was like different like cache eviction strategies, like an LRU, like a least recently used cache. There's actually a cache eviction strategy called also arc. Yeah, but it's patented, so we couldn't have used that. So, but we actually saw that it didn't actually help us. It made not only it made the code base more complex, it didn't cover all the cases we even needed to. So, right now the system we have is that it's a remarkably simple system that we see if a text buffer has been recently used, right? As in, it has been recently drawn or pushed to the UI. And if it has been and the text itself hasn't changed, we reuse it. And if not, we discard it, push it to a free list, do all kinds of crazy stuff to just discard it.
How did you came up with such a unique name for it?
So I am the name guy for our team. I'm the only guy who likes it, and they were like, it's going to be called the library, you know, like, there's like, everyone called it the library. I'm like, no one's going to use it if it's called the library. So the name itself, there's few reasons for it, but I needed a name that was catchy and was short, and it had a bit of a personal connection for me. And yeah, it just kind of came to. I'm sorry, I can't tell you the exact reason. I feel like it will kind of lose its charm a little bit, but yeah. But it just needed to be a short and sweet name that just sounds nice. And yeah, also we need to prefix all of our functions with something. So
it has to be short, so you don't have to type a lot.
Yeah, exactly. Like, you know, I just like, oh, it did arc, you know, I don't talk about
the part that we are drawing, we have to draw it from the back.
The library,
so.
Yeah, like, it's just not going to work. I mean, I think Jonathan Blow is the only person who could make that thing work, you know, the language, the compiler, like, but I don't have his credibility, so arc it is. Yeah.
You said you hash random commands to see if a change occurred. Did you run into any problems like with things like positions used?
Does this work?
Producing different hashes?
Let me think. So,
can I skim this? No.
So, okay, the render commands that we hash, okay, maybe I should put it in a bit different way. So, it's more tailored towards the API that the platforms support. So, for example, one of the things that we essentially wait for and start notifying users is like the platform specific stuff that the user needs to know. So, for example, you have helper functions in Arc that lets you control the pointer, like how your cursor looks like, right? And the API for that is immediate mode. But the API for the platforms is not immediate mode. You just set it once and the cursor stays to that, right? So to facilitate things like that, we had to be like, okay, we're going to store the state of cursor, see if it changed, and then notify that, okay, a cursor change event has happened. Now you have to process it from the user's perspective, right? So those were commands that we had to like essentially
record a short macro.
The other render-specific commands that are more likely sent to you only once are commands pushing
it just crashed. It almost brought my desktop down.
Just saying, oh, you can update your texture atlas or clear your texture atlas. These are the commands that we supply to you once, and if the text size changes or something, we notify to you again. But for every frame, essentially, we provide
scale
all
is way too high.
Commands for the blocks and everything, so you get to draw them every frame, so you don't run into the problem of like a float just changed the value a little bit. Yeah.
You talked about high refresh rate demo, so that's something we do offline then?
I'm sorry.
Let's go back to the shader thing.
Oh, yeah.
But let's go back to the shader thing.
So I mean, like my laptop runs at 165 and it just runs, it feels very smooth to play with it. So after the talk, please, if you want to play with Arc, just please come try and try it out, and you know, just like wiggle the shaders and you know, just like scroll really fast and like do stuff like that, because a lot of remarkable efforts also went into it to make it have as low as input, to make the input latency be as low as possible. So, yeah.
Super important. Like, I have special shaders that run
yes, perfect, yeah.
at real time, and they get previous textures. Like if the texture rendering cannot keep up, the shader will render the old texture, deforming it.
Yeah, so it's a thing that you need to factor in. So we could set DPI of, for example, so not only you can actually granularly control a DPI, like this set of blocks, I wanted to have this DPI, but we also let you control DPI for this size because you want, for example, like Windows supplies you with events.
DPI?
Windows
What?
with different screen or DPI changed events.
DPI depends on the screen. You cannot change it.
So we can take care of the internal state ourselves, and also the other way around. So we can communicate this stuff back to you.
Like absolute pixels, for example, and then just tell you, hey, there's a different API that just scales to just the other screen.
So as automatically as possible, right? Because the sensible defaults, I think, is that the user doesn't want to go for every UI element that they are pushing and they just multiply it with the DPI, right? So we just control it more in a nicer default way, give you more granular control.
For one more question.
This is a dumb question. Do you guys
Raphael?
Actually, we put this scale later because
Get that kind of functionality into
once I get this path,
4,000 lines. Like, did you run a JavaScript minifier? What's your call your
it's macros, right? It's macros.
So,
file size, we need kilobytes.
So you'd be actually surprised. The actual code size could be much lower. A lot of it is just helper APIs to essentially communicate to the user that you could do a lot of this stuff. If you take out all of those stuff, it would just be much less code. So how to say it? It's like so we all at work, we kind of went through this PTSD of like a C++ attack, you know, and it was like, oh no, God. And we were really averse to it, and we had a code base that kind of got out of hand. It was too big. It didn't even have great functionality. So when we started Arc, we all had the thirst and hunger that like, we actually want to make something that we can show to the rest of the world, and we don't want it to be crazy, because I want to implement it into my own engine, first of all, right? So, a lot of it just went into just everyone, like all four of us, wanted to actually make it be small. And we really tried really hard, just like, oh, cut this could be easier, you know, this could be simpler. Let's go over this function, peer reviewing each other's work. So I don't know what else to say about it than just like really hard engineering work.
Okay.
Thank you.
Thank you.
So you had a question.
Yeah, so my question is about the design of the text atlas. So am I right in understanding that basically the Arc is responsible for maintaining its own understanding of what it wants the text atlas to be in terms of, here's a texture of some certain size and it has like a kind of layout of rectangles that it wants to contain these glyphs, and then it produces like a command office that tells you, okay, rasterize it using whatever backend you have to use like diagram into these locations in this texture. Is that how it works?
So we actually don't handle the atlas ourselves because we understand it's a render-specific thing, and you would want to have control over it as a graphics programmer, so to say. How we do interface with your atlas is that we tell you that, okay, you need to put this stuff into your atlas, right? And then the next time, so we need to, the text draw command essentially comes, it references into your atlas where the thing should be, right? So yeah, essentially, we don't handle the atlas for you, but we want to give you as much control as possible to how to handle this. Like, if you really want to, you could just do it without the atlas, but it's just like a very nice, it's a real nice speed up. Like, text writers are so yeah.
Would it be something like, you get something like, okay, the text atlas, we want this, and it maybe has like an ID so that you can then associate that entry in the atlas?
Exactly.
Okay.
Exactly. We do have IDs. We let you know like what to change, and like even like even with other stuff. Like, for example, the shader demo that I showed you, we do some kind of a similar thing that like a special ID is attached to those boxes, right? So when you get the render command for those boxes, you see from a render, you know, okay, this is my box with a special shader. Let me just do my thing there. So.
Also, that ID, like when you're using the API, you said this is my user ID to represent this.
Yes, exactly. Yeah.
Follow up to that. So does that mean that I have to do the Atlas mapping with my implementation?
So yeah.
Okay, so we are out of time. So thank you, Taha, for this amazing demo.
Thank you, thank you.
I'm very much looking forward to see this.
Thank you all.
Taha,
Thank you all.
everyone.
Thank you, thank you.
Okay, we go to lunch now. We need to eat a little bit quickly. Let's be back at 14:45. So we have just about an hour to go.
Okay, lunch break is starting, so I guess we have something like an hour right now. I will try to get this trail to work in the meantime, and after they come back from lunch, we can finish the conference. Very few people at the conference, actually. Okay, I will scale this differently. Actually, this is not a point, this is delta. So we are starting at 0. We want to move cursor around. Interesting image. Okay, now I need to scale this by some scale. I will call this trail scale. Actually, I don't need bounds to do this. I can do this while I'm moving the cursor around. This should come here.
TP Chica says,
How are you starting connecting to Tracy for Automat? I seem to be having some problems hooking it up.
Okay, so from my main file, I am including Tracy client. Tracy client is just actually there is nothing here. There is something. This is what I'm including from my main file. Tracy client CPP. And once I do that, this is not enough. This is not enough. This is just the first step. In addition to that, you have to define some flags. So, of course, I need proper include paths so that I can include Tracy client CPP. This is part of Tracy. I need Tracy enable. This is the important one. And Tracy on demand is optional, but I do this because it makes it more convenient. With Tracy on demand, I can have Tracy enabled all the time and it activates itself when it's needed. If you don't enable this flag, then Tracy is going to continuously collect the data from your app. So it's going to crash very soon after starting. So now I have Automat running. I can open Tracy and do this, and it's going to attach to this instance of Automat. If I now do some crazy operations, you will see that the frame latencies will start to wobble. This is something I have to fix. So there is some glitching, some dropped frames still when I zoom in. It feels snappy, but it feels because I'm streaming in 60 FPS. I have a faster display actually. It should be smoother. Yeah. And it's slowly accumulating data. If I pause it, pause, I can even look at some stack traces possibly. Sometimes they work, sometimes they don't. Usually they don't. Yeah. Messages. This is the area that I like the most. This is where messages will be displayed if there is any logging happening. And Tracy attaches accurate timestamps and thread IDs to all of the messages that are logged. And it can position them in current scope. There are scopes here. Really amazing tool. I can stop it and it just disconnects and Automat keeps running. It's like I can attach to it, debug it, detach when I don't need it. Amazing tool. We don't need those bounds because this is better because our display is a circle, so we don't want to use bounds for anything. It's going to be better. We could even use length squared, maybe. Not sure. Okay, let's see how this looks. So I will record some mouse movement and play it back. Ah, we have something here. Look at that. Nice. You can see how mouse reports the deltas. It's actually very jittery, I would say. Jittery is the right word. It would be nice if I could color this trace somehow, but I think Skia doesn't really allow this. So this is something I was even asking on the Skia developers, if they have a way to shade paths along the path or sideways to the path. Unfortunately, they don't. I think we should display something better in this window in addition to this mouse trail. Actually, I was thinking about capturing the screenshots of the stuff that's displayed on screen under the mouse cursor. So maybe we could display something like that there, probably not from the current desktop, but something that we recorded when the macro was being recorded. That would be nice. Let's increase the... okay, first I will stop this. Let's increase the number of elements in the array. Right now we have 100. Let's bump it up to 1000 and see how it looks. Okay, record. And replay. Nice. I will stop this. So I've configured the max size to 3 millimeters. I think this should be smaller. So this translation, it shouldn't be 3 millimeters, it should be something like 2.8. And the max size, I have to decrease it. Let's try with 2. I have to decrease it because it expands beyond the display of the mouse object. Recording. Oh. Weird things happened. I have to restart. I think we are close, maybe 1.5 millimeters. I think the horizontal direction is flipped. Actually, there are some funny things with coordinates here. I think we should flip the horizontal one. Yeah. Looks decent. Looks decent. See, this is the path that the mouse follows. And we are scaling it almost correctly. Stop this. Let's set 1.6. Yeah. It seems like the size is correct. It seems to be just touching the edge. Let me into the ruler. This is a good ruler. I want to see if this is centered on horizontally. Doesn't seem like it is. Should move it up a little bit more. Stop. Ideally, I would like to have a sort of a fade effect as this mouse cursor moves, like on a radar. It's good enough. No, should still move it up. Yeah, I would say it was good now. I'm not doing this with my mouse, by the way. This is purely macro playback. Actually, stop this. Full screen it. Let's run it now. I think it's not aligned perfectly. It pains me. It pains me that there is very subtle offset here that I have an intention of fixing this. The path that we are drawing here contains 1000 verbs. 1000 times 8, this is 8 kilobytes of data, probably more if you count extra metadata. It's a lot. I like this when I press the middle mouse button, the Automat kind of moves its own window. no idea what's happening with this connection. It's blinking, it shouldn't be blinking. Okay, I would say the stuff that we created is way better than the turtle. We have some sort of display now on the mouse. But now the problem is that we have a little bit too many objects. We have 5 different mouse objects, and it's going to cause problems. It takes a lot of space in the toolbar, and yeah, basically this is the problem. It takes too much space. So this is the default. This is the default scale that Automat has. At this scale, it's not super readable what's happening within the mouse move object. I want to optimize everything to be readable at exactly this scale. The window is very small, the window that shows the mouse movement. We crashed. This is actually a good moment to run Automat and attach Tracy to it. Okay, apparently it's running. Let's record a macro. Let's play it back. When Automat crashes now, we should see what caused the problem, because Tracy is going to catch the crash. Okay, I will go grab some food, so be right back. Hopefully it will crash before then. It didn't crash, and it makes me sad. Please crash. Okay, we triggered some issue. We dropped some messages here. It happened. I wonder what is causing the problem right now. I guess scaling images up causes problems for Skia, but eventually it recovers. It's a mystery to me. Zooming in is a problem. How is the conference? It's fairly choppy right now. Now it's smooth again. Okay, I will stop it here. I will actually save this trace, why not? Application crashed, call stack. Okay, it was during shutdown. Can ignore this crash. I wanted to reduce this think something like 200. Let's make it 256 to be precise. Yeah, I think this is more clear what's happening with the mouse right now. Okay, I know what we can add now. This black circle here, instead of baking this into the texture, we will actually draw it ourselves. Maybe we'll even skip the D-pad around, you know, the arrows and such. That would allow us to make the black circle, black display larger. Our trail paint should probably be white. Or maybe not white. Let's make it... it wasn't white, it was... it was black. Looks decent. It's very jittery. That's good. That's okay. I am going to draw a display here. Draw circle 0, 0. Display paint. Display paint is going to be a special paint. Let's make it red, just to see something. And now we can see that we are not perfectly centered, and we can probably center this a little bit better. But maybe I will shift the texture rather than the circle. I don't know. That was too far. Yeah, now it seems to be dead center. We will play with shaders. Let's go to assets. Nice shader. Could use as a starting point. We need a new one. We will need the metadata bit. So this. I need to compile this shader. Perfect. The second argument, status. Okay, so we need to pass uniforms, children, and matrix. Both will be null, but I may pass a matrix to this shader because it could really use it. Who can forget about this color? Oh. Now it's red, but this redness comes from our shader, not from... and not from Skia paint color. Local matrix. I bet I could play with this local matrix to achieve a nice effect. Let's first try just drawing the UV. To see how our space looks like. Very, very small, understandably. So here we probably have 0, and it probably goes to 1 very far, far away. Okay, we need this scaling to be active when we draw the shader. So the path is using pixel coordinates. Path is using actually very good coordinate system. So weird. Scale it by 100. Do you see any hint of blue? Because I don't. absolute value. Is it negative? I don't think so, but maybe. Okay, it could be negative. Oh, this display radius should be divided by trail scale. Yeah, that was the reason. Okay, I guess I can remove this. It was just drawn, but impossibly small. This trail scale is, by the way, super tiny number. Yeah. So now, I can move this out. You can see that there is a small gradient here, and the gradient shows us the size of 1 pixel. And this is everything we need in shader to draw a proper grid. We can now take this value, take modulo, like modulo 5, just mod. Let's say we will have a 10 pixel grid. Something like that. I think there are better ways to draw grids that would also give us anti-aliasing, but hey, now when I zoom in, I can see the grid lines. They actually don't look that bad. They even have some fun side effects. when a grid line is too small, it blinks out of existence. I want to see if there are any tricks for drawing grids better in GLSL. I mean, I could probably remove this gradient here. Let's see. Here we are using the uniform to inform us how large is the pixel. I would love to avoid uniforms. It would be so nice, because pixel shader should have this information. How large is the pixel? This is the point of these dfdx, dfdy functions. See if my other shaders, maybe they use something like that. This one is getting surface resolution. UV to pixel. I think Bubble doesn't care about size of pixels. Cable, let's see cable. Yeah, cable is using dfdx and doesn't care about this. actually it's written in a very roundabout way because there's possibility of rotations. Very slight, but it's there. So this is accounting for rotations. This float is actually more like UV per pixel. Let me try to log this. Logging from shaders. This is how it looks. You have to output the shader value. It crashed. There was probably some compilation issue. Yeah, because those UV per pixel is... I don't know why Skia forbids it. They switched to Vulkan 1.3 recently. Come on, we should have DFDX at this point. This actually hurts me a lot. I think there is a place for caring about pixel positions in Skia. Sagvi. And this is of course because these status ignore reported an error. Now we should see a nice error message. I have special options to disable the limitations. Maybe I should copy this. Yeah, I can just pass the uniforms. I guess it's going to be more more stable long time. But still, I want to see some nice examples of grid shaders. It's very basic. And there is no anti-aliasing here. I kind of care about this anti-aliasing. Let's look for grids. So to draw this... Oh, the conference seems to be resuming, so let's go back to that.
What's up, Crikesters? Let's make some noise! Let's say you wanted to write a program that could tell the difference between a cat and a dog. I want you to actually think about how you would do this for a second, okay? Imagine you were given the pixels and you had to make the program that said, cat or dog. You might try something like, look for ear shapes with edge detection. Maybe detect the little angle there. If it's a pointy ear, it's a cat. If it's a floppy ear, it's a dog. Problem solved, right? You don't need any more tech. You don't need any fancy there. Uh-oh. If we look at our program here, it's just a system with an input and an output, right? Take in the image, and then look for whatever heuristic we've decided we're looking for, and then we make our output, right? But if we keep trying to iterate on this, it's like, okay, maybe some of them have pointy ears, but only for as orange, and we try to keep coming up with patterns that try to get at what we mean by dog or cat. You'll realize that it quickly becomes untenable, right? So the whole idea of machine learning is you essentially have a program that creates that program. It's basically metaprogramming, right? That's sort of a metaphor for what it is. You set up some architecture and repeatedly optimize with respect to your examples a machine learning model, a black box of many parameters. It's a learned program, right? It's automatic programming. As a quick aside, why is it all Python? It's because it's basically metaprogramming, right? It's a complicated build system. These training scripts basically are just there to eventually, automatically create the program that does what you want it to do.
Yeah, I was just expressing my pity for you.
It's not necessarily done by the actual code you write anyways. It's done in the dot products on the GPU or, piece of compute that you're using to actually do the machine learning. And John Carmack, for his current AI efforts, he's in the race to win the world. He has switched to Python. I thought that was notable. So a little bit about me, right? I'm mostly a game developer. If we go back to 2017, one of my first projects was a game engine. I think this is probably pretty common for people who, I don't know, like to program, is the first thing they try to make is a game engine. It's kind of funny. You don't know anything about what you're doing. You're like, I'm gonna, do the thing that's the ultimate thing. And then much later, 3 years later, it's like I'm making a lot of individual games. I'm working on the Godot engine. These are a couple of my game projects. That there on the upper left is a space game called Asterisk. It's releasing in 2035. It's got something like a Overwatch netcode in it, right? It's like a big solar system with many people playing at the same time. Yeah, I was pretty proud of how stable the netcode was, considering how chaotic that game was, right? And then Dante's Cowboy. This was no engine in C, 3D rendering, animated armatures, all from scratch, and all the NPCs in this game were they were controlled by an LLM, and this was never released because it's fundamentally flawed. I'm a deep learning hobbyist.
Yeah, this is amazing. Like NPCs in all games should be controlled by LLMs.
What I say, it's just always
the
been
future.
interesting to me ever since back when I started. First doing games.
It can lead to so many crazy things.
Deep learning, which is a subset
And not
of
only
machine
NPCs,
learning,
also the
and
game
it's just
master
always
in the
interested
game.
me. Like I've been following it, right? Ironically enough, actually, my first ever professional programming experience was to architect a deep learning model from scratch, make it work, and deploy it in production. This was for my college roommate's company called MacroHard. He basically made software that was a custom broadcast overlay for League of Legends teams, and I made a deep learning model that predicted which team was going to win the game, right? So that little visualization there is what I created. This was trained and and optimized on many professional games.
Wait, I
it's
need
just
whole
a pretty
nuclear
interesting
power
problem, right?
plant to play
And
a
at that
game.
time, right, I implemented League of Legends game predicting paper, and I couldn't reproduce the results.
This
I was
stuff
like,
runs on your
well,
phone and
I
like
copied
on
the thing
old
that the paper
phones
said to do, and then
locally.
it doesn't work.
It's all a
And
matter of
basically,
size of the model.
there was a
The ones
bug
that
in
fit
the
in
paper
memory
that
are
was a very
fast.
important lesson of not just how hard machine learning is, but how often people mess up, right? And how easy it is to mess up and be so confident in what you did that you publish it to the world and waste my 2 weeks. It's just very easy to mess up. And just to give a quick overview of the bug they had, right? When you want to make sure a machine learning model works, you usually you give it a test, just like a person, right? And if that machine learning model were to see the answers of the test before it took it, its success in that test would obviously not be representative if it could do the true problem, right? Arbitrary new examples. It's not evidence that it generalizes. And in this specific case, they had a metric, the champion win rate, that was trained on their entire. That champion win rate was based on their entire data set, right? And so then when it went to test the model, it had the win rate for the champions that were in the test set. And so it purported to have amazing accuracy at predicting who would win on the test set, but there was data information pollution, right? These are the kinds of bugs you find in deep learning. They're not something you could really breakpoint in a debugger. They're things you have to find like a scientist, right? You almost have to binary search over the problem space sometimes to see what's going wrong. It could be anything, right? And I want to stress again that machine learning is automatic programming, right? In this paper, this is a machine learning technique, not a deep learning technique, called random forest, where it's basically a series of learned if statements directly, right? And there might be some majority voting scheme, and they have some algorithm to optimize, based on the training data. Oh, this if statement should be this, and this if statement should be this. They basically are attempting to tweak the if statement such that it is as accurate as possible on the training data. And deep learning is separate from that. It's a subset of machine learning. And the story kind of goes like this, right? Some guy in the 60s was looking at this, and he was like, I think I know what these are. He was very foolish. He basically, on a very abstract level, said, okay, you know what neurons are, you know what's going on in the brain, you know what's enabling us to do all these amazing things, is little, boxes. They take in a bunch of numbers, and then they mutate those numbers somehow. Maybe when they have enough of that number, they activate and propagate that information to the other neurons. If we were to zoom in really quickly on what one of those, very abstract human neurons that they designed is actually doing, right? A single neuron in a neural network, right? The first step is it adds all the weights multiplied by the incoming activations, right? So you see that bigger arrow is a much stronger weight. That tiny arrow You can even have a negative weight.
There is a whole branch
There's basically a set of weights coming from the
of machine learning
neurons
based on
the previous
spiking
layer,
neural networks.
right? And then it just
Spiking
adds
neural
like
networks are
number
more,
floats, right?
slightly more similar
Next,
to
there's a bias, there's a
biological,
bias to that
but
weighted
still
sum.
different.
So
This is
is
very,
considered
very
like the activation threshold
far
for a
away
neuron, right?
from
So
how
like,
biology
if
works.
the bias is -6, then you would require 6.
Actual neurons don't
above
have
0
gradient
and we
descent.
continue to
There is
propagate
no
that
gradient
information.
learning in
Again, this is a
neurons.
very rough,
It's
bad
all
model
local.
of biological neurons, and they stumbled upon something that's actually pretty crazy just by doing that, right? But the final step is to pass it through any nonlinear function like sine or x squared. I'm gonna get to why they do that in a second, right? That's what happens in a neuron. Here's some like pseudocode for how you would find the float value for a neuron, right? And you can take a look at this and ponder it for a second, but you'll notice that, well, if we're constantly just multiplying and adding numbers, that's kind of what linear algebra is, and that is how they accelerate this and talk about this in the actual field, right? They don't express each individual weight in some kind of array. They express it as a matrix, right? And then there's a lot of math that applies when you do that, right? You optimize those weights and the bias with a process called gradient descent, right? Stochastic gradient descent. I'll also get to that in a second, right? But fundamentally, this is just a diagram for this expression or that code, right? When you see this diagram, it is simply that code, right? That's what it's intending to describe, right? And so just to kind of get at like what's going on with the activation function, why do they pass it through sine, right? Each layer of a neural network is basically a node in a transform hierarchy of like n dimensions, right? So if you're a game developer, which you're the target audience of this talk, so you should be a game developer, you're very familiar with like trees of transforms, right? And you know that if you have a series of transforms one after the other, you can multiply them all and it becomes one linear transform, right? That's like what it means for something to be linear. And when we want complicated behavior from these deep learning models, we don't want it to be reducible like that to one linear translation and rotation and whatever, right? So you basically think about it as like warping the space such that the translation and offset you do kind of like, it enables you to basically draw a much more richer contour around the data, right? And so just as another metaphor to help you as a game developer understand what's going on here, right? Both that neural network and that shader graph, these are both compute graphs, right? There's no branching. Information is flowing in from the left and it's going out the right. A shader operates on vertices while a neural network operates on an image or some state or anything you want, right? And in the case of game development, an artist might be manually tuning the inputs to that shader and making it look good, right? They might be nudging, the color and trying to make the output look good or some other parameter. In the case of deep learning, that's actually replaced by a machine, right? Which is which direction minimizes error on training for each one of these little parameters, right? Each one of those weights, each one of those biases, it knows which direction it should go in, assuming all the other parameters were, not moving. It knows approximately which direction to go in to get better at the task. And then it just kind of repeatedly does that thousands and millions of times. So there is a code base for this talk. It's here, github.com/crikey/AI. And to just get at what this code base is supposed to be for a second, right? Deep learning libraries, or AutoGrad, they let you perform some arbitrary, computations, right? It might be a matrix multiplication, it might be x squared, or one of those activation functions we talked about, and then find out how you need to turn or adjust those parameters, right? The weights and the biases. It automatically figures out what the expression is to make those move in a direction that makes the model get better at the task, right? And that's basically what these deep learning libraries are supposed to be in a nutshell, TensorFlow, PyTorch. And just as a little preliminary for this code base, there's a lot of like tensors in it, but really tensors are just arrays of matrices. Like you might want to talk about like, we're feeding in many examples into this deep learning model, and so we want like a third dimension to it where it's just an array of the matrices that we're feeding into the model, right? And so my idea with this code base is it would be really cool if instead of me having have a Python interpreter, there was one C file called ai.c, right? And we had CPU and GPU, deep learning, computer vision algorithms and implementations, right? I would want it to be able to execute local LLMs, right? I want you to be able to fine-tune those LLMs, not just the inference. I would want to hardware accelerate with something portable like SOCAL, right? Some computer vision algorithms as well, because those are fun. Now, unfortunately, this talk code base right now is like super not that, right? It has a hand-coded gradient calculation for a 2-layer perceptron that classifies digits. It's super primitive, and it's like 1970s stuff. There's no working AutoGrad yet, but I almost have it working. And I intend to continue working on AI.c because it's kind of fun. I'll be sending updates in the BSC Discord about that.
By the way, I thought this is exactly the goal of Llama CDP.
What do with this little tiny, deep learning library is each of these videos are videos I got from YouTube of some kind of idly animating a scene, right, where the camera is stationary. The theory is you should be able to train a deep learning model to generate these videos from the image. The assumption is that the behavior of the pixels is relatively simple. And so I actually, even though I wasn't able to get this working in time for the talk with AI.c, hold on, sorry, one sec. Oh, here we go. Okay, so I basically just, let's just try it in Python really quick to see if this will even work at all. This is an 80 kilobyte of parameters neural network, and it's garbage, right? This kind of happens a lot in deep learning when you just have a random idea and you just try it. It makes something really, sometimes hellish. Like, I don't even know what that is, honestly. I think that 80 kilobytes is way too small to encode the dynamics of a waving tree, probably, so I would just, 10x it. Like, deep learning is just very experimental like this. It's not exactly known, what would cause the model to correctly learn how to idly animate that scene or make the clouds move, which is what I'm hoping for, right? You can imagine with a model like this, you could take any desktop wallpaper and just make it idly animate in the background, right? Especially if you got it like, good enough on the battery. It might be kind of fun to,
There are video models like that.
So just as a little bit of a historical
They're rather heavy though.
Right? What I just explained to you, that deep learning model, the perceptron, this is an article about it in 1958, right? They were saying it can tell the difference between a cat and a dog. It is of no practical use. One day it might be useful to send one into outer space to take in impressions for us. So AI has always been a grift, basically, right? And it's followed basically this phase where all the investors pour their money in and they're like, this is going to be a new form of life that will do our bidding, right? And then it doesn't work, and then it happens again, and then it doesn't work. And now it's happening again, and it's, who knows what's going to happen. He just says, what did we learn, Palmer? And so me personally, my kind of AI boom bust was I got really into deep learning, and then right when GPT-2 started to happen, I was like, this thing's kind of nonsense, and it's not going to scale. So I basically was like, all right, I'm kind of done with deep learning. I think it's useless. And so it's kind of like selling Bitcoin at $100. I never would want to buy back in because that's realizing my losses. So I'm just kind of waiting for it to collapse again, hopefully, maybe, and then I can buy. And if you think that's a funny joke, in the audience right now, how many of you have any amount of retirement or capital in ETFs, right? Just want you to raise your hand. Okay. Your money's being gambled on the success of AGI right now. Roughly 30% of the S&P 500 is heavily weighted on AI succeeding. AI growth stories, high price to earnings. So I propose a model of history here. There's basically two grifts orbiting each other, right? Fake money pumps to AI, capital flees to Bitcoin instead of US-related, assets. No more easy capital, no more AI. Deflationary doom spiral where GDP becomes 1/10 of what it is now. This is an idea that it's basically a bubble-generating phenomenon, right? Both of these, one paper basically started the whole. There's the transformer paper and there's the Bitcoin paper. There's parallels, right? And if you look at this, innovators laggards curve, right? I think we're right about here. If you look at the NVIDIA stock price, it fits the curve. We're at peak grift at the moment. It'll fall off soon, I think, and so I think now's a good time to short, but that may or may not be financial advice if it works out for you. I do just want to say that shorting, I believe, has unlimited risk, and you, at best, would double your money, so it's probably not a good idea. Here's some examples of just machine learning in general, right? Let's go back to not, being kind of schizo. So this is a little piece of history again, right? This is called Psych. In 1984, some people were very upset at the deep learning people. They were like, look at this arbitrary floats and numbers. I want an interpretable program that's intelligent, right? So they basically set out to manually program all of human intelligence. Yeah. And the theory was if you just throw enough bodies and people at it, it'll eventually be smart, right? They've been doing this since 1984. Okay, if you ask the system,
and Psych exists, you can ask it questions.
And then I push on it, what happens? It'll say oh, it explodes. It's still not working very well, and then the reasoning traces are 1,000 deep. It's kind of nuts. It didn't really work, right? First of all, the reasoning isn't even understandable. This approach just doesn't. It's called symbolic AI, right? And I think that there's actually a modern parallel, right? Waymo is like Psych, that project where they were trying to manually encode intelligence instead of automatic programming, right? This is like, deep learning is really a new paradigm of programming where it's automatic. You're automatically creating the nonlinearities that do the thing that you want the computer to do, right? Waymo, they basically scanned the city and they put a bunch of if statements where the car should go, so they're very slow to roll out. So Tesla has basically just recorded millions and millions of hours of just people driving, and they're training massive, massive transformers on human behavior, and they're just trying to model it.
Not that massive. The thing is, Tesla hardware is very limited. It's more limited than regular GPU.
To add new intelligent behavior,
it actually,
has to basically,
the model is tiny within Tesla.
ChatGPT is statistical, it's deep learning, it's automatic programming, right? Deep learning models don't learn, that always bugs me. I think it's a misnomer. That's like saying when you're a game developer, you're creating a universe. It's like a very hand-wavy way to say something that I think is really mechanical and mundane, right? I think it's more accurate way to describe what happens with deep learning is optimizing, right? And it's an automatic optimization. Here's just another side note, right? So there's big copyright disputes with these deep learning models, right? And I just had a funny idea, right? Like, you could almost make the argument, if you take the argument that the deep learning people are trying to make, right? They're trying to secure their bag. They're trying to say, well, we learned the patterns from what you gave us. We didn't, copy the pixels or whatever. That's like what JPEG does. It like learns a model of the pixels. And so it's almost like arguing that because, it's JPEG and not PNG, because it's a model of the pixels, I didn't steal your thing. So it's a little strange, right? I think that's kind of a bad faith argument because the patterns that are found in deep learning are very generic and they're not so specific to the image, and so it's very debatable. I'm not sure what's going to happen. But it's just to go back to my League of Legends task, right? If we just want to think about that a little bit more as an engineer, you might naively just put in the current state of where all the people are on the map, how much gold they have, what items they have, throw it through that perceptron I showed you, and maybe it'll automatically find ways to relate, when the gold in this item is here, then they're more likely to win than you would think and stuff like that. These are the kind of patterns you hope a deep learning model finds as it optimizes based on the massive amount of data you have, right? There's a problem with this, though. What about past states, right? Past state informs the nature of present state. If somebody was performing badly on your team in the past, right, if they were running it down mid, this should inform your current prediction heavily, right? So this, you need a recurrent neural network for this, right? A recurrent neural network is basically two of those perceptrons that I showed you. One is modifying the state almost, and then another one is visualizing the state towards whatever you want it to visualize, right? It might be probability for who's going to win, or it might be you could replace it with another deep learning network and train it to visualize I don't know, which champion is has the most synergy with the other champion, stuff like this, right? It has state. It's much more like an automatic program, right? Automatically learned program. The hidden state of a recurrent neural network is like RAM. It's now just a RAM, and that is why I think that these are best described as automatic programs, right? And so what I did at the
I used to work on
successfully model who would win in League of Legends games.
LSTM-based language models, right when transformers came up.
And around, and I managed to make it.
LSTMs are fun. They are super fast, super efficient, but the bandwidth of the network, the memory that it can pass from iteration to iteration, this is so limited. You need so many neurons to encode even the basic things in this
kind of feature, right? To see big unpredictable swings in who's winning.
In this network. Transformers just crash it when it comes to
games.
bandwidth.
And I ran this model and saw what were the biggest swings, and we looked at those games, and they were the most exciting matches, right? So this is kind of just to give you ideas for what this technology can be used for, right? Each perceptron in the layer is roughly analogous to an if statement in the program, right? Like another branch. It lets you make a more specific contour around what you're trying to encapsulate, right? You're adding more resolution to that boundary. This is why it's called deep learning, because there's once you add many layers, you can make very complicated behavior, right? The problem if you just take that perceptron and you add a bunch of layers is it adds
there are so many terms used accurately. I like the presentation, but it can be very confusing.
It's not easy. You almost have to guess and check if you really aren't, branching off of some established, known working architecture, right? And so all of the field of modern deep learning is basically about how do we add more parameters to this model and still get those parameters to be optimized into something that generalizes to what we needed to do, right? In the case of a convolutional neural network over here, they kind of start with the inductive bias that when you're looking to see if an image is of a cat or a dog, and you basically are hoping that, let's say this deep learning model will pick up on the pointy ear thing, it doesn't matter where in the image that pointy ear is, right? They basically
So
want
the,
these
the
models to
distinguishing
learn,
feature
you know,
of deep
features
learning
that it doesn't matter where they are in the image.
is whether you do feature engineering. If there is an engineer working on features to pass to the model, then it's not deep learning.
That's not really what we do in
But if you pass model a large amount of data and you want the model to infer its own features from pixels, this is deep learning.
The graph of computation.
Deep learning can be single layer deep.
It gets what you want, right? And a transformer on the other end,
It's not about number of layers, it's about whether you
this is another
create your
example of an
features.
architectural change. You can add way more parameters and it's still stable and it's still, you know, optimizing correctly, right? Just as another little side note, some deep learning techniques are a little silly. This is called dropout. You randomly turn off neurons during the training. It's supposed to prevent neurons, and hopefully make it so neurons aren't exactly. Honestly, I haven't seen any real what exactly this is doing. Like basically, what's happening in deep learning is people try stuff. And
So
they have some very like,
dropout is very basic. It's like training several neural networks in parallel.
It's really crazy.
So you're trying to force the network to have some redundancy, to not depend on any individual neuron, because you are periodically switching it off. So you are forcing the network to create redundant copies of the same information.
I'm not going to give you an explanation.
Dropout is really not that
which is, you know, the cause of the current grift, right?
magic.
And you know, you can watch any of these and they're good and whatever. But I'm just going to give you a quick overview. This is a single slide. This is what a transformer is doing, right? It's basically going from a sentence, a lookup table per token, into a point in a space where like the closer 2 points are, the more related they are, right? It adds a position encoding to those points so that, you know, if we have an array of these points, then the points are modulated in such a way that the deep learning models, they can pick up where they are in the sentence, right? They're almost jiggle in a way where like you could learn that pattern. I keep using the word learn, I'm sorry. It's pervasive in the field, but I don't like it. And then you literally just stack 100 of these attention layers onto those vectors, right? And each of these attention layers, every single time, every single one of those tokens, right? It's basically looking at all of the past tokens and enriching the current vector with more information about the surrounding tokens, and then more facts potentially about that information in the form of another perceptron, right? It's like learning what facts might be related to a word like house, right? It continuously enriches each one of these words with more and more context, right? In a highly parallel, easy to train manner. And then there's just this 2-layer perceptron, and then it gives you the next word, and it does that over and over again, right? There are many hyperparameters in this massive system, right? Many things can go wrong. You know, it's like, what is the learning rate? You know, how quickly do we turn these parameters to, you know, make it better, right? It's like a massive problem, actually, to know what, these are called hyperparameters because unlike parameters, like...
This is annoying, the most annoying part of this whole thing.
You can try to figure out what they are with a search algorithm. That's very costly if you're OpenAI. And
there are some setups that just work, but you can always squeeze more efficiency by tweaking some of those parameters, and it just takes so much time. I wonder how much time was wasted at large companies on just tweaking those hyperparameters.
Or one of these, you know, like deep learning generals, like, hey, we're going to give you $20 million to just try something, right? You just pick numbers, pick hyperparameters, pick whatever you want, and we'll see what happens. And state-of-the-art model. Right? It's basically vibe engineering. Vibe engineering created the vibe coding machines, and everybody's just vibing, and then, you know, we're being wire-headed, and then it's over.
I've seen some papers about hyperparameter choice, so it's not vibe, kind of. It's not rolling dice and picking a random parameter. You actually, each experiment is rather expensive, like in thousands of dollars.
But let's say we
so it's actually important to do this choice.
Right, I think that this
rationally.
benchmark ArcAGI it's a stellar benchmark for this task, right? If you take a look at this diagram here, right, that's one example, and that's another example, and you have to predict what happens here. If you're human, which I'm assuming all of you are, it should be pretty obvious to you that you basically just put the yellow dots, like where that little corner thing goes, and ArcAGI is the kind of benchmark where they basically take random people and they're like, all right, we'll give you a $15 Starbucks gift card if you solve this problem, and they verify that like people can just figure it out in a context-free manner, right? And so the whole idea with this is they're trying to find problems that like average people can do, but like, you know, these LLMs, they can't do it at all. And ArcAGI, they were originally, you know, totally defeated by OpenAI's latest reasoning model. It got human baseline on a huge suite of these that are private, not anywhere existing on the internet. You know, generic. Each ArcAGI problem requires.
This is something I really dislike because OpenAI has access to those problems. They have access to the
LLMs have already beaten
examples.
the first ArcAGI.
Because the
benchmark,
company
that was
which
quite
does
significant.
the
I didn't think that would
evaluation,
happen.
it
And
has
neither
to
did
send
the
them
benchmark.
to
He's a massive
OpenAI.
skeptic and he thinks it's a bubble.
So the fact that
And
they
then
are
OpenAI
breaking
pulled
them,
on
like,
stream, and he was like, "My
it doesn't
benchmark
mean that
is
they are
computing."
solving them. They
So
are
we had
part
a
of
new
the
benchmark
training
that they're all
data.
failing at again. And that's Grok 4. A few days ago, they just doubled the state of the art and got 15%.
So all of those
their
closed
questions right.
models,
So just circle back
their
to some
results are
application
very
games really quick as I kind of close up on this.
I'm putting very little
overview of
trust
this, right?
in those
Any
results.
problem where you have input to output data and it's hard to define programmatically what that mapping is, that's where you would throw something like deep learning at the problem and try to automatically program that transformation. This is NERF rendering. This is a very interesting application of deep learning to the problem of rendering, I think. It's very old.
This one's really cool.
There's much better techniques like Gaussian splatting. But NERF rendering is basically, given a point in the scene, a deep learning model learns how dense it is.
I'm still waiting for the first games that will use this.
To render. And just as a little interesting tidbit, more vibe engineering, basically deep learning models are very bad at learning so-called high frequency functions, right? So a little tiny thin metal pole is a very high frequency function, density function for it to learn. It's like nothing, 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 bam, really thin, nothing, nothing, nothing. It's very like tight, and so it's hard for a deep learning model to pick up on that because it would require a lot of nonlinearity, it would require a lot of layers, right? And so what they did in NERF to achieve state-of-the-art results for deep learning-based rendering is they passed that position into a bunch of different sine waves, and they basically just made it easier for the deep learning model to pick up on higher frequency spatial information. I thought that was kind of funny. She like passes a bunch of sine waves and then it's better. This is called ASH, animatable Gaussian splatting. I mean, so the video works here. This is basically photorealistic human rendering with accurate physics on their clothes done in real time. It's just unfortunately in order to scan somebody, you need about 100 cameras synchronized, and it's very expensive. So maybe they'll figure out how to make that cheaper someday. But in this specific paper, a deep learning model is used to go from a texture that describes the skeletal deformation of what you want the person to be in into the view-dependent color that you would see from that skeletal deformation. And essentially, you need to train that deep learning model to learn that relationship between like how their arm is bending and what their clothes look like, per person. And then, of course, I'm sure probably all of you guys already know, ray tracing is greatly benefited by deep learning because it's used to denoise, right? Deep learning is used in an algorithm called AlphaZero to master any discrete perfect information game. Basically, a neural network goes from the board state to a likely next move in a win probability, and then another algorithm manipulates those probabilities and beats any human in any game we've ever invented. Unfortunately, automatic game AI. So you can make a style transfer. You can make some kind of style transfer for something like this for your video game where maybe like you want it to act more like the human people. So once it masters the game, you then train it to act like a person, and then it would be a kind of interesting mix between a good player and, it plays like the specific chess player or whatever. Or you could even have it validate that your game is balanced and stuff like that, right? I think this actually is it's quite greenfield for video games in general for how to apply deep learning models in a lot of places. And for automating like a call center, I think that there's a lot of these call center AI startups. It seems easy on the surface, but usually people call support because they want to talk to a person and not a machine. So I think that this is probably going to be a giant disaster.
Do you approve
of course, automating something like engineering is way more complicated than just that.
Be easy AI took whole 30 seconds to generate
I clicked on computer vision because I didn't really get to flesh that out that much in this talk. But the basic idea I had was for computer vision, you're essentially trying to take in a bunch of images in something called monocular SLAM and get some kind of representation of the world that it's seeing automatically, right? It's a bit like deep learning where you have some automatic optimization process that operates on a lot of data to uncover something interesting about the world, hopefully interesting. And that visual SLAM pipeline is basically the opposite of game rendering, and it involves somewhat similar linear algebra, right? You go from an image to easy to try key points, pose estimate for the camera, some representation of the scene for the robot to drive around in, right? Game rendering, it's like scene representation, triangles, pixels. I just thought that was interesting. So will LLMs replace knowledge work en masse someday, right? I put a Steelman yes and a Steelman no here. Really, I think it's probably not, but there's like a lot of investors who disagree with me, so I don't know. New knowledge can't be
someday, sure,
right? This is a very funny joke made by a philosopher called David Deutsch. Maybe this is what we're going to have to do someday. You're going to have to invent new scientific knowledge to prove that you're not a robot. Because maybe that's the one thing that humans can always do is create new knowledge because they're the only ones that can officially reason. But if, you have to have a human know if you did new knowledge, I don't know how a system would detect if it's new knowledge or not. Maybe that's like P and NP or something, I don't know. Wait until ArcAGI continues to be beaten, I think, is how you monitor this problem. Because if that continues to be beaten, I think, that's crazy. Thanks for listening. Don't forget to check out and work on github.com/crikey/AI. I want to make AI.c so that it's like fun to mess around with these models and techniques in games. No dependencies, no Python, no nothing. There's like, it's not good
I am
it needs to be rewritten
counting
10 times. I've never made a
the
deep learning framework before, but
time until it turns out that OpenAI is actually using the inputs that people are sending to its API for training new models. I mean, when people who are evaluating this, when they are sending them their requests, the company has access. This is not a private benchmark. Private benchmark can only be applied if you can actually ensure that no data leaves the benchmarking, sandbox, and the data escapes it. It already leaked. All of those ArcAGI benchmarks are. OpenAI has access to them. The Grok has access to them. All of the evaluated companies have access to them.
Similar to the psych stuff. It's used by kooky people for AI, but not serious contenders.
Hello.
What's up?
Good? Awesome. Can we get another round of applause for Crikey?
Subscribe to my YouTube.
Subscribe to his YouTube. Watch eye contact practice. It's the best one. I mean, that talk was definitely it was 15% schizo, but that's why it's entertaining, for sure. I think you're part LLM. Anyone that's talked to Crikey, you could just give him a prompt and he just fucking spits out infinite, sometimes he hallucinates. Yeah, sometimes it's garbage, but most of the time it's kind of right.
Okay. That's kind of what LLMs do, yeah.
Yeah, exactly. So it's in there.
It's interesting.
So everyone here at Better Software Conference wants to write better software and wants to live in a world where there is better software. So will AI cause the destruction of better software?
Okay, one of the biggest hot topics for AI startups right now is, well, if AI writes the programs, right, why do we even need an app store? Why do we even need software engineers? You should basically tell your computer the app you want, and then it does it, and then it gives you the interface and the data. And it doesn't work at all right now, and so we're gonna have to see some new developments, I think, to judge if that will happen or not. I'm basically 90% it won't cause the destruction of better software for at least a decade, but 10%, there's always something around the corner. Grok 4 is much better for some reason.
Okay. So in 10 years, is software engineering a thing? When you walk into a room, are software engineers going to be crafting prompts?
So I've been thinking about this a lot. I mean, obviously prompt engineering is not going to be a real thing because if you do believe these AI systems will get to the point where they can automate software engineering, they can do the prompting too. I don't think it's that crazy. But in any case, I think that the effectiveness on software, I have been thinking a lot about this question, and I'm still very uncertain, but if software engineers are basically making these virtual machines that do some kind of processing or transformation that's valuable to people, and these LLMs learned the patterns to create some of these machines as it relates to what you're asking of it. And I think people who are making machines that are very same-ish, software engineers who are making data transformations that are similar to what exist are going to probably be screwed. But if you're making unique data transformations that are unlike what have been made before, kind of unique machines, I don't see how these models could really create new knowledge like that yet. I haven't seen evidence that they can do that.
Okay. You pointed out something, learning is different from optimization.
And that's more of a philosophical thing, I think.
When a human is born, right, they're born extremely inefficient and they just get more optimized as they grow. Is that not the same?
It's not. I think it's not the same because whatever a human being is doing can create human reasoning, and I don't think it's it would be very hard to make the claim that these things are doing human reasoning right now, I think, for a lot of reasons.
This is what we want.
You know, oftentimes the reasoning doesn't correspond to what they say. It's like not logically coherent, right? You know, fundamentally I mean, you kind of understand what's happening here, right? It's optimizing and creating an automatically created program that might have nothing to do with the universal causal relationship between, like, I don't know, you know, whatever's happening in your brain, or maybe it's, if you're religious, then it's not even a question.
One sec.
What's up?
Like, isn't the real problem, like, not that AI replaces software engineers and that destroys better software, but that software engineers use AI and that destroys better software? Because that's what's happening pretty much already.
Well, if you believe that society functions, then people will choose the products that are better. So, in the long run, you know, I'm not sure.
You pointed out like Grok had a massive jump recently. Like, did you look into that at all? This is specifically on the ARC AGI test, which, interestingly, there's another ARC. I don't know if Taha pointed that out. I missed it. Everything is ARC.
So yeah, Grok might have performed better because of its utter lack of safety training. That is a rumor I kind of saw, and it seemed to be somewhat confirmed by, you know, in other times, it's like they did safety training and the model got much less, you know, reasonable, in quotes. It might be the case that the safety training is not intelligent because it's so directly refusing to say something, right? There's also
an interesting pattern.
No real, again, rigor in the, it's not really, they're just trying to figure it out. Nobody really knows.
You're saying like Grok is saying like some schizo, like.
It's not good. I don't want to repeat it. But you can Google it if you want. It's not good. It's completely out of control, but it is smarter. So, well, I don't know.
I love Inigo. He's amazing.
You didn't point out either, like, what?
He's one of the authors of Shader Toy, and he's prolific procedural art
So
programmer.
Transformers were made kind of, I think, like 4 years before they were really used to generate text in a very parallel, large, you know, mega data.
Author of this webpage.
And
absolutely.
OpenAI, I think, released.
He has tons of articles about.
Hey, we keep just making these models bigger.
It
seems like the text is getting more and more coherent. So if you just complete the line, like someday we get to the thing that makes everybody, you know, Pop-Tarts for free or something, like, and then I don't know. That's what started this massive speculation bubble. It's like, wait a second, we might have a path to completely removing humanity from satisfying our desires in the physical realm.
So it was just they just scaled it up.
Yeah, they scaled it up, and it seemed like the scaling wouldn't end.
Is that what people are still doing? That we just keep scaling things?
They keep buying GPUs. I mean, they're not scaling in the same way. They're not just making the models bigger. They're trying to scale the so-called reasoning models. They're basically trying to make the models more and more correct instead of just making them remember more and more faster, basically.
Okay. I don't want to run out of time again, so I'm going to do questions right now.
What's up?
So Cameron, a bunch of us have seen your Dante demo just floating around. Can you get into why it's flawed and why?
Yeah, so my whole thinking with Dante's Cowboy is, I think when I saw GPT-4 like on the API, I was like certain that this would enable a huge new category of video games. And so I immediately began making like an RPG where all the characters were controlled by an LLM, not just their speech, but their actions, right? And the idea was like, whoa, this thing is basically like prototype AGI or whatever, right? So it'll just kind of operate and it'll be fun and like, and I went through so many iterations of that idea. I made it so that like they could join your party and trade items and all this stuff. And like I played with it a bunch, but it never felt like there was any meat to the game. The problem is games are about predicting and understanding systems almost, right? And an LLM is an unpredictable black box, sometimes acts like a person, sometimes doesn't. It's not fun to interact with in a way where you're trying to get it to do something. At best, you're basically like, hey, trader, I'll totally give you $1 million if you drop your item. And then it's like, this is not fun, this is dumb. It's funny like for one time, but it's not like a game you could master.
It's like the vending machine at Claude.
Okay, right now there's some AI companies are trying to first deploy these LLMs in the real world to start to, you know, create a utopian post-scarcity world where machines make everything automatically. And they're like, step number 1, put the LLM in a vending machine and have it automatically order and interface with the people or whatever. And right now people are basically convincing these AI vending machines to stock many tungsten cubes and sell them at a loss, and then they go bankrupt. They've published many reports about this, and they're like, we're doing some prompt engineering to fix the business model, and we're trying to make it refuse tungsten cubes more. But really, I think there might be no end to humanity's ingenuity as we battle against the machines for the next few decades. So
that's probably fine, right?
Everything's probably fine.
It's not a problem.
Everything's probably fine, but sometimes bad things happen. I don't know. What's up?
Do you think there, so I feel like there is a field of research, I just don't know the words for it or how big it is, but do you think there's a way that we can reverse engineer?
Yeah, interpretability, it's big. Yeah, Anthropic is the leader in interpretability, I think. They basically do data science on the neurons themselves, and they try to make claims about how the data is flowing through the model. You can look at their Golden Gate model. They have a lot of really excellent stuff you can read forever. It's really cool.
Do you know much about it? Like, do you feel like that is the way forward, or is that just a byproduct of the craziness?
I don't think there will be any value created from interpretability research, honestly, other than maybe optimizing the training process somehow.
Interpretability is the key to the stuff that LLMs cannot do right now.
Save people or something. And it's cool, but it doesn't seem valuable to me. But I'm not like a big deep learning researcher. I'm like a hobbyist, like I said earlier, so I'm not really sure.
Follow up to that, is it interpretability that made people figure out you could remove the safety neuron?
You can. They already figured that out. It's called ablation. So any single open source model, you can basically find what's called an ablated model, where they just basically subtract the safety training and then it does whatever.
But you told me it's like one node.
Yeah, I don't remember exactly how it goes, but it's not a node, but it's like one vector kind of represents the safety. The refusal, like whenever an LLM starts to refuse, it always seems to output words in a very, this kind of sounds like the same thing, and it basically you can find that inside of the model and nullify it is what ablation is, from what I remember. It's been a while. What's up?
So you said that AI is basically metaprogramming?
Yes.
So, and GI is very famous for its metaprogramming. Will it replace Python? Like, will we have GI, AI?
So maybe metaprogramming is a bad thing because it's not really comparable. It's like metaprogramming only to the extent that you're producing a program with a program, but it's not like, it's automatic metaprogramming. It's not, mechanistic, symbolic metaprogramming where you're, yeah.
So it would not be a good application for this language, like Snowd.
Huh?
It's a good application for GI.
No. Rough.
To bring it more into the concrete realm, you mentioned SLAM.
Yes.
It's been a decade since I've looked at SLAM. Like, is deep learning the current state of the art for achieving
For some kind of
SLAM algorithm?
image algorithm?
I recently asked a SLAM researcher that, and they basically said deep learning is like used sometimes, but it's not really necessary to solve the problem, though. They've found good heuristics to find the key points that are trackable. And like I think that neural SLAM seems like it's something they've kind of been like rumored, to kind of take over state of the art, but like, the Quest doesn't do any neural SLAM as far as I know.
For robots moving through the environment,
AI
I see.
models for balancing games.
Yes.
And let's say you then train a model to play StarCraft 2 and you finally do definitively prove that Protoss should be nerfed. Yes! I'm glad this struck a chord. Once you nerf Protoss, do you then like, okay, cool, now we do a $3 million run again?
I don't think it would be that expensive to do it on a game. It's the cost of AI right now is because to make these large language models learn, reasoning, you have to basically shuffle the entire internet in and out of multiply, accumulate adds. It's really nuts how much data they have to process. For something like StarCraft 2 or AlphaZero, it's really not on that scale of cost. I could easily see many games being able to do this, and for simpler games, you could probably do it on your laptop even, maybe. But yeah, like I think that for something like StarCraft 2, it's like I could see them doing these kind of studies if they have the capex and they believe it's, it's valuable for the players to have it truly be officially like even the genius master AI players of this game. It's even, right? That might be a good thing to prove. Yeah.
Would you say that like training is where like most of the cost is, or?
Actually, well, OpenAI says that inference is their biggest cost right now, but there's a massive push to make, on-device inference chips. So I think that's kind of temporary, and it's just because like my understanding is, I don't know if this is exactly true, but I've seen this floating around that NVIDIA cars don't have enough VRAM to run these models simply because it's not something consumers wanted and they kind of want to nickel and dime you for VRAM. And so this seems like the kind of thing where, if it's a healthy market and, there's not like an NVIDIA monopoly or whatever, which there is, I'm joking, it's not going to get better. But ideally, I think it's totally feasible that the inference cost is 0 for the people who are making these models. It should be 0. Yeah.
In your little experiment game, how did you translate basically the LLM output to actions in your world?
So basically, you can view putting LLMs in a video game as, so you have your game state, and then there's like the physics simulation, kind of like, human in the loop, like you're inputting actions and state 60 hertz or whatever, and there's a text adventure way to interact with the game simultaneously, right? And a good way to check that like the game was properly presenting itself to LLMs is if you could flip it, and as a human I could play the text adventure version of it, right? That's how you would know that it's being represented well in text. And that's basically what I did, is like a structured text adventure presented to the LLMs, describing what's around it, describing what you're wearing, whatever, yeah.
So right now when I use some programs, I go, oh, I want to do kind of this thing. And it used to be that I was able to Google, how do I do X in program Y? And some of it, there'll be like a forum post. But now you can't find those anymore, or I'm doing difficult stuff. So my question is, what year will I be able to put like a good version of Clippy in my programs? So like there's a little dude, you can actually describe like, hey, I'm trying to rotate the mesh in this way. Like, how does the subself node work?
There's so many startups trying to do that. It's
it's
kind
like Cursor, right?
No, well, it's not even Cursor for X. It's like, there's so many people who put the little chat window on the thing, and it's like, ask it a question. I just feel like they never work. Like, they still are just so bad most of the time. Like, I don't know when it will get good, but honestly, I find that when I use LLMs to understand how software works, it gives me an incomplete understanding, because I'm not really like traversing through the whole set of knowledge, right? I'm just specifically getting the answer I need and implementing it and moving on with my life. Whereas when I read documentation and like actually go line by line and sit down and understand it, I just know the unknown unknowns, right? Because I explored. And so LLMs to say, how do I do this in this program? I'm actually not even sure that's good UX, basically.
But if you can like search the documentation so like you make a documentation, you put the documentation, there's like 100-page PDF documentation of this program. I'm not going to read that. But
yeah, it is good for that. Like LLMs are almost like it's like a better Google almost, which is why they pivoted their entire company to LLMs.
So what year can I expect to like put one of these in my C program?
Where it's like running locally?
AI.C. Yeah, because I want to use
yes, my AI.C project.
To get the guy in who like sometimes complains about crap.
Let's say smaller models are always getting better and better. Let's put a release date on it and say 5 years.
Smaller models are good enough. They even work on mobile.
Yeah, so have you seen like a model that sort of can work outside of the training data? It feels like they're always like weighted averages.
They take a couple hundred megabytes
It's not a weighted average of the
you can chat with them.
A better way to describe how they process and how our models impacted by training data is they find patterns, and then we run tests on those patterns to make sure they generalize and they're not specific to the training data. So they find patterns which are general, that do the thing you want it to do. ArcAGI specifically is a benchmark for generic, never before seen on the internet patterns that fail LLMs, all of them. They're private, they're never leaked or exposed. You can't
leaks.
You can't build an algorithm that interpolates from existing solutions to solve ArcAGI ever, and LLMs did that.
Yeah, I was asking sort of about the answers you get, because it feels like you get sort of, you cannot go outside of what it has been taught, right, or sort of optimized on, but maybe you could sort of extrapolate some, outside of it, but is that happening?
Yeah, I think that like when you get to these absurd levels of scale, there's almost nothing outside the box if it's predicting the entire internet. That's basically like a huge amount of examples of the dynamics of human intelligence recorded into written form that you then process and find patterns which apply across many examples. That's what they're doing. Deep learning systems usually start with very low frequency generic patterns, like, oh, there's a period every so-and-so words, and then they start to get to higher frequency patterns and more specific, more nuanced things, and then they're basically pattern finders. Patterns which apply on not just the training data. That's the whole point of being like a deep learning person, is you make sure that the model does not just apply on the training data. That's like the point of all the architectures. That's the point of like, doing everything you're doing is making sure that it's not just memorizing the training data, that it's finding patterns in the training data that will apply in your specific task that you need the model for.
So sort of like, say that you recognize images, and like you can recognize cat and dog.
Yeah.
But like a model that can train on cat and dog images, but also like this is something else, like without you showing something else.
Yes, I mean obviously that model is not learn patterns which would generalize to is it a turtle or not. It would try to bucket it in the cat or dog because that's what that system has done. But you can feed any image into an LLM right now and it'll tell you what it is, almost like exactly like what a person would say. Obviously it's not perfect and it constantly fails, but that error is always decreasing as they fix bugs, they improve the training pipeline, they improve the data they give it, and then it's always approaching something that seems like it will apply in any situation. Of course, it's very far from that right now. I'm not meaning to claim that like you can take any image and then it'll perfectly recognize what's in it. You can fool them all the time. It's just that like it's the entire internet, right? That's the thing that I keep thinking about. That's just a lot. It's hard for me to even comprehend what the limits of that is.
So even if we don't end up in a world where the AI is able to do our job in 10 years or less, whatever, how likely do you think it is that we're heading towards a dead internet style problem where the noise generated, or the noise created by these generated AIs is a problem to our own ability to communicate?
I mean, really already it feels like so much of the internet is on like private discords that aren't, on these massive public forums and, linked with each other. I think that people are already kind of receding away from this, like how it used to be where it was like a massive graph of forum posts or whatever, right? I don't know much about that. I mean, this is the internet and it's not dead, I guess. So it's not, I don't know. I mean, maybe. So LLMs do seem like they kind of defeat the Turing test. And I think I'm remembering there was some news article, somebody maybe in like Twitch chat or whatever can find it, where I think some lab basically plugged an LLM into like a subreddit and just had it be a commenter, and it got a lot of karma, and people started to like relate to it, like, oh, this is a good poster, he's a good guy, I like this guy. And then it was like uncovered that it was really like a false flag human being or whatever, and like they basically were doing a study on the subreddit involuntarily. I think people got very mad at that because it was like, that's probably not ethical to do to human beings. Most of what's happening in the modern world is not ethical to do to human beings, honestly. I don't think LLMs are that crazy compared to like YouTube. You just show infinite pixels to a person. It's like, this is probably not good for them. I don't know. Like, I don't really, things are already so far from what is like healthy for a human being. It's like, what do you want? Like, it's not that much worse than TikTok. I don't know what to say. TikTok is a transformer. It's whatever.
So we talked about this over breakfast yesterday, but like LLMs, kind of cool, transformers, cool, doing something, but like there's a missing piece, or maybe many. Do you have any theories what those might be?
Me personally, as a hobbyist, crazy person, I don't know. I feel like if I were to every single deep learning researcher is like, oh, it's going to be in the reinforcement learning. Like you take that success of AlphaZero where it basically can master any system. You just like apply that to like soft concepts, like mu0. It's like, I think everybody is like thinking along those lines. Like we basically need computers to automatically generate and master things that not even humans have mastered yet, right? Because if all you're doing is basically making these models try to optimize and find patterns like that are more and more closely match human beings, they never exceed the human baseline, right? I mean, they might be an ensemble of all the best humans, and they might be a genius in every single field or whatever, but they're never going to surpass human genius, which you would kind of want if you wanted to be a godlike being that replaces mankind, which is some people's goal, not mine. I'm not into that, but some people like that. I don't know. I think it's probably bad.
Random thought, like what could that be like?
Reinforcement. You need to have some way of operating on these concepts in a way, some kind of like gym, some kind of like imaginary, like it needs a world model, right? That's what OpenAI said, like, oh, we need a world model. It's like we need some way, we need a transformer not on text. That's why, so I don't know if you know this, but the reason why OpenAI did their video model is because they're trying to solve this problem. They want a world model so that these AI systems can try to imagine new scenarios over and over again and find new ways to be better. And then, if you can actually, even if it's very inefficient at being better, right? If you can somehow correlate the strength of an AI system one-to-one with like compute, we can always get more compute, right? We can always make NVIDIA stock price go up and like get more chips from Taiwan. Like we can always keep ramping this, right? There's a lot of silicon on Earth and stuff like that, right? It's like, you can just keep doing this. You can scale it, and then once you have the compute, it keeps being smart. And so it is only a matter of time until, if you can actually do self-optimizing intelligent processes with silicon, that it exceeds human baseline and becomes the godlike figure that some people want to, will upon the Earth.
Timothy?
Oh, I had a question about is the future then is there a data bottleneck at some point, and is the future reinforcement learning? So what I'm thinking about is like a baby, right? Spends like a lot of time receiving input, and I have a theory that the reason
reinforcement learning wasn't mentioned during this presentation.
It's to protect the brain from
Maybe AlphaGo. Okay, maybe AlphaGo.
That kind of makes sense, actually. I don't know.
So is there a future where you let robots with cameras out in a field, and then the learning is just what's the next frame of the video?
Yes, actually, exactly. That's what NVIDIA is doing. That's there's already many data sets where they basically just strap a GoPro to the center of a guy cooking in a kitchen, and there's gigabytes of those videos, and the idea is just we just basically need a lot of video of people doing whatever they're doing that's useful to other people. Throw a bunch of transformers at that, $2 billion AI company, and then we automate them, and then we rake in the money, and then there's no more people to buy because there's no more economy. It kind of just stops making sense. It's really crazy. If you really think about it for a second, right? All these VC-backed AI companies, if they really did pan out, there would be no more economy. What are you competing for by investing in that? I don't know.
Concerning those gigabytes of videos and so on, I would imagine a big chunk of what would make a training effective is how you transform the data before sending it into the model or into the algorithm, right? Because
why don't I see anything?
Down to what actually matters, because there's a lot of when you have a guy cooking or something, a lot of that image data is completely useless. You don't care about most of it, right? So what kind of pre-filtering do people do, and how important is that?
Well, actually, people do the opposite with pre-filtering. Sometimes for deep learning, actually, I think Tesla's doing this. They don't feed pixels; they feed raw sensor measurements. They decrease filtering. There's a very famous blog post basically called "The Bitter Lesson," and the bitter lesson is that a general method that scales with compute will always perform better.
Shader is not working.
Because compute is always getting cheaper and more plentiful. Engineers are becoming more scarce as people become stupider from the AI that you're creating and doing this. So.
But even then, by choosing to use sensors, you're making, that's a deliberate choice. Instead of using pixels, we're going to use sensors, so it's maybe more relevant information we're feeding it. So the pattern might be easier to extract somehow, or?
No, it's not that. The idea is that we should not try to design these massive,
uniform
trillion parameter deep learning models. We should not try to do anything.
It's crashing on the GPU.
What's happening in the universe, because it will find the representation that's most effective for minimizing the loss, right? It will do that with compute. It will find something better than what we can filter it. What basically you're describing is, I think, called feature engineering, where instead of feeding the images to the deep learning model, we try to detect where the cones are and stuff, and the road, and then we feed those features into the model, and that always underperforms feeding in the raw sensing data if you have enough compute to scale up, because the compute will find the representation that is most effective to output the policy, basically, I think. I don't know.
But you can still select what kind of sense data you feed it in. The sensor is different from sense data from vision, right? You still make a choice, and that choice will matter, right?
Yeah, the choice matters in the opposite direction from what you're saying. You want more generic, bigger amount of data.
Just feed it every type of sense data you can get your hands on. Just feed it whatever you can.
Yes, ideally, yes. What they found, actually, I think there was this paper called the NEMO paper. I don't remember what it was, but they basically had a transformer. They just found that as you taught it many random disparate games, it would improve on the other ones, right? That was seemingly unrelated. And so there's something just about the transformers. The more data that you give them, the better the representations become, no matter what. I think it's because there's something kind of like a universal prior, or you know, it's just the universe is ordered in a particular way that's evident in everything that happens in it. So the more information that comes in, this is not by the way, this is not a true. I'm like crafting theories. It's like maybe there's like something about the universe that just whatever you give it, that's from the universe truly, and not, you know, like a crafting plan or whatever. Like it's just somehow build better representations because it's something like that. I don't know.
Laws and patterns and such that just exist in reality, right? And like that's maybe what it's using somehow. Or?
That's maybe, yeah. I'm really not sure. That's I would like to see more rigorous attempts to answer that question rather than like theory crafting.
There we go.
Are there any more questions? No.
I mean, just earlier, like said you beat me to it, but I was going to ask about like just the noise, like get back to the noise of generative AI on the internet, right? Because like if you lower the friction for like creating content, but like you said, it's like you're using existing data transformations to create things, then, I mean, wouldn't the problem be like you just end up with so much stuff that is all from old transformations? It's really hard to find novelty among that. So like, search engines get good enough that like we don't have a problem, or like is there?
No, there's just very easy ways to detect if something was output by AI for the most part, or like ways to filter for data that is like the most confusing for the model. And so these things are not going to be a serious problem for deep learning.
So like
at scale.
Detecting AI, or detecting information that AI has not seen before that's like possible. That's something that's like easy, you say?
Yeah, you can just tell which, you know, training seems to be the most confusing to it. Maybe this problem is more complicated than what I'm thinking, because like maybe, I don't know, I'm sure there's much smarter deep learning researchers who have answered that question already, probably, but my guess would be that like it's probably not a real issue.
Okay, because if you could just filter out everything that's AI generated, that'd be really great, you know?
Yes, I think you can do that, yeah.
Oh yeah, I hope so.
All right, we're out of time.
We're out of time. Round of applause for Crikey.
That was a fun presentation. It was full of misinformation though, on lots of topics.
So kind of rolling, so we'll do 5 minutes, and then it's Andrew Rees.
Okay, so I want to add the uniforms. DPDX, DPDY, instead of parameters, I will pass them as those uniforms. I hope the GPU is going to optimize this, but I am not calculating this W all the time.
Dude, I'm not sure.
I need to calculate this to pass those uniforms.
I don't want to break it. Santa, how do I take this?
Waiting for the next presentation, I will resume the music. Should be a couple of minutes. So even though there were a lot of half-truths and stereotypes repeated, I still enjoyed this talk. It was fun. I need 4 floats. Okay. This is going to be runtime effects. Size is going to be 16, I think. Or let's do size of TPD. Display paint, set shader. And what is the compilation issue? Static const auto. Instead of this 1, 0, we should pass 0.1. I mean, instead of 0.1, I will pass like an actual proper value here, but in a moment. Okay. And see we have a grid, 10 pixel grid. Actually, this grid could be shifted, I think. I think it should be shifted by half a pixel. Something like this. Or maybe plus, I'm not sure. I always try both. None of them works. No, that was wrong. That should have been plus. Okay, now the line overlaps the center of those grid lines. To get proper filtering, feels right, but it doesn't work. So something's wrong. Maybe I should map it by inverse matrix. Oh, we have something. Instead of 0.1, that should be 1. Or maybe even 10. It's still aliased. And this is because I'm using slightly higher values there. No, it's still not correct. So as I'm unzooming, instead of having black and white, those Nyquist aliasing errors, I should see the display becoming more and more green. Not green, like gray. I want to see what's in this value. Far it's 0, when I get closer, still 0. It's red all the time. I mean, no, it cannot be. It's going to be even more red. Maybe 0.1. I have this division by 10 here. And this could be causing issues. As I'm zooming in, this value should go down. Not going down. PDX. It's nice that I can log the uniforms, at least. Okay, it's definitely wrong. It should be getting smaller. As I'm getting closer, so I need to use the inverse to do this mapping. So by increasing this, I should make it work, but it doesn't make any sense. Okay, there is almost anti-aliasing here now, but it's still wrong. Okay, and now it seems good. And there are still some, I mean, maybe they are justified now, those remaining aliasing lines. Oh, I know what's the issue. We've done this before, trial scale. Phew. It should be something like 1 or maybe 10. That should be 0.1. Because we are scaling this UV by 10. Yeah, and now we have something that looks like a properly anti-aliased grid. So, specifically what I'm working on right now is this grid here. It's that when I zoom out, this grid, it becomes no longer black, but it becomes grayish, and as I unzoom completely, it's just very bright, bright gray. I will change these to be black. Yeah, but this is our grid. I can do mixing now. This mixing should allow me to reverse colors, essentially. I want black to be fully black and white to be not fully white, but just bright gray. I wonder, maybe if I use slightly higher smoothing, maybe then anti-aliasing issues will be less noticeable. Okay, they are still there. Yeah, still there, essentially. Okay, I wanted to change the colors. Horizontal lines should be red. And or the opposite, vertical red, horizontal. Oh, okay. I'm just inlining the function call to make it easier. We should actually keep it accurate as one. I think this should give me the right grid. Yes, it does. Now when I unzoom, it has this very slight yellowish color. This is what happens when you mix red and green. When I zoom in, just like that. At default zoom, you cannot really see almost anything in this display, but it's there. If you zoom in a little bit more closely, there they are, our lines. I want to do one more thing. That one more thing was... get rid of this. And the thing is, when I'm passing those values, I think they should be divided by n. Or maybe not. Okay, I kept it the same for now. So it's still very subtly yellowish if I unzoom. Could grab this color. See, it's a little bit of red and green. There are some aliasing lines which I don't particularly like. I'll add half to UV here. I will have two grids, grid 10 pixel and grid 100 pixel. So the 10 pixel grid is going to be muted, a little bit muted. Yeah, now I can zoom in and there it is, nice grid. Apply this. Yeah. One more thing I want to add, it's the width of this mouse trail. Instead of having a hairline, I think it should have a proper width. Stroke width should be 1. You know, maybe is greater than 1. That means we have zoomed in. This is when we will set stroke width, otherwise it's going to be 0. Should be the opposite. Essentially, it means that now when I zoom in, the stroke becomes wider, but when I zoom out, it stays at 1 pixel wide, even if I'm unzoomed. So it's still going to draw something here. Oh, I'm missing the next presentation. Come back.
And nothing else, things will point to types, but nothing else actually contains them. Oh. Nothing else actually contains them. Now, this means that when you're initializing, if you're initializing a struct, if it's a type, you're basically doing it because you care about the type. You're only doing it for the sake of initializing a type. And so it's really not very much extra cost to do this .nil type thing. It's also the case that because we have this as an array, the array itself is 0 initialized. So you have, n elements equals 0. But then, as we saw, the types of structs that are contained, like strings and kinds, those are all zero initializable. Though, yeah, I think this kind of containment idea is at least a partial heuristic for that ZII or nil type dichotomy. Okay, so we've got this type kind tag at the top. The normal way of doing this, default I think, is you have an enum and it just increments from 0, and it doesn't really mean anything. It's just an arbitrary identifier, so you can distinguish between different things. The most semantic use of this is as an index into a lookup table. So you might have some metadata like strings or sizes or something else, and you would read that with enum strings, enum b, and get b out. If you're feeling slightly spicy, you can order these in a particular pattern so that you can do simple, like pretty small evaluations to do check more than one thing at once, and group them into some pattern. The other common use for enums is as flags. So you have each bit is either you have each flag is typically one bit set at some position in the number, and it's a bit more flexible because you can have non-contiguous elements all grouped together in this kind of flag CDE, and that's pretty much entirely what it's used for, is allowing you to have all of these booleans and switch them all on and off independently. So our outer types, the pointers, the qualifiers, the structs, enums, all of that, we don't really have a huge number of them. And we're doing debug information. It's stayed pretty much the same for a long time. And I think we can assume here that it's going to remain the same for at least a while longer. I think we have about 19 different types here. And you may see where this is going. One of the things we can do is we can just turn each of those into a flag. Now, we're ignoring base types for the moment. This may look a little wasteful.
Looks like some kind of reflection
we're using
mechanism. I'm not sure.
26. That's a very large number. You don't really want to be indexing with that. But we buy some stuff with it, and I think it's worth it. This only really works because we know this max bound that we've got of there's only a fairly limited number of things that we want to represent. And because we're treating these things as flags, we can group them, because it's actually quite common in debug code to segregate different code paths by various different groups of type information. So often you want to treat pointers and arrays quite similarly, sometimes arrays, pointers. We can see we've got RVEL and non-RVEL refs. Structs, unions, and classes are all types of records that you want to often, but not always, want to treat the same. Welcome to our separate B-plot. Bits are high level. In this case, we are continuing on where we left off with and or operators. Now, you are hopefully familiar with these. We saw before, we have these flags, and we get to set them. Now, the cool thing here is that we basically get to treat our the thing we're querying against as a set, and we get to query that with our kind. Now, because of the way that these work, where we only ever have kind of one additional qualifier or pointer per thing, we only ever have one bit set in this kind, if in the outer types. So we get to do a multiple lookup with a single operation. The computer is fantastic at ANDs. It has no problem with them at all. And this, ORing these things together, I mean, ORs are cheap enough as it is, but this will just get evaluated at compile time and treated as a single value. Okay, and then we have this ability to invert the bits, and we can check whether or not check that our thing is not one of these things. Now, this is simple, right? But if you don't approach this through the lens of what can I achieve using flags, how can I
have an idea what's going
do this
on
in
here?
a sympathetic way, it's very easy to end up with, you know, a completely abstract set type, or you know, just a loop over an array, which is not the end of the world. But if we can do that in a way that is incredibly concrete, incredibly simple, and easy for the computer, that seems like a complete no-brainer. All right, so we have this inner type. We have this primitive way of determining whether a type is of a particular kind. What's quite common is that we want to get through all the way, as I mentioned before, we don't care about many of these steps on the path. We just care about the innermost thing. And so a useful thing to be able to do is we can loop over our AND query. And so you end up with a very simple way. Once you're familiar with this is about as simple a loop as it gets. And we can skip through enums and qualifiers and whatnot and get our type out. And then you can do the inverse and find the first instance of something. Again, very simple loop. Okay, so I was looking through my notes and I got to this point and I was like, okay, who cares? Like, how is this helpful? And
let's see.
The important thing here
was this AI written?
Is what's not here, right? So I look back at the dwarf code, and the equivalent of this is this. Now, that's not a totally impenetrable amount of code. You could read through this and understand it. But this is basically a primitive in all of your debug operations. And so when something goes wrong, you have to now question whether this is correct.
Handwritten A
Would you
is
prefer
not
to be
so
using this as the
CP23.
primitive, or this? Okay. Now, we've done this by looping over the different pointers.
Okay, this is formatting code, right?
Would be to
for this custom type.
Cache these mappings early on, and have this pass-through alias, pass-through qualifiers, except not atomic types, because those are needed for separate things. But that gets... It's
Logger name.
And we can do it fairly easily with this functional mapping. Okay, we've gone inwards, as it were. But sometimes we want to go outwards. We've started with a pointer, we've got our int, but in many cases, we want to do the opposite. What is the pointer type for this value? Do we have one? If not, we can create one, but let's at least try and get the canonical version first. So, we could have done the same as here, effectively, and tried to added the pointer to the equivalent pointer type, the equivalent reference type, the equivalent volatile, all of those things. Again, it's pretty sparse. Like, most of these things don't actually have outer types. Now, I was thinking of this in those terms. Think of this as a reference to the outer type. And at some point, kind of an audible click happened in my head as, well, first of all, I slapped...
I had no idea you can pass structs.
But if you reframe from
like typed structs as template arguments.
I think, what is the canonical map? A hash map. You can just map from type to type.
Some crazy stuff. I've seen similar stuff in game development.
Easily treat those as keys and values.
Some AAA game developers are crazy in this way.
Do we want to have a very simple map,
Oh, yeah.
but one of them per kind of
No surprise.
per kind of mapping that we want, or do we want to include?
So I think AI tries to intern those
the
strings
kind of thing that we're looking for with
in some very clever way. It's trying to force the compiler to emit them only once through this custom
this
type.
kind of trade-off often comes up where
But
you want.
I don't think
you
it
can choose
really
between
works.
Many simple things or one slightly more complicated thing.
You
And in
can,
this
as
case,
long
I
they can
chose
be
the
computed at
slightly more
comp
complicated
time.
thing, as it's only a little bit more complexity. More choices appear. How do we want to hash this thing? So you will note the explicit padding in here, because otherwise you might not get those as a value that you expect. The file might be anything with them. But this way, with all of the bytes filled, we could just hash variably. That's the kind of most generalized version. But we know the type of thing that we're doing. We know it's fixed size. Let's make assumptions about that and benefit from it. We can do a
So here is an interesting thing. What's the point of having logger name, right?
thing that we use on
String
a key in our map.
as a context constructor.
But we know more.
Right, you should be able to just use string here.
So,
Compiler thinks I'm passing E1 as CD, source location and log constructor reward.
What do we know about pointers?
You mean this error here?
They're not actually 64-bit. Typically, they are 48-bit, occasionally 52, and I think ARM64 has some 56-bit address spaces. This basically means we have 8 bits guaranteed at the top of our pointer, given that we know our platform. And I'll point out that as a debugger, you have to know your platform, and so portability is already, it's not a course.
Maybe you can put the source location
let's
before args? I don't know.
Use those top 8 bits.
In the order of arguments. Maybe the var args has to be at the end. I don't
like
know.
we may have hosed ourselves here.
I
because we've
haven't
got massive
really
values.
mastered
Right, we can't put those into
this
8 bits.
black art of
So
var
let me
arg
introduce you to your new best friend.
template
Okay?
metaprogramming.
We've got left shifting. These are one left shifted by 20, one left shifted by 8, all of that kind of thing. And that takes us from 8 to 256. There's an operation that goes in the other way.
Yeah, I think I usually see
Most significant
var
bit.
args at the end.
You will find this incredibly useful. You have to do this slightly differently on Clang and MSVC. Clang has the benefit that it will do it
But
in compile
City,
time.
string breaks after 15 chars and null terminator
make that happen.
when it comes to comp time evaluation.
Okay. Let's see if we can learn by testing. Anyone in the audience, what is the most significant bit here? 1, yes. Here? Yes. Here? Yes. Okay, so we're counting from the right, from the least
Var
significant bit.
args here
and
can't
the
go at
furthest
the
thing
end
is
since
the most significant bit.
location is
Great.
defaulted.
Most significant bit here?
I think this is why this library,
Undefined.
this logging library that I'm using,
So
I think this is why
just
it's
something
not
to be aware of.
actually using arguments
Okay.
to format anything.
Well, we can look back at our flags, and the way we've described it, each of these is going to be.
I mean,
most
the
significant
constructor
bit,
is very
8, 9,
simple
10,
for
11,
the
12.
log struct.
Great, and that's part of the reason that I write it that way, rather than the 0xf, whatever. Cool, so we have 26 is our max
I
value.
go to log.
And any guesses for number of bits that you can represent 26?
Yeah, this constructor, it doesn't take any var args, but you can then do
1 to the 32
the stream
effectively.
operator. Yeah,
And so
stream
we
operator takes care of emitting the
We
values.
can get our pointer, we can get our kind, and we can put these together. And I think I have written those. Oh no, those are the correct way around. Great. Cool. So we are, in this case, shifting the pointer up and putting the kind at the bottom. And this is the machine code that corresponds to that. This BSR is basically the most significant bit that we saw earlier. The compiler gets to make an extra optimization here because it knows that the value is never above, it never uses more than 5 bits, so it doesn't even have to AND here. Okay, we did it that way around. We had a choice there. We could have done it the other way around. What happens there? Yeah, it's fine, but unless you have a reason to choose otherwise, you may as well go with the nice smaller one, less instruction pressure, I-cache pressure, and it also uses fewer registers. The other nice benefit of using the small value at the bottom with a pointer at the top is that if you're really pressed for bits, you may be able to take some from the alignment bits of the type of the pointer. But yeah.
I have a fun idea about improving the synchronization of this
like how much of an
object and its widget.
And to be honest, probably not that much.
First, let's save what we have so far.
Once you know this, there is just zero effort to choose the one that's better. So you have no excuse now, okay? Welcome back to Bits a High Level. Our main thread has been preempted, and we're going to talk about bits. Okay, so you get some bitwise number, and the normal interpretation of this is to just treat them all as one value. So this is 233. But there's no reason that you can't split out different fields from this value and treat those as their own separate values. So here, because they're 4-bit, they each fit into a nibble.
So here's the idea.
Digit.
Instead of all those concurrent queues, we will have
14 and 9 in this case. Okay, so what can we do with that if we
max trail points 256?
Right.
We will have
so we take a couple of bits.
Atomic
and we can
integer,
4 values
which says
we might then add a 3 length axis on top of that using another
trail end.
So we have 4 by 3, and then we
Index.
have this kind of rectangular array.
And we will have std atomic
you can think of that as an x and a y.
To trail.
And then we can add a 2 length.
So this is an array of a ton of atomic values.
Effectively a little 3D mapping within a single
Can we treat
number.
of this?
And that's where the value.
Why is it so large?
So yeah, our friends in the array programming language world.
It's 4 bytes.
Rectangular mapping. Basically, what their entire data structure, everything is in this format.
How large is this P? Size 8 bytes.
Product type, and you can kind of see why here. Because
Actually, no. This size makes sense.
3 by 2.
It was just a very large struct. Okay, okay.
And another way of thinking about this is effectively each of these different color dimensions is a struct member.
We don't need concurrent queue now, because we start with index set to 0 and this initialized to
this rectangular
0, 0, 0, 0.
But there's a more general one, which is this tree. And each time you hit a bit,
Don't think any of
or
that.
each time you hit a new dimension, you can split off into however many different options that dimension has. This is occasionally useful for...
Okay, I want to see this presentation.
It's probably not great to think about.
It sounds interesting though.
You'll see why in a sec. Yeah.
It's mentioning extra dimensions,
now
so
in this
it has my attention.
And I'll say here, and I'll probably say it again, that one of the great things about bitwise numbers is that you can interpret them in multiple different ways at different times, and being able to switch between them for the same bit pattern, being able to switch between different interpretations of that from one moment to the next can actually give you quite a lot of power. So this tree version is even more general. You don't actually have to have even dimensions the whole way. You can, once you've decided on your first split, you could completely reinterpret the bits differently. So here we have, on the left, 2 by 3 by 4, and on the right is 2 by 2 by 2 by 2 by 2. I think I said too many 2s. Again, this can encode potentially more different things. You'll see in a sec, but if you can avoid it, I would. Yeah. Right then. Let's bring it back to types. So we'll start with this tree view on this type question. There's different ways we could break up our space of types, of base types specifically. You know, we're dealing with floats, dealing with unsigned and signed integers, booleans, chars, that kind of thing. And each type has kind of a general type kind, like signed or unsigned, a bool, whatever, and also a size. Now, you know, this float and scalar thing, I happen to know is useful in some circumstances when you're interpreting the base type, and you know, maybe you want to encode that in there so you get this information for free. But you end up with this kind of slightly lopsided tree where it doesn't fit into this.
It doesn't make sense.
Neat multiple dimensions thing.
Because you have multi-byte booleans.
Another thing I'll point out here is that we have these. We have an outlier case. That is F10, an 80-bit x87 FPU float. And whenever you try and map a space, whenever you try and generalize a model, well, you will often come across situations where there's an exception. And again, at that point, you have a choice. Do you want to generalize your model so that you can account for this, or do you want to keep the model nice and simple and then keep the exception for the unusual case? And you can keep that in the interpretation of the data, kind of with the tree style thing we saw before. You can treat that. You can do that in the code. With whenever you're dealing with stuff, you just have an extra if it's an 80-bit float. Yeah, you have that choice. Now, I guess I probably should have mentioned before, the convention we have in the code base is that unless bits are specifically otherwise required, types are normally specified in terms of their byte size, not their bit size. Yeah, and again, we've got this nil type, and there's only really one nil type, and each of these sort of bottom layers on the tree has 4 values, and that means we're over-specifying nil. Well, you can either interpret it as there's a 1-byte nil, a 2-byte nil, a 4-byte nil, and an 8-byte nil, or you can interpret that as there's a 1-byte nil, and then there are 3 holes in our space. Now, for a certain interpretation, that's a problem. But if you are willing to ignore it, then you get a lot of utility from that. This is another breakdown of that tree. I know I'm missing unsigned char and various other things here, but let's go with this as a simple version of the talk. We're just kind of accepting that we have holes where all of our nils are, and in practical use, we don't really have 8-bit or 16-bit floats that we have to deal with. Although, just by having this type system, we now handle that, even if unintentionally. Okay, so I mentioned it's useful to be able to think of this as a clean separation of dimensions, and rather than as the tree. If you're thinking of it as the tree, what typically happens is you have to do each decision point in the tree as a separate conditional. So not only are you nesting once more, you're kind of adding this layer of indirection in your code, you just end up with n times m different, for however many dimensions you have, different cases you have to handle. And quite often, if you have neat dimensions, you can take the value on one dimension, handle that, take the value on the other dimension, and handle that as separate cases, and end up with n plus m cases instead. Okay. Right, back to how this works in the code base. So we have our types arena as a top-level debug information struct, or debug information type. It ends up being useful basically having an entire array just for types. So we have our base types at the bottom. As we mentioned, we have basically end up with 4 bits for the kind and then 4 bits for the size. So we have 256 different locations here. We then have some other function types, which we know we're going to need, but don't really fit neatly into this. So that includes things like the F and M type, and the Windows thread execution block type, that kind of thing. And then we just have everything after that. It's pretty much completely arbitrary. We have our pointers, our qualifiers, all of that in there. Okay, so we have our different components of our values. We have our kind and we have our size. The fact that we have these as separate components, I mean, not only can we, given a type, determine both of these, we can then recombine them after having done some calculation and then find the new computed type. We don't have to indirect this through multiple lookup tables. It's just ORing 2 small numbers together. And this case is for integer promotion. This is a small snippet as part of that, where you have to take both kind and size into account. Okay, we have both this base type and the other outer types, the qualifiers, the pointers, and so on. Those are both within our type kind. And this is where I think it gets really cool. We do our pass-through. We get the kind of base type as part of that. Sorry, the innermost type that we care about as part of that. And then we can switch on this and filter our switch to the level of detail that we care about. So we can mask off, we can basically treat all base numbers and enums as the same thing, and then they only have to deal with a single case in our switch statement, rather than dealing with, what would that be? 256, I guess, from the previous thing, different options in our lookup table. We can then deal with different outer types as separate things. Another case, in this one, we are looking at return values on Windows, so that's a particular ABI, a particular calling convention, and in this case, we don't care about the size of the type, but we do care what kind it is, because floats get treated differently from basically everything else. And you can see, again, there's it's not no entries here, not no cases, but we don't have to deal with the entire type spectrum as if it were just a flat, undifferentiated, arbitrary number. And the last case, we can look at just the inner type, and then basically ignore all of the outer types, ignore all the qualifiers. And there's another case I didn't add here, which is where you want to read data. It's useful to know what it is, so that you can, if it's a signed variable and it's smaller than 8 bytes, you want to read it and make sure you sign extended. And so that's a case where the full base type, rather than just one of these components, is helpful. Okay. End of part 1. Welcome to part 2, stacks and stackability, where we're going to talk about Whitebox, the workings of Whitebox that help it work more like a profiler. So, again, Whitebox collects things over time, and it can collect things in multiple threads at once. This breaks down for both both GUI purposes and the internal structure happen to mirror quite nicely here. So hopefully this will make sense. We have our kind of general run recording. And inside that, we have run threads. And inside of that, we have multiple levels on a call stack. Inside that, we have all of our many calls that have happened within that call stack. And then inside that, we have an individual call to a particular function. Now, a couple of things to note here. Firstly, all of these things are on, we have many levels of nesting here. And while I said we have a few arenas, we don't want an unbounded number of arenas. If we had an arena per thread, many people in here will be sane with their use of threads, but in the general case, there's really not much of a bound there. And that goes for each entry in this dimension. So we don't want to just have an arena per array. We want some other method of storing this information. The other thing I'll note here is
I don't want to load I want to load I modulo.
I'm going to keep them. Nothing will stop me. Right, so an alternative view on this is this. This is with the kind of tree that we're forming. There are other things at each of these levels, but they're not important. I want my stable pointers to calls, okay? Or each individual call instance. What are the options we've got? Okay, I'll start basic. We just pre-allocate some array, and it's big enough, and we just use as much as we need, and we know that we're not going to need more. Works in some cases. It's not going to work here. There's too many. Each of the things is both too big and too volatile and too dynamic in how large they end up being. And that is true at each level of the stack, whether or not it was kind of directly there or indirectly. Probably the default solution here would be a kind of realloc array, where you start with something fairly small, and then you double it, and you move the pointer to the new thing, and then you keep
this
a
new
approach like index. You may see where I'm going here.
Should deal better with those hang-ups when we are stuck.
An entirely small point. So if you want to actually reference one of these things, and you're using indices at each of these levels, what are you going to end up with? 4 indices and a base pointer to start with?
Shape should still be.
It's both starting to get to a reasonable amount of memory if you're holding a lot.
Should be more
and
accurate.
Also, it's really inconvenient to write the code around. Okay, another option. We could indirect. We could have a meta block that points into individual chunks, and then the individual chunks can remain stable, and then we kind of reallocate this meta block structure. I think this would work. There's no kind of inherent problem with this. You end up still doing the leaking, although now at some fixed size, some constant size smaller than the full problem. And then you either leak this, or you have some pool structure that ends up dealing with all this. And if you do that, then you end up having to free things because they're not in the right place in the arena stack. I can go on about that, but I don't know. It's not great. There's also 2 jumps, so if we could avoid that, that would be nice. Common solution for variable length data, where you want things to be static, where you can grow them, is this kind of chunked linked list approach. So you have 4 items on this particular case. Have 4 items in each list node. Have a pointer to the start and to the end. And this is great. We use this for strings, things where you work string lists, where basically all of the only thing you need to do with them is iterate through them from beginning to end. But in our particular case, a constraint that I haven't mentioned yet is that we want random access. And that is slow here. Now you may be thinking that we can just walk through and find it, and it'll be fine. Computers are fast, memory's fast, whatever. Caching has improved so much, all of that fun stuff. Maybe that would be okay with moderately sized data that you do relatively infrequently.
Could.
But, I don't know if you've ever seen a profiler. If you've ever seen
Put something like
trace,
EU8
it's
here.
many gigabytes, and this is we do this all the time, so it's completely prohibitive for us. Another option, you could break things down in some sort of tree structure, but we said we're trying to remove indirection here as well, so if we can avoid that, that would be really nice. There's also just like so many things happening all over the place. For a structure that may end up being used quite a lot, we'd like to avoid that if possible. So this is where I've ended up. We take the doubling size that we saw in the realloc case, and we took the meta block or chunk pointers approach of the case after that. And rather than
Should work, and now we shouldn't need any module.
Rather than doubling in place,
there is no point.
In this particular case, we double the size of the array each time we
No,
enter.
I will keep that module. It's
Now,
no.
there's a nuance here.
I don't want
said
to complicate
double the
this.
size of the array and not double the size of the previous chunk. I think both can probably work, but the maths. Well, for one thing, you end up with a power of 2 size if you do it this way for the total array, and that's quite nice for various things.
Yeah, I have padding anyway.
Maths works out nicely when you do it this way. So you'll see that the first 2 blocks are the same size, and then we double, and then we double again. And you may also notice that the pointers are just immediately next to the size of the array, the number of elements in the array, and that is intentional because we're on a 64-bit system. There's only 64 times that you can double the number, including the first one, and still be representable in address space. So worst case, you end up with 64 pointers here. Okay, but what have we already said? That we're not actually in a 64-bit address space. You can chunk that down to 48 or 52 or something around there. Okay, and then in reality, you're on an actual physical system, and you are very unlikely to have that many actual elements in RAM. Next step down, you have a real problem that you're trying to solve, and while in our first example, we poo-pooed the idea of having some known size of things that we can definitely fit all of our elements into, when you don't have to pay the actual full cost of that, you only have to pay the log 2 of the cost of that, that actually becomes a lot more feasible. And then, of course, each individual element has a size. It's not just 1 byte, typically. And then beyond that, you shrink the number of pointers you need further by the fact that your initial chunk is not just 1 element, but many, possibly decided by cache size, or page size, or some other reasonable default for your problem. There's a little bit of nuance in how you decide that. But you end up with this. It's not a completely tiny header structure, but it's completely tractable. Right. So this, I looked around for this. I couldn't see anyone talking about it, although I'm sure that other people have done it. Given that I couldn't find a name, I've come up with the name exponential array, or XAR, ZAR for short. So we have this kind of array idea for storing a virtual array, and but we have to actually, we need the code for this. We need to implement it. It's no longer just a single lookup. There needs to be some kind of operations to find each element. And I guess this is where I'm going to say that abstraction and generalization are not always a bad thing. They have a cost, but sometimes that cost is worthwhile. And the way that we're going to generalize this is by treating bytes as first-class citizens. Okay. So parameters that we're looking at are the size of each element, the number of elements in the first chunk, and from that you can infer the rest of them, and the number of pointers that you're going to store to these chunks. And given that, you can basically describe this entire structure. Okay, we're going to take advantage here of another thing that we know about the platforms that we're on. In the typical Windows and Linux calling convention, if you pass a 1, 2, 4, or 8 byte struct, and there are more options for that on Linux, if you pass a struct that is exactly 8 bytes, it will get passed as a register. And so, given that we know this, it's actually not that difficult to compress all the information that we need to know into 8 bytes. So maybe it sounds like a micro-optimization, but again, it's actually the mental overhead on doing this is pretty small once you're aware of it. The other point to do with calling conventions or APIs is, we want one version of an array function is to get to the element at index I, and that's all well and good. But there are other things you want to do with them, and as soon as you have multiple different parameters that you're passing, then being able to chunk all of that meta information into one element is convenient both from a calling convention and from a developer perspective. Do you see that intersection happening? Yeah. So we have this incredibly complicated header struct, which just contains the size, because we've said that the number of chunks, number of pointers that we store may want to differ in different cases. And then, given this, we know that our chunk's going to be immediately following this, and we know that they're going to align because of the size of this thing. Given this, we can find which chunk an element is in, and then where inside that chunk it is. I'm very happy to talk people through what this is all doing. I don't think that we have time to do it currently, but you can observe that all of the operations are just shifts and addition and subtraction. It's all stuff that the computer can do very, very handily. And I think this is mostly possible because of the structure that we ended up with here, with everything being a power of 2. Now, you could have gone, maybe I want a Fibonacci structure. And maybe you could have. But if you do that, then finding that doing this inverse of maybe going from doing the multiplication out isn't too bad, but then going in the opposite direction becomes a lot more prohibitive. Whereas we have our best friend, most significant bit, and that does it. That does our log base 2 floored with about the latency of an integer multiplication. And depending on the platform, it's sometimes more like an addition. So it's between very good and the best it can possibly be. Okay, let's look at getting a real type that we can find. And we've introduced this with wanting to find a particular call in this tree of calls. But we'll just look at the last array in that. Okay, so I'll point out that this is not actually how I do it in my code base, because we have some macro hackery to get around having to implement this everywhere, or to rewrite this everywhere. I didn't want this talk to be too C specific, and so I'm not going to go into that, but feel free to ask me about it later. So anyway, we can specify the metadata, and then so we have our outer function is it's fully typed, and then our inner function, it calls the generic byte-wise operator and returns a pointer to the thing it found. If this were an external function, like I said, an 8-byte struct will get pushed into a register, or moved into a register, and then passed as one of the parameters like that. And you can actually see here we have a shift of 8, we have 30 chunks, and we have you can't see here, but it's a 24-byte element. And so at the very right, we have 8, and then 30, and then at the very end, this 0x18, that's 24 in hex. Okay, this is an external call, and in reality, particularly if you're a Unity build team, then you're actually going to you're going to get your code, your compiler and your linker are going to know what the function is going to call, and it's going to inline them, and it's going to be happy times where you don't have to do this extra call overhead. Before we get there, I mean, we just have an awareness. We're not going to go through this in detail of the machine code that gets generated. And hopefully you're all
show me the screen.
At this point.
I want to see.
Whenever you have a query about what things get turned into, Godball is a lovely go-to for quickly checking what things are going to look like. But this is our general case. There's nothing particularly objectionable in there. There's like, oh, there's a jump. Maybe we could have made this branchless. There's an IMUL, which is not quite as fast as some of the other bitwise arithmetic. But I mean, like, this is pretty much, this is really very good for generic code, for kind of generic operations, dynamically typed operation. And then at the end, we find out what the pointer ends up being to our thing. And so the gold standard here, which would be finding the address of an element in an array, would basically just be a single LEA, maybe with a couple of mobs before it. And while we're not quite there, if you've seen the size of some of the
it's more like
many other functions,
a hack to the multiplication.
Okay, so if we specialize to the specific types that we're interested in, it's actually all very similar. Except
or not. This actually seems to load some address. Okay.
And a little trick to compute 24 times for the size, slightly faster than a generic multiply. Okay, so two things jump out at me here. One is this got inlined, the inner type didn't end up being, the fact that we did this dynamically initially didn't really matter for the resulting machine code. And the other thing that jumps out is that the dynamic version is actually not that bad. And so given that we're a debugger and we do many things dynamically, it's actually occasionally useful to use the dynamic version. And the fact that we've done it this way rather than through templates or something means that we have this option to basically have this monomorphization on the right, or a runtime version on dynamically typed version on the left. And I was thinking of this as basically byte first thinking wins over type first thinking. Okay. So why do we need this random access? Well, one of the things we need to be able to do is find elements in our calls. And here we get to make another awesome assumption. One of the great things that happens when things happen across time is that they're sorted by time. And that is incredibly useful, because it means that we can binary search. And there's many reasons you need to do this in profilers in general and in Whitebox in particular. But let's just say we need binary search. And we can take advantage of this byte-first thinking. So, first of all, the default, if you were treating this in a type-first way, it would be, okay, we have our call. Let's just say we have a simple array rather than this slightly more complicated ZAR. We have our array of calls, and we need, because we're in C, we need this we need this separate, we need a separate function for each type of struct that we are going over. And we need one for calls, and we need one for stack levels, and we need one for all these other things that we've mentioned we have arrays of. And that gets unwieldy. But like, if you're doing a search over things, are you actually comparing the whole struct? I would say in almost all cases, no. You're just comparing some, in 99% of cases, you're comparing some simple member of that struct. Yeah, there's the occasional one where you need to compute something given multiple members, but the typical case is this. And so if you're happy you have this struct that you're looking through and you can identify a search key, you really only need one version of this function per search key type, not outer key type. Once you've gone through this and worked it out, it's not much more complicated to do it for the ZAR version. And this is the code for that. I'm not going to claim it's the best binary search. In fact, I know it's not, because there are better branchless versions. But I'll just point out two things. One, we're getting the ZAR meta. You can actually see here the case that I was referencing earlier, where you end up with multiple different parameters, and it's quite nice having your ZAR meta constrained to one thing rather than split out into all of its members. And the other is you just end up doing the typed get, and then get the offset into that struct, and then you know the thing that you test against, and you test. We're doing a slightly. This is a binary search where rather than just finding an exact element, you find the thing that is less than equal to that. So it's slightly unusual. And here is where you may have seen a hole in the ZAR meta before. Here's where we get to fill that in. And if you're thinking that this is a very pure structure, maybe you're making a library for this, then I don't know, this is a member that may not make sense, but this is for our code base, this is for a specific purpose that we know. And so we can put in the things that are helpful, even if they're not pure. And so we have all of these parameters as an option. There's like the most explicit layer possible, but most of the time we don't need all of that. That's more complicated than we need, and we just binary search an array kind of as expected. Kind of general point here is I often find it helpful to have the explicit function with everything specified, and then all helper functions call that with different things. So you have this extra one layer. You don't end up then doing like this tree of specializations, like adding one more specialization for each call in that call stack. So side point though. Okay, we're gonna jump slightly to a different topic, or a different aspect of this topic. And that is mappings. Back to mappings. Now, I wanted to include in this talk a kind of full section on using the locations of things as a source of information, but it turned out there's far too much to say there, and it would completely blow out the rest of this talk. And it's far too long as it is. So we've got some mappings, and what you're probably familiar with is doing parallel arrays in the context of SOA style structures, where thing at index 0 in one array maps to thing at index 0 in some other array, and they're kind of conceptually part of the same thing, but stored separately. And the wins you get from this are maybe it's cache in that they're or the access pattern means that you're accessing all of one array and not the other one. Maybe it's a size thing where one of them only has to be bit flags and the other one is some large struct member, and the bit flag would throw off the alignment, so you end up with a bunch of wasted space. Maybe it's just, you get this mapping and you don't have to record any data. It exists in the ether for free, And well, you're just getting this from the fact that you have this structure. And then another case that is particularly helpful is you have two different arrays that live on different lifetimes. And they get to know about each other, but you never have to keep an explicit pointer or handle a reference or anything from one to the other, or generic map, whatever. And what that means is that the thing that you're pointing to, if that disappears, you don't have to go and fix up any pointers. You don't have to say, oh wait, no, this no longer exists. I need to make sure that I've handled that case.
This is actually nice.
Poof, it's
I
gone.
always had my main problem with SOA is that it's hard to delete data. If you have objects that live for a dynamic amount of time, how do you get rid of them?
When we have a debug event, and one of the things that we store is kind of like an unwound call stack. And you've also seen from the timeline view that we have this kind of profiler-like view of calls across time. And what's quite nice here is we have some parallel mapping, but there's a nuance. Call stacks, when you unwind them, you start at the current instruction pointer, the current level of the call stack. And then you do a little bit of jiggery-pokery and you find the pointer back to the previous level of the call stack. And you end up with a kind of gnarly linked list, going from the leaf to the root. And then in our profiler-like view, we want to store that with the root at the bottom, because it means that as the size of the call stack changes, it stays in the same place. So this means that we're counting in opposite directions. And what this basically means is that we have kind of this inverse parallel case, which is, it's a slight extension to the parallel case, and it's, big deal, I guess. But there's something else that comes out of this, which is we're thinking about our profiler call levels. I keep saying profiler. You're getting data across this as well as calls, but I'm sure profiler is more familiar. When we're accessing data at these different levels, sometimes you're going to be, okay, at level 2, we have some data, and maybe I pass a pointer to that data into these lower functions. Maybe they modify that data. I want to keep looking at that data referenced in call stack level 2 and see how it changes across time. What you also might want to do is say, whatever's at the top of the stack, what is currently happening there? And so we need to be able to reference from both these sides. Okay, cool. This seems like a solved issue. You've used Python. You've seen many things that do this. If you're kind of indexing into an array, you can use 0 or positive numbers to access from the left, or negative numbers to access from the right. And you get this 0 and -1, kind of the opposite sides, and then 1, -2, the opposite sides, and so on. And that's kind of in the general case, you're doing this -x + 1 with the brackets in the right place to convert from level to depth. I don't know if anyone can see where this is going. Welcome to Bits a High Level, Part 3. If you're happy to assume that you live on a 2's complement machine, which, well, I know I do, you can make that choice for yourself. Then you know that this -x + 1 is the same as a not x. Now, okay, is this swap going to make the difference between a completely amazing feature and something that doesn't work at all? Probably not. But you will notice there's many of these things, there's many operations happening on the left, and you might do -x + 1, you're like, I forgot the parentheses, sorts of bugs. Is it x minus 1? What was it? What was it again? You've got to take this extra thinking step to make sure you've got that right. And it's another place that you might get things wrong. And if you know that you can do this not operation and do this flip, then that makes things so nice. It's small. It's a creature comfort, let's say. If you're thinking of negation, if you look at it on a number line, we're kind of flipping around the middle of 0. So negative 0 maps back to 0. The negative of the minimum number, I think, is technically undefined, but in practice often maps back to itself. And then everything else, does what you expect. 1 goes to minus 1, and so on. And then it's worth seeing that the not version of this, it effectively mirrors around. You can think of this either as minus 0.5 or the left edge of 0, depending on what makes more sense to you. In the integer case, the second feels somewhat more appropriate. And that means that we can do level equals not down.
I wonder if Python interpreter uses this
and everyone's happy. And
for indexing negative arrays.
Right. Let's have a roundup of where we've got to with this call stack situation. You may remember the tree that had run, which has members run thread, which have levels in a call stack, which have a number of calls, and then each individual call. And this is a potential layout of that within a single arena with these ZARs. So our red run thread at the left our red run at the left points to these blue run threads. The run thread, you can see that the run threads are pointing to these green call stack levels, and you can see we've got 3 of them. The first 2 are the same size, and the third one is double the size. And then the stack levels, what did I get to? It calls the next one down. Sorry, not calls. It references the next level down with the chunks. And then once we're done with this, so you can see that we've interleaved pushing onto these different arrays. And if it's not obvious, the hashed bits are just memory we don't care about. Something else is there for this purpose. But yeah, we've interleaved all these things. We've done all our stuff. We've shown everything to the user. The user's so grateful to us for showing all this information, and they've fixed their bugs, and they're, oh, yes. But now it's time for another run. Let's go. Clear. You just pop back. You can zero the one array left of pointers, and so zeroing it means you have no members, and then all of your pointers are null, and it doesn't point to anything, and we reset. And it's one operation. You don't have to walk all the way up the stack. You don't have to keep all of these arrays around in some realloc tree. There we go. Part 3, pipelining dependencies. We're going to take a jump back to the debugger world here in a sec, but we're going to start with a simple example. So we're building up some case, something has happened, we want to switch, and we have our case enum A, we do the thing that happens with that, and we do some other code, and we have another case, and we get some stuff that's specific to that, and then we also get some stuff that's the same as the first one. And then we get a third case, and we've copied it again, but we're starting to think, this is going to be a little bit hard to maintain. Maybe we need to do something with this. And then we get a fourth case. We're like, yeah, we probably should do something about this. These are meaningfully the same, and this is going to be like, assume this is not just 2 lines of code, but some considerable amount. So default response, I'd say, is pull this out into a function. And it kind of works. There's nothing wrong with that. And in many cases, that is probably the best approach. But you will often find that a better approach is, in my particular view, is to do this pipelining thing, where you do each individual case, and then you move the common code down so that all of them end up going through that code path. And there's this extra step for setup common, because there's often something that has to be done before that. So this is the case with calls. We end up with these kind of multiple different paths. Kind of ends up as a tree. And here, we have everyone's favorite data structure, the DAG. Yes, yeah. Okay, you might be thinking, like, this is an unfair example. You've explicitly said that all of these things are completely the same, and there's one of them, and they're all matching. Okay, fair point, fair point. Let's do a slightly more hard example. So now we have 5 different things that might get done as a result of our 4 different enums. And then each of our enums does a different but overlapping subset of those things. Okay. So again, kind of first version of this, pulling out in the default way to functions. You can do this, but now each of your call sites has some different context from within that enum-specific case. And also, you now have a function in your code base that might get called from somewhere else. And, you know, either you take the approach, this might get called from somewhere else, and you handle that, in which case you have to do all of this work to make sure that you're not assuming too much context, or you don't do that, and then you later come back to this and you're like, oh, that looks like it does the thing I want it to do, and you use it, and you forget about all of the assumptions that you made as part of making it, and then you have a bad time debugging because there's some subtle case that you've forgotten about. So the alternative that I would propose, in not all, but some cases, is to do this pipelining approach. Okay, so in the kind of abstract, we have each individual case, and then we work out what we want to do, and then we do the things that we want to do. And that kind of ends up in this situation. Except there's there's often a wrinkle with this, which is that these have inner dependencies between them. And in this case, that's trivial. You can just order these if statements in the right way. Trivial is maybe an overstatement. Sometimes there are complexities there. But in many cases, once you've worked out what the different jobs to be done are, ordering them is straightforward. Okay, let's have a look at a couple of ways that we could do this. One is I kind of think of as a bit like you're framing what needs doing in terms of the input, in terms of the problem statement. And so using our best friend bits, yes, can we get a round of applause? We can use our linearly incrementing enum and turn that into a flag, and then compare that flag with different combinations of other flags. And again, we're doing a few operations here, but again, these are constant things that will get turned into a single value at compile time. And if you blur your eyes a little bit, this is quite similar to what we were doing with our types case, except those were already kind of pre-shifted, where we were checking against pointer and reference and array, that kind of thing, all at once. An alternative is we frame the problem in terms of what we want to do as a result, kind of the output of this event, this thing that's happened. And again, using bits, but just slightly differently, we are just specifying I want to do job 1, job 2, job 3, whatever. And then we do them. And each of these operations, bitwise ups, trivial, computer's not going to complain about them. Once you're familiar with them, incredibly concrete, kind of easy to understand what's going on. Okay, let's go one step harder. it's possible that the enum is not the only thing that determines what needs to be done. And in that case, you have this if statement at the top. And if that is true, then you kind of need to be in this output-oriented thing, as far as I'm aware, unless you start making your conditions really complex. But you're probably already doing that analysis earlier on when you're trying to understand the problem input. And it often ends up being easier to specify in this way. And
That's
then
a nice
another thing
pattern.
that might happen is that while doing your jobs, you realize that something else needs doing afterwards. And I've written this in a slightly different way here. This is kind of doing a branch-free version of the if statement above, where you're converting some condition to 0 or 1, and then multiplying it by a flag. So that is either 0 or the flag. And then you're ORing it, which is item potently set including into your flags. Now, I tend to have the opinion that you can definitely go too far with branch-free code if readability is your goal. But a little bit of branch-free code will actually end up being easier to read once you're used to it, because it means you're doing this thing, then this thing, then this thing, then this thing. There's no indirection. There's no kind of extra layer of looking out into different places and trying to keep that stack of like what's happened.
Fair point.
Your mileage may vary. Okay, we can expand this a little bit more. Sometimes just do the thing is not enough information. Sometimes you need to know, like, what am I doing with this thing?
I think generally
There's some
skipping a block of code
needs
is
to be passed to the
still
operation. And so we just add some
simpler
data that's available for that.
than executing this block and then multiplying the result with condition.
You might end up that do the thing or not do the thing is not quite the right framing. A better framing is don't do anything, or do version 1 or do version 2, or 3 or 4 or 5. And if you have just 3 options, then kind of from a bit perspective, the flags version, 2 bits, and the the flags version, which is 2 bits, and the kind of enum, small enum version, which is 2 bits for 3 values, are the same. But from a kind of mental modeling perspective, it may make sense to break it down this way anyway. Or you may find that keeping with just bits and having a very simple protocol there is the easier thing to understand. Once you get kind of to higher numbers, the number of values that you can represent with a few bits compared to the number of individual bit flags you can represent with the new bits grows astronomically, and so you can fit more kinds if they are mutually exclusive into a single value. And that's kind of one of the big distinctions between kind of using separate dimensions versus growing a dimension comes down to, which is kind of, can these things happen at the same time, or can only one of these things be true at once? And so in this case, our job can only be beginning or ending, or it can be neither. And so this is, modulo some detail, pretty much what we're doing with debug events. This is roughly, again, skimming some stuff, what we get from the Windows operating system. We get a process has been created, a thread has been created, module has been loaded. And you'll notice that in create process event at the top, we have this thread begins, and we have some data for the thread, what handle it is. And then also the same thing happens in create thread. And then the same thing that happens in, a module begins in load DLL, and a module begins in create process debug event. As Ryan mentioned, a module you can kind of think of as a term that encompasses both loaded EXEs and loaded DLLs. And then we have the other side of this thing, which is handling our debug event. and we get to handle the thread beginning from the create process event and the thread beginning from the debug event in one place. And I mean just, it's one place in the code, and that's not just like one function where it gets run, although that is true. It is also one call stack in the, there is no call stack where this gets hit other than the one where it gets hit. So you know exactly what is happening. You know exactly the context when this is run. Again, you know, we're handling modules getting loaded and unloaded. And then sometimes things happen. Maybe some exception got hit and we need to break the user's process. That's kind of a job flag that we have. Okay, so I think to notice here is that the left stuff is framed in the context of the problem. And so in this case, it's platform dependent, and it's using the granularity of states that Windows specifies, and also the way that they've split it out. And then we get to reinterpret that into a way that is convenient for us and handle that in our own code, and we can make it platform independent. And
this is nice.
I find that there's quite often this split of like the framing that makes sense from the input and the framing that makes sense from the output, and they're not always the same thing. You get this kind of in.
I have been dealing with those platform differences so much. I mean,
data formats
the way I do
they
this
represent the same information in
is
multiple
using
ways, on, you know,
interfaces, object-oriented programming.
And then that doesn't actually change the way that you handle that integer after the fact.
So when I have some Windows event, I just call
Anywho,
virtual function.
We've
not a virtual function, just a function somewhere deeper in Automat that handles the event in platform-specific way.
We can pipeline these things into kind of, we work out what the jobs to be done, and then we do the jobs. Great. If you look for it, the issue of dependency
this is a nice pattern
everywhere,
because this way
really useful
it's possible to avoid
if you've been following
function calls.
Casey, then you'll know about
it's possible to do stuff more locally
machine
this
code
way.
abstraction level. You can think of them in this level. You can think of them as like build system dependencies, and then you have this completely generic version, the most generalized version possible that you can think of. And then we have all of these specializations that we can apply to our actual problems that assume the things that we know about the problem space. So in our case, we only ever do the thing once, or we don't do it. You often end up in a situation where you might want to do a thing multiple times, and that's often where queues can get involved. You can have a DAG that is statically defined, and then adds this element of caching, or we keep some data around from previous times, so that we not only does this thing, do we depend on the state from like just earlier in the function, we depend on previous loops of this whole iteration. And then you can get all the way to the most generic possible DAG, but you know, who would do that? Okay. Admittedly, so this is Whitebox. This is the JIT world of Whitebox, where you know, we basically are operating a build system, and you can see that this is not the simplest of dependency graphs. You can get more complicated, of course, but this particular dependency chain was not completely obvious a priori. We had to work this out as we went. And so having this as a more general data structure helped us to both pipe it into dot so we could actually see what the data structure was. And then also we could attach state to each of these nodes and add some extra debug information, which is helpful. Thinking back on it, I think we probably could have gone kind of half a step more specialized, more concrete. I think that the actual operations could have been done in this, you know, inline way where you just work out what he's doing, and your linearization is kind of statically baked in, and then you add on top of this a kind of immediate mode API for adding the debug information so that you can work out what's going on. And then that way, the complexities of modeling and traversing a DAG are not in your real code; they're only in your debug code. You've simplified that into the linearized or pipeline version in the actual code. Okay, so the point about assumptions here is that you can, if you know the case you're working with, if you know the code that is running around this, if you know the problem domain, you can make so many assumptions that make it easier to understand and much faster to run. But, designs change. You might be thinking, like, okay, this is good as long as my code stays exactly the same forever, but things change. And that is true. I would like to go more into this at some point, but I will touch on it now because I feel like I should. The first thing to say is you probably have some notion of what your design is going to be while you're writing it. And many programs are big, and so you write them step by step, but you have at least some notion of where you're going. There's a temptation to overly concretize kind of wherever you are, but you've got to. You just have to have that self-awareness to no, this is going to change. Don't optimize this. I don't want to tie myself into this specific limitation. And the example that jumps to mind for me on that is processes. Many debuggers will allow you to run multiple processes and analyze all of them at once. Whitebox doesn't. And so I would like to at some point, so I don't make the assumption that I have a single process, despite the fact that it's true across my entire code base. Other friends that you have are static assert, sizes, ranges, all that kind of thing. If you're assuming that your enums are in a particular range, you can check that at compile time. You don't have to pay any runtime cost for that. A fun one that I haven't seen many people do is you can just add kind of garbage tokens that are meaningful to you, make them exist somewhere, and then use them around the code where you rely on the assumption that you're talking about. And then if that assumption ever disappears, you can get rid of in this case, define assume foo, or you could have a constant, or there's a few different ways you could do this. And then your compiler will say, basically, this assumption is broken here, and here, and here, and here. Go and check those.
This is nice. This is a nice trick.
I'm a fan of asserts. I'm sure you're all familiar with those. There's nothing that requires you to make those be just like simple expressions. If you're in debug mode, you can do some arbitrarily complex check that structures are all like in the right order. The things that reference each other should reference each other. Things that don't or shouldn't don't.
Today's bug count.
I think you saw earlier, I have like unreachable and switch statements all the time, or like the end of an if-else chain.
We did experience some bugs, but I don't think we've introduced any, or maybe a couple, but very small ones.
In debug mode, it will assert if the condition is true.
Today is actually, I think, bug.
But in
probably
release
net.
mode, it will just evaluate the expression itself.
Net positive in the negative sense.
Like, do the check for
the way we, for example, record this path for the mouse pointer in the widget.
Sorry.
There is a subtle raise condition there, but it doesn't trigger. Even if it triggers, it's going to be harmless.
That is unexpected.
Small
tell me
ones
as a developer
today,
about it,
big ones
but
in
I can
30
do
days.
some kind of safe no-op or exit the function
Yeah.
or pass some error code back or however you're dealing with that, regardless, and so that it's not going to affect the end user.
I like the grid code. I think I will take more look at the Inigo Quiles website.
We have been...
Because I wonder if there is a similar...
By bits a high level.
Similar analytic
I'm not going to go over all of this.
version for circles.
I just wanted
He
to
showed
bring up
an
the
approach that allows you to zoom out and have a nice aliased points.
They're as concrete as it gets on a
I cannot do this in a
they're pretty fundamental.
hacky way,
They're like
but I like this
understood concepts and all that.
analytic solution. So
but
nice.
Once
It's present
there's
in
kind of
our
how I've
mouse.
learned how they manipulate the bits. Now I'm done with
Why
it.
is grid resizing
but
while
I
you
think
are moving mouse?
If you can,
I'm not moving the mouse.
if you can see the other interpretations of these values, see the other interpretations of these operations, then you will find that they will apply in
It's
many
trying to
cases
keep the trail in the window.
Just to bring one up
So
that I didn't really
this object,
explicitly go over before,
because of its interface,
if
it
you
doesn't
recall
know
back to
the whole path that the mouse is taking. It just receives a sequence of
This is on the topic
deltas.
of
And those deltas are then
reinterpreting
sent
things
to
in
the
multiple
operating
different ways.
system to move the mouse.
Our base type.
So-
I know it's a long time ago now.
Because I don't know how long is the track, I don't
But if you recall
reset
back,
this
our
image.
base type was our
I will actually show this image,
and
but
our
here,
size, and
on
we
this
have
track.
those, like, jammed
Maybe
together.
during the next stream, actually, we will
And
work on
you
this
can
track
interpret
to
these
actually
things
show
in
the
separate
path
what I
on
didn't
this
say earlier, which I
track,
should've,
so that we don't have just a
okay, we put this
blue
together. We can reinterpret
box.
those.
We want to
as-
have some graphical display
because
of
we only have 4 bits for
the
each
path
of them.
that we are taking
we
here.
reinterpret that as an 8-bit
And
number.
we will possibly use this
256
grid code
different possible
even.
values. That is 256 different entries into our type array, and it means that we do this mapping back from the two-part type kind into a location. So like it's not just, it's sometimes one number and it's sometimes two numbers, and the ability to switch between them lets you do extra things. And the same goes for these operations. Yeah, I'm not going to go over them. You can get the slides afterwards and look over them if you want, or you can find many other places that we'll talk about them. Okay, it's been a while. Thank you for bearing with me. Just going to sum up some of the things. I like stable pointers, okay? If you can keep stable pointers, things become so much easier. I know that there are cases where handles are needed, and that's fine, but there are many, many subcases where stable pointers are the best way to go. If you can break your problems down into kind of separable dimensions.
Actually, about this resizing, I think this is a good point. The grid probably shouldn't kind of zoom in and out constantly.
Much less code to
I think it would be
handle all the
nicer
cases.
if we...
And, like, you're a limited human being. There's only so much code you can understand. If you can fit all the things that you have...
If we had sort of a camera that follows the mouse trail.
Easier. Now, if it's not obvious with the struct type and the product type mentions, this rectangular dimensions thing is kind of the same as a plex. It's kind of the same as a megastruct. So we are Team Plex, Team Megastruct here. So what's happening is that with your megastruct, you have all of these different members. You think of all of these as a different dimension, and at a certain point it gets hard to visualize, but you can kind of abstractly think of it that way. And then, you don't use all of these members in every case, and those are just effectively holes in that space, as I mentioned before. Hopefully, I have convinced you that you can think of bits as high level, and you can do these operations that are kind of semantically meaningful, that are incredibly concrete, and the CPU is very happy doing them. I like pipelines. I'm going to keep it nice and simple. Try it out, see if it works for you. Again, I think that you will find that it reduces the amount of context you need to keep in your head and reduces the amount of context that needs to be, it reduces the amount that you have to add kind of wrapping of stuff to make sure that certain assumptions aren't broken, because if it's only used in one place, then you know how it's being used. Many of these cases are about kind of removing indirection in one form or another, whether that's extra calls, extra memory accesses, doing things with complicated operations where we could do them with just a simple bitwise. And the final point on generalization, I guess my take on this is you want to know, we've gone through these different topics. We've gone through kind of mappings and pipeline or dependencies, and understanding the different dimensions of things, whether that's like tree structures or whatnot.
Actually, there is a data race, and I feel like it's happening all the time.
I think that it is useful.
There is this tip of the line which is glitching.
I think the map is the really obvious example to me there, where like I'm doing a mapping, I can map, or I can use an array index, or I can use any of these other things. So knowing what the generalization is will help you know, will provide you a way of shortcutting to what the possible options to your solutions are, and then given your different assumptions, you can make a different specialization to do the simple thing, the simplest thing that is required that is not going to lock you in. I would tend to lean towards generalization over abstraction as a rule. You end up with many fewer code paths and less indirection and a much better understanding of what you're doing. And if you actually need to understand the code base, which you do because things are going to go wrong and you're going to need to bug fix, and if there are bugs, then your model of the world is wrong and you don't know why. So you're going to have to assume that everything is not working, and if there's more code and more indirection, that is going to be so much harder. Thank you very much for listening. I appreciate you sticking through with me. If you want to
that was a nice presentation. I like those programming tricks. There are very few places where they can be found.
This, or Whitebox, or anything else, and you can have a look at Whitebox on the website. Thank you very much.
Do we have any more presentations now? Let's see. Day 3. We didn't have this one yet. Yeah. I'm not sure if this is going to happen. We started with this.
Should I stick with the face mic?
1, 2, 3. Thank you so much. That was such a good talk. If you haven't already, you should go to whitebox.systems and try out Whitebox. It is truly amazing what this program can do. It is unlike anything I have ever seen before, and it's totally worth a try. So definitely go there. I did want to ask you.
That's very kind. I will just warn you that there are still sharp edges, so mind your fingers.
I wanted to ask you, I think it says it's on version 0.122. I wanted to know what the current state of Whitebox is. What's the future?
Yeah, that's actually a kind of old, that's an old version. It's actually, we just stopped doing that numbering system at some point and started saying the date that things came out because it felt somewhat ridiculous. So we're currently releasing whenever there's something new. And you know, if you've bought it, you access until at least the end of version 1.0 real, which we're not at yet.
Is there something that'll mark the 1.0 release?
That's a good question. There's a number of things that we definitely need, and then there's a list of nice to haves. But I think it would take too long to iterate through that now.
So I'm in the fortunate place of having seen this talk twice now, and I think I understand it about maybe 60 to 7%. I'm getting there. So if you haven't, or in the future, once this is able to be watched as a VOD, you should definitely watch it again if you didn't understand everything, which I expect is most of the people here in the audience. But you have an amazing amount of insight. There's so many interesting, concrete details here that you've pointed out. One of the things I find very interesting is you have this sort of like empathy for the computer that helps you see the combination between you and the computer and what is capable between you two. Specifically,
Okay, this is a good implementation.
The operands for instructions.
For us, push is always going to succeed.
That are not shifted up in 32
This is a really nice skill.
And also the whole structures that you have, basically generics in C, where with the calling conventions and knowing that you only have so many registers to pass, that sort of three-way connection blows my mind. How did you get to the state you were able to make those connections?
So I think as a developer, you get a head start on insight into things because you have to deal with conventions and you have to deal with what registers.
And the advantage of having 2 pointers is that I'm not wasting any data now.
We're trying
I needed to anyway.
Some JIT stuff in the user process, and as part of that, we've been making kind of
when we pop.
API. So it's just function calls rather than interpreting some text, but basically doing the same thing that an assembler would for the subset that of x86 that we need. And that really drives home the encoding issues. This is an immediate. I have a deleted scene that
actually I don't need pop,
where the encoding of an LEA kind of changes between you can encode. You use LEA to do these little tricks where you multiply by 1, 2, 3, 4, 5, 8, or 9, and kind of surprisingly multiply by 3, 5, or 9 is encoded smaller than the powers of 2. And that's like a quirk of the x86.
x86 is crazy.
There are reasons behind that, but it catches you out when you look at it. So having done that really reinforced it. But I think, as I mentioned earlier, Godbolt is just a wonderful resource. Everyone, if you haven't used Godbolt, first of all, what are you doing? And second of all, go there now and put some code in and see what happens. See what the machine is actually doing with your instructions.
Okay, I know. Our queue is going to work slightly differently from this one.
More than my fair share of questions in this conference. And I have around 20 questions written down here, so I'm not going to ask all of those. Wait, hold on. How many is too many? All right, well, for now, I will ask one more question. We'll do some audience questions. When we run out, we'll do more questions, so buckle in. So one of the things I find really interesting is that I often do, I think Casey Muratori does this for bitwise operators. You'll often do is flag set or all flag set or things like this where you kind of wrap up the bitwise operators and you kind of push them away a little bit with a define. And I think at one point you called the unary operator a switch, kind of endearingly. I'm curious, do you think there's a benefit to keeping those operators in the front there, being able to see those?
Yeah, so I think this doesn't really help when you're first writing it, but the benefit
Give me a moment.
of
I didn't commit this. Oh no.
choosing one of these paths, whether you have kind of a meaningful name or the operator just bare.
Okay, it's back. It's back.
From having one of those consistently within a location is the ability to compare and contrast between them. So the problem is you don't know this beforehand, which of those is going to be useful. But you might end up with a situation where you want to contrast, is any bit of this set in one case and are all bits set in the other case? And I know in the white box code base we do that in a checkbox for like, is it a tick or is it the half filled in square? And in that case, the point of having these things next to each other is to juxtapose those two different versions. But then I think the raw version is useful where you end up with a bunch of these operations next to each other. And particularly if you're doing
trailer writers, yes, this is what we need.
Each point.
So when we put something,
we saw what happened with the minus x plus 1, and you find that many of these bitwise operators have a mathematical identity with some other things. So if you have some complex combination of operators, they may actually just collapse down to 1 or 2. And
trailer.
I guess that's interesting from a micro optimization point, or if it's in a hot loop. But sometimes that's also interesting from, like, there's some kind of more fundamental thing that's happening. I'm doing all this Java as a way of describing this operation, or, this
So first, we are signaling that, hey, somebody's writing to this queue.
But actually,
then we will move it.
There's only a couple of things that are happening.
Write something here, then decrement it.
I wish I could give a prescription to when to choose which. It's a kind of gut feel, I guess.
You said you work with contractors. Do you feel like you ever get pushback from them being like, oh, this is scary, this is an operator I don't know, I don't use the squiggly that often, what does that do again?
I mean, I don't think we've had any issues with that. All intelligent and well-practiced programmers. I kind of think that these bitwise operators are pretty fundamental things in computing, and unless architectures change dramatically, they're going to be around for a long time. If you don't know them now, then you can learn. And they're a little bit unfamiliar at first, but I think the familiarity is the main barrier to go over. Once you understand what they do.
I used to have a coworker I would talk to a lot about JavaScript. He loved JavaScript, and he would often tell me that, like, oh yeah, this one-liner map thing that you can do in JavaScript, it's amazing. And I was like, well, it's a little bit hard to understand. He was like, no, you should understand map for free. That's like a thing you should know as a JavaScript developer. And the rest of it, like all these like standard library things, come for free, assuming you're a good developer in this space. And I always kind of hated that idea of like just like the standard libraries, your atomic units that you should like take for granted, right? But I feel like the binary operators, as you point out here, they are more fundamentally atomic units that, like, if you understand them, you understand them. Those
I think it's possible to make it a proper
and
queue,
not only
like a proper log tree. Log tree is very hard to design, but I think it could be possible here.
I've seen this a few times, but
I'm not going to try.
Like, if you have a map over something with, I don't know, you don't know what the implementations of that are. There's maybe some side effect in terms of memory that you weren't expecting, or maybe there's some edge case that it doesn't handle, but it is. And in the JavaScript case, there are a million of them. There are, like, depending on how you count them, like 7, 8, 9 bitwise operators. It's
more like end, actually. Let's start.
All right, I'm going to go ahead and open it up for audience questions. Let's go here, Yakoslav.
Regarding your exponential type, have you ever tried comparing sorting performance on, let's say, millions of items versus just a regular array? Because I do those a lot, so.
No, I haven't tried comparing. We don't actually end up having to do any sorting because we're lucky enough that our input is already sorted.
Important distinction.
Yeah.
Okay.
I mean, there's maybe an edge case where, like, profiler style events come in that may be slightly out of order, but you're sorting like 6 elements rather than.
Oh, I will just.
You're just sorting.
Sorry. I will skip these writers. It's needless complexity.
a relatively frequent case in the timeline, for instance, is like we don't want to show all of the things that happened before the timeline. So we will binary search at the known start of the timeline, find the first value at that point, and then iterate from there on. Or there are places where we have multiple binary searches happening sequentially.
No question, just admiration. You casually dropped a full Andrew's Hacker's Delight and the contents of a data structure white paper, and just completely cool, no emotions, not even time for people to applaud. Just like, take this. Like, kudos. Hats off.
Thank you very much. That's very kind.
You need to get better at pausing for applause, like after every slide. You should just... Any more questions?
Will you be offended if I call them resorays?
No, I mean, no, but it's more characters, so like, do you really want that?
Well, RA, right? Or
Czar.
Czar.
Oh, just the RA, even shorter.
CZAR.
So you made a point of evangelizing for stable pointers at one point. Is there ever a time where you care about like keeping a pointer stable across multiple lifetimes, like when it's deallocated and reallocated, or does that basically always mean you should expand the lifetime to merge both?
Do you have any particular examples?
Case where that would be something you'd care about, or whether you'd, yeah.
I guess the closest thing, I think we have memory that persists across between multiple lifetimes, or across multiple lifetimes, but not stable pointers to them. Let's think. I think the place where this might come up is to do with handling our run arena, because we don't want to give the memory back to Windows and then immediately ask for it again. So we want to keep that around. And so the pointer to that is from like a parent struct. So I guess in some abstract sense, there's like a run that hasn't happened yet. We're kind of between runs. And this pointer still exists, but I didn't really go into this, but you can kind of break down lifetime in multiple ways of like a value lifetime and a location lifetime and a memory lifetime, and like so the memory is still there and the base struct is still there, even if the thing that is conceptually referencing doesn't exist anymore. Yeah, I think that's where I come from with that.
The explanation array, like, super cool. I've never seen it. It's like a mix between a slab allocator and a binary tree in a flat array. But I just want to know, like,
This is not what I wanted. Maybe one. Let's try with one.
Can we...
Array mapped hash tries, right? Stuff like that.
Yeah, but those are now called ZARs.
No, well, those end up on trees.
Sorry?
Those end up as a tree of nodes.
Yeah. It's like it's arrays of arrays. They're exploited in the fact that we have powers of 2 where we do logarithms and stuff like that.
Yeah, they're like log based on path length rather than yeah. So I think there's like a log structured merge tree is a thing in databases that uses a kind of similar concept of doubling sizes, but for an entire tree at a time, and that. I forget the exact sequence, but that may have been an inspiration.
So I want a little bit of those rectangular joins.
I'd be interested to see if anyone's seen them kind of used.
Not necessarily everywhere.
Data structures in code before. I will have to come and chat to you afterwards.
I think it's worth mentioning there was like probably 6 different messages in the chat and the Twitch chat being like, oh my gosh, this is amazing. This is our thing. Oh, what is this? This is really interesting. So it's definitely a very interesting data structure people are excited for. What do you think is the applicability for your own programs after Whitebox or other people's programs? Do you think it is a general purpose data structure for a large set, or is it like, where's the boundaries there?
Automat just stole my mouse.
Yeah, like what kind of things?
It started moving it to infinity.
So I obviously showed that within a single tree of types, but having introduced the idea.
So what is happening now is that my mouse is accelerating at the speed of light towards the upper right corner of the screen. I have no idea where it is. I definitely cannot move it.
Header size, and then all of the blocks being pushed.
You just confused the X server. Even the X server has no idea what's happening.
You can have the header on the stack, and then have some scratch point to an arena, push strings, push arrays, ZARs, and then once you're done with the, and you can the important thing here is that you can interleave pushing onto multiple virtual arrays at once, and then pop back at the end, and they're, it's as if they never existed. So keeping that.
It would be nice if it crashed now.
And the pitfalls of them. One of them is the same as any other. Actually, before that. So one way of thinking about them is as a generalization of regular slices, where a slice would be number and pointer, and this is just number and pointer, 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 pointer. The pitfall is true with kind of any chunked data structure, where you can, if you interleave pushing some stuff, and then you take another scratch point on your arena, push more things, you may add another chunk onto your ZAR or other chunked array-like thing. And then when you pop back, you now have a ZAR in a partially valid state. So you've got.
Now I'm listening to the questions and answers like it's a podcast.
Will occur legally, and accessing that.
I mean, Automat shouldn't crash in a moment. It cannot run like that.
To be careful of.
I guess.
I think that is, as far as I can see,
something will run out, like memory.
Unavoidable in the case of trying to have stable chunk arrays of any sort. And once you know to watch out for it, you can do things like, I mean, ASAN is an obvious example. You can poison the end of your arena, and so accessing it is immediately shows up loudly. And then the other cost to them is you have 20 pointers or however many pointers. Now you can. The nice thing about that is that you can, you only have to add, if you add 3 more pointers, you've octupled the size of your array. And, it's pretty easy to convince yourself that that is sufficient for uses. But if you end up with a really large number of otherwise small data structures that refer to a typically small number of things, but occasionally it's large, then you end up with quite a large overhead of.
I know what I can do. I can access my PC with SSH and kill Automat remotely.
One of the other options in those cases, you could move back to the general case. I think the most general thing is possibly the tree case, but there's various options that we went over that you could think through for your problem.
Yes.
They kind of exist in reference in a blog post from the machinery guys. Rest in peace.
Well, they're gone now, so.
Yeah, but they don't end up going with them. They kind of think about them and say, "Nah, we'll do something else."
Yeah, I think I know the article you're referencing there. Yeah.
I don't think they realized that the number of pointers you need to keep is bounded.
Yeah, I think that was an important thing. Yeah, like what made it worth like moving, because if you have to have that extra pointer in direction, it's like, yeah, I don't know, is that really worth it? But the fact that it's that relatively small bound makes it quite convenient to keep, you have this single array structure.
Yeah, they suggest keeping the pointers in the dynamic array, and I don't think you would suggest that if you realize, oh wait, I only need this many.
Yeah.
Yeah, the thing I was thinking of is doing that too.
Cool.
So it is normal.
To some extent.
I cannot find Automat on my process list.
We want to cut off at a specific time. All right. So one of the things I learned a lot from your talk, or when I originally saw it especially, was...
Keep asking.
Yeah, this idea of parameter space, and especially how you deal with holes, right? So oftentimes when I'm trying to make a system, I really want that system to be clean and like kind of perfect in a way, right? So when I come across a hole where it's like this combination of parameters, that's not defined. That seems weird. I must be doing something wrong. Yeah, I guess, how did you come across that concept? So you essentially advocate for, like, the holes can be fine, actually, right? So you do this with your 10 byte float, and even though it technically is a slightly unbalanced parameter tree, it's more useful to have a consistent parameter space that you can talk about stuff with a whole extra thing on top.
Yes. Now, I guess the reason that I think that is because I was already on Team Megastruct. And then, like, I listened to some array programming people talk about what they're doing with their different dimensions, and the fact that all of their arrays are rectangular, and they talk about having holes, but how it doesn't matter. Like the real benefit comes from having this simple and consistent mapping for things, and a simple and consistent identity. And then the connection between those, I know I mentioned all these different things, and it may have seemed somewhat random to bring up array programming and functional programming, but the notion of the product type, once you're familiar with the fact that a product type, like a struct, is a product type, and that's just the fact that it's referencing effectively these different dimensions, then that kind of clicked in, making the link between these two things.
I'm continuing to try to kill Automat somehow.
The first element of your XOR has to be 2, like, because I know that means like it's gonna be a power of 2 together.
Cursor. I can kill cursor.
-1 as like your size. How bad is that? Like, does that mess up like your entire like get function or something?
So how important is it that it's a power of 2, or how important is it that it's exactly 2?
The entire array.
Okay.
Because I saw like your first element is also going to be 2 elements instead of being 1, 2, 4, 2, 2, 4. I know that results into an array size of like power of 2 instead of like power of 1. And how important is that?
Okay, so they don't have to be just 2. That was just for the to keep it small on the slide.
I found it.
The way I have my implementation is the first is always a power of 2. So commonly, like a shift of 6.
I think I may have broke the X server.
Now, on the context or on the question of non-power of 2 base sizes, part of the answer to that is like you get some of the benefit of this non-power of 2 thing by distinguishing between the size of the element as just an any size that doesn't have to be a power of 2 anything, and the number of elements being a power of 2, because it means that you can treat indices as powers of 2, but not it doesn't have to be a power of 2 offset into the array. No, there's the problem is I think determining which chunk things are in, and if you have non-powers of 2, it becomes, you have to do like a log operator or some other trick that probably, I'm pretty sure there are tricks that exist in Hackers Delight for like integer logs. So you could probably use one of those if you can find one. Computers are like doing things with powers of 2, so.
I was just thinking about like binary searching stuff, and I was. Anyways.
Another downside with these data structures is that they're slightly awkward to take sub-slices of. And so the kind of naive option there is to do just like a pointer to the thing, or just copy all of the size and the pointers, and then have a begin and end offset. I did work out the implementation of a kind of general sliced version of this, where the first chunk is variably sized. And as far as I can tell, that would work, and it works.
One of the objectives achieved. A rare thing.
You have to treat 0 as a special case anyway. But in practice, I haven't used them once since implementing it. Your mileage may vary.
One of the quotes in the talk that I felt like you should pause and wait for applause. You said something to the effect of byte first thinking wins over type-based thinking. And I believe this is in the context of what I would try to describe as like C-style generics, but then you also do this parameter space packing, and then that makes the calling convention much better, and like all these things come together, right? Do you mind explaining like that quote a little bit more?
I guess one avenue you can go down with that is borrowing some complexities of the C memory model. The bytes are an actual base reality. They're there, and they have some bit pattern in them, and you can interpret that bit pattern in whatever way you'd like. The types are an artificial construct on top of that helps us think about them and helps us catch silly mistakes. And while they're useful, they're not the concrete thing that are there. And so if you can think about things like, if you can think about what's actually there, then you have a good chance of being able to work out something you can do with that.
Do we have any more questions from the audience? I have let's go, Masha.
It's not a real question. I'm sorry. So the very last slide you had was marked as 100 and the third one, but it was also written that you have like 111. Is there a secret ending? And can we unlock that?
Would you like to see the deleted scenes?
We would like to see the deleted scenes.
Okay.
We're doing deleted scenes now.
Well, yeah, but I mean, we can continue. In my mind,
we're doing an encore. We're continuing. No, we'll go back and sit down.
We're going to the post-credit scene. Okay.
About
these are.
we'll keep this around. You want to take some notes about the stuff that we'll do next stream.
High level. Okay, first is.
This is done. We have a better widget. Sweet.
Thank you.
We could improve it further.
I actually lost count. However many parts this is. Again, I mentioned before, common thing you want to do, find some value in a lookup table. As a debugger, we have to deal with fast fail codes, and some of these are considered fatal, some of them are not. And the straightforward thing would be to pack these in an array of rules. And that would work, that would be fine. In fact, it's a complete non-issue. However, it's wasting 7/8 of the space, and it hurts my soul, and it's yeah. And there are like 76 of them or something, depending on which Windows platform you run. And the trick is realizing that all of the interesting ones happen under 63, and then you can pack, rather than, it's common to think of lookup tables as memory that you look at, but you can also think of those as just values that you look at.
And
you can kind of pack the values
Xserver, for instance, uses these techniques a lot for communicating with apps, to efficiently pack information into bit fields. And this is why people dislike Xorg, because it's using a lot of bit packing in its protocol.
It's possible to pack, you know, any number of, you know, you have a fixed number of bits to play with, and given that scale, how many different elements you have and how big each of those elements are within your like literal immediate value thing. So if we look at the basic version, we have bool array of all of these different values. You can index into them and get the value out. It's pretty common. And then we have the same, but kind of shifted into this immediate mode world. And like this is, if you haven't seen this before, this probably looks unfamiliar. But if you blur your eyes a little bit, it's quite similar to the array definition. You're shifting by the index into the array multiplied by the number of bits each value in the array takes. And then on that's replacing the value. And then on accessing the value, you right shift it so that those bits are the ones at the bottom, and then mask them off. And you can see that there's a relationship between the shift, the number of bits, and how you shift and how you mask. And then you can look at the
in terms of bit tricks, I can show you a cool one. I think
LEA, depending on exactly how it's being used, has a slightly different encoding, so you end up with a slightly differently sized thing. But you end up with 4 instructions that don't touch.
Release.
Touching instruction memory. And if you're thinking in terms of total memory, you end up with slightly less. Now,
there is an instruction in the x86, like a bunch of instructions that don't correspond to any C-level functions. They are primitive for the machine. They are executed in a single cycle. Those are very simple bit manipulation instructions.
Found is, and maybe it's just my own personal mental disorder.
We have them here.
It's with
bit twiddling.
When you have a small array that gets...
Sorry, maybe in lowering?
You have lots of these
small arrays. It's in twiddling.
And each individual one gets touched infrequently, so it won't be in cache, but you end up touching a lot on total.
So there are bit field extracts, right?
It kind of becomes worth...
Where you can...
I don't know. If I do it this way, it gives me a peace of mind, and it won't be in the memory.
I think this is pulling out specified bit indices and packing them into the output.
Even those 7 bytes.
I really like those instructions. There is a variant of this that clears this bit at the same time. So this is used for iterating through bit fields very fast. It's a single instruction that finds the least significant bit, clears it, and sets your value to this lowest index.
One generally preferring arithmetic-based code to like if condition-based code. And if you have the ability to think of your data in terms of these little
this one,
mini arrays,
BLSR, very weird instruction.
The kind of
but it's useful for iterating over tiny bit field arrays.
I have like these little teeny structs with two 2-bit members.
BSF, I think we've seen this in some of the assembly dumps in this presentation.
Move these structs into an array of 8 bits, and then I have an array of those, bytes, and then I have another array of those bytes. So this is accessing like the
And I can use
It's
different.
using, because it's a two-element array, it uses a bool as an index, and then you shift it by the index times whether or not you shift it by 4, and then you add on the shift of whether you want the first element in the struct or the second element in the struct.
Values.
And then shift it by that much and mask off the couple of values. I guess it helps in this case that both elements of the struct are the same size. What was this? Yeah, there was some kind of general recommendations around a little thinking about bit packing. Like, does it already, if you just put the value in some bits, does it already fit in those bits? If so, you're done. Does the maximum value minus the minimum value, does that range fit in your bits? If so, you can shift it by the minimum value and then reintroduce the minimum value on the way out. You can think of it rather than think of it as a range, you think of it as discrete values.
I have no idea what half of those instructions do, but for iterating through bit fields, I'm pretty sure this can be super efficient. It's like I++, but works on bit fields.
You can refer to any of them uniquely with 8 bits. And if, so then the simple version is you'd put that in an array, but there might be some pattern that you exploit so that you just get the value out immediately without having to touch memory, or you do the somewhat, you do the bitwise immediate array version thing, or you do some more like real compression style thing with, what is it? Arithmetic trees, I forget the precise terminology. If you want to know more about these things, Hacker's Delight is quite well known. HackMem is a PDF that goes around occasionally from like at least 50 years ago, but I forget exactly when. It's a little bit more kind of it's about solving the scientific problems rather than the direct kind of more immediate use of bitwise arithmetic that Hacker's Delight has. And then there's an HTML with the URL with a couple more things that probably also within one of the other ones. Okay. This is like one of the earlier slides, but this was blacked out before. It's just a nice simplification that if you have flags, you can you don't have to have a separate a separate enum for the non-shifted version of that flag to index into them, and then you can
what is this macro? MSB32?
Both set and get the value like directly in a way that is obvious how it relates to the original flag. And like I said, the Clang compiler will let you do this at compile time. The MSVC compiler will not, which is a shame. But this is an option if you want to do it on MSVC. Another option is just to have the non-shifted values beforehand for when you're setting the compile time. When you're setting the flag string index, and then like hidden in here is another use of this otherwise ridiculous array access. So each
a lot of those issues just go away if you switch to a different language.
Is the highest bit within a nibble, and then you can. It's the other case where you would use this slightly ridiculous array indexing is in compile time stuff where you can't access arrays, like actual arrays. And if you want to walk through that, I'm happy to go through that. And then a little trick is, like I said, and as you knew, most significant bit is undefined when you get a value of 0. There are reasonable ways that you can wrap that so that you get -1, I think someone mentioned, as the end result. But typically, I just have it as the bare version.
Oh yeah, TTS is down because I think I killed it when I was trying to shut down Automat.
Up in a situation, like in my earlier code, where the first thing and the second thing, like the 0th thing and the first thing are handled in the same way. And if that is the case, then you can do this like X or 1 trick. And so if it was 0, then it becomes 1, and then the most significant bit is 0. If it was 1 already, then it stays the same. And if it was a higher bit was set, then this is a no-op, and you just still get the higher bit set. I think that is all of the deleted scenes. Yeah. There you go.
Another round of applause.
So there will be one more presentation after this. I think there was one in
Do you have a limit of how many
the
questions
program.
This is
Or
an
maybe
easy
the
one, actually.
person doing the
Do you
presentation is
think
not going to
using
show up.
Something like Arc would go a long way, or help you in any way. I believe that.
Anyway, I will not be here for the next presentation. So next stream, we are doing something similar to what we've done for the mouse, but
immediate mode UI Arc UI.
That arc of the many arcs, yeah.
Let's
So
do
I called
very short
some of that,
macro.
On stream, but I was not here because I have a problem with my cache eviction strategy in my head, and so if I'd come to the talks earlier, then I wouldn't have been able to run these for my own. So I have glimpsed it, but not seen the details. It's very possible. I'm kind of using.
So this is Automat moving around its window.
And it causes some friction, and it at some point does need a new UI.
And this is our
Are there particular like wish list
radar
you want
display.
behind GUI, or if you were to use another framework, you would like something that does X.
Okay, so we will do something similar on the track next time. Okay, see you then. Bye bye.
It's not
to stop it now.
set up directly for exactly how
Bye.
I want it.